see there's a little less people today than yesterday. Maybe the bar open was not so good in the end. There are still some places in the front. That's where you'll see the best. So we advise people to come closer to me. Just a quick reminder that COVID is still something that exists. We had 2 incidents today. So one of the speakers is going to be remote because she caught COVID last week. And another one got a visa delay because of that is COVID related. So 2 of the talks will be streamed. That's unfortunate, but still, I guess the content is the same and you can still feel the energy through those giant screens. Can I have the slides, please? I'm just gonna do a little quick announcements and reminders. So the schedule is available online. That's where you'll find all the information and it's being updated. Today we have an AppSec block, that's what we're starting with. We have a cryptography block after that, and then we'll end with a red team block. One of the talk is canceled, red team tradecraft, because of COVID also. I just realized that my spacing is a little bit sketchy and that's really shameful of me. We also have the community room. So I don't know if everyone went there and explored. There's a lot of things there. It's downstairs in Salle de la Commune Hall. You have to go down the stairs and there's a lot of activities. It's a bit chaotic, noisy. It's awesome. In there we have an amateur radio club. Go and talk to them. That's super interesting. It's an old technology, but that's still super relevant today. We also have a Flipper Zero meetup. If you don't know what Flipper Zero is, I advise that you Google that thing and order it. It's really awesome. It's like a portable universal hacking tool. It's really awesome. We also have soldering on the NorthSec badge, so you can there are lights on that if you didn't know, and you can light them up if you go downstairs. We will also have a NorthSec Legacy Swag giveaway table. So we'll have a table packed with old, well, they're not old, they're still new because nobody wore them, but they're legacy swag that we kept, and you can now take all of it. It's gonna be during the day downstairs. And we also have 2 workshops. One is reverse and bypass of modern Android runtime protections. That's gonna be in the, I think it's in the I don't remember exactly, so you can see on the schedule, that's why the link is there. And then we have advanced process injection technique, which is virtual, and the Zoom link will be posted on Discord. We will also do something a bit special. There's a book raffle. So downstairs in the community room, there's a reading corner with more than 100 hacking and tech books. We're gonna give them all away. And in order to do that, we'll pass tickets to people that are interested. And after the last conference, so it's around 5:36, people can go downstairs and we'll give all of those books away so you can become more intelligent after reading those books. I guess you're already pretty intelligent, but more knowledgeable. And just a quick reminder for those that are interested, tomorrow there's a black light party at the CTF. Everyone with a conference ticket is welcome to join. It's gonna be around 10. There's gonna be a Hacker Joe party, which is really awesome if you've never saw that. It's gonna be in this room. It's gonna be followed by a black light party. We'll have glow in the dark drinks. It's gonna be really great. The rooms, we are right now in Salle Ville-Marie. There's a ballroom where the workshops are and the CTF is. It's on the other side of the little bridge. And then De La Commune Hall is downstairs. That's where the community room is. Just a quick reminder of the code of conduct. That's really important. Be friendly and welcoming, of course. Be patient and constructive. Sometimes things are noisy. People might be intoxicated. Don't be intoxicated. Be respectful and collaborative. That's the purpose of NorthSec is for people to being able to collaborate and share information. Be responsible. If there's any emergency, please contact us. We have a report at nsec.io email, and you can use Discord. NSEC staff and NSEC moderators are us, and otherwise anyone with a pale blue t-shirt or me. I don't have a pale blue t-shirt, but you can still come to me if there's anything, and we'll do what's needed to help you. A big thanks again to all our sponsors. You're gonna see them throughout the event. They all provide something to the event. As I said yesterday, we don't take free money. We only take involvement in the event. So without further ado, I will pass the mic to Guillaume from KPMG, who has a little something to say. Thank you.
Hello. Bonjour tout le monde. Hi everyone. Thank you to be here. Thank you for the NorthSec folks. You organized again this year a very great event. We miss you guys. You know, since 2 years it was a little bit boring, and I couldn't go to you know, I saw the setup here and the investment of time and effort to make it pretty, very nice. KPMG is a proud sponsor of this event. It's been many years now that we come to this event. We recruit a lot of good talents throughout the years, and we still gonna encourage this event for the following years. My name is Guillaume Clément. I manage a wonderful team at KPMG, division specialized in, I would say, technical cybersecurity. About 140 colleagues, one of the greatest teams in Canada. And I wanted to say a few words today around how cybersecurity changed in the last 20 years. I don't want to go back far away, but for the ones who knows, not a long time ago, we were doing cybersecurity and selling cybersecurity based on, you know, potential scenarios. Yes, there was events here and there. We had the virus and worm events in 2000s, and you know, there was a credit card data breaches in 2013, 14. They were, you know, there was cyber attacks here and there, but not like we had recently in the past 3-4 years. Then, you know, cybersecurity was hard to sell. We were basing our recommendations and work on, you know, risk scenarios, and you know, we were an expense, and we were kind of the first cut in the budgets, you know. And the sales cycle, you know, when I was selling this a few years ago, when the 2000s was the worst, but even almost like 5, 6, 7 years ago, the sales cycles in Canada was about sometimes a year. Okay, now it's kind of sometimes a week. You know, it's totally different. And why is that? It's because, you know, the recent attack surge that we had the past 3-4 years gave us some facts and real examples, real life examples of what the impacts are. Okay, if you don't invest in cybersecurity. And now we were an expense not so long ago, and now we bring value, and we're kind of becoming an asset for organization. And our role is very important. And that's what I try to say to my colleagues and everyone. You know, we're not just there to do a work, we're there to sometimes save organizations. And we can be proud of this. You know, it's an important job, an important domain, and either you are a student, a researcher, professionals, vendor, a firm, you know, we are kind of becoming more and more important in that economy and any industries. Then, you know, and I think that the future is great for us. I think the advantage we have, I think the business will be good, and we're gonna have jobs when the economy is good. But even if there's some economic crashes or anything like that, no, criminality go up, and we're still going to be important. Then, you know, I think future is good, and I mean your role is more and more important, and let's keep going. That's it. I'm gonna make my team, because they told me just before that I can extend my speech because they had some technical issues. But at the end, I think it's fixed then, because they always say that I take a lot longer than I'm supposed to then. Yeah.
Thank you, Guillaume. Yeah, don't worry, it wasn't too long. All right, so we're gonna kickstart things right now with the AppSec block. So I'm going to present you your moderator for this block. She's Joëlle Alexandra Desmarais. She's been involved in the NorthSec community for a few years now. She now works as a security director, implementing security practices from the ground up in a fintech startup disrupting the mortgage market. So please welcome her with all your applause with me. And I'll give it to Alexandre.
Hi everyone. As Hugo said, merci Hugo. My name is Joël Alexandra, but you can call me Joël. Today I'll be your moderator. Some of the talk, like Serge mentioned, are online. Some of them are live, which I think is going to be pretty fun. And we'll have a small Q&A at the end. Well, it's going to be hybrid as well. So our first presenter that we're very happy to present here today is Vickie Li. If you don't know her, she's an experienced web developer with an avid interest in security research. She's author of a book, which I think that's the topic of the talk today. You can also find her on different platforms. She's on YouTube. She has a pretty successful channel where she simplified security. That's why it's called Security Simplified. And she also have a blog. It's called Vickie.dev, where she talks about security, new techniques, and latest bug bounty findings. So please welcome me with applause for Vickie Li. Merci.
Hi, is there sound now? Okay, awesome. Thank you so much for the intro. And hi everyone, welcome to this the first talk of the second day of NorthSec. I'm super bummed that I'm not able to join you guys at the event today and meet y'all. I'm actually currently under COVID quarantine at the moment, but still, thank you guys so much for the opportunity to present this talk remotely. Let me start sharing my screen. One moment, please. Can you all see my screen right now? Okay, awesome. So, hi everyone, and welcome to. I thought writing a tech book was supposed to be fun. My name is Vickie Li, and I am the author of Bug Bounty Bootcamp, which is a book that helps beginners learn web security and get into bug bounty hunting. And also, I write a security blog online, and I also work as a technical writer for multiple cybersecurity firms, doing things like documentation, tutorials, and corporate blogs for a really long time. And the topic for today's talk is, how do you write better technical content more efficiently? Right? I think as security professionals, we've probably all had the experience where we need to write some sort of technical document, right? Sometimes it comes in the form of reports from pen testing engagements, or sometimes it's some sort of documentation that you need to write to document the tools that you've developed, right? So in this session, I'd like to first talk a little bit about the strategy that helps me write better technical articles more efficiently. And then, so I'll talk about things like how to write better documentation, better guides, and better tutorials. And then I'm going to go into how to write approachable and appealing blog posts online, and how you can optimize for that experience if you do want to start a technical blog of your own. And then finally, I'm going to go just a little bit into the process of writing a book. And if you do want to write and publish a book, what do you have to do, and what kind of key decisions would you have to make? So I started writing technical content when I was trying to transition from development into security. I tried to learn bug bounty hunting as a way to learn more about web security. And what I would do is that I would go onto HackerOne and find all of these disclosed vulnerabilities online and look at the vulnerabilities that they reference and try to learn about them. And I start spending a lot of time reading these reports and learning about the vulnerabilities. For each vulnerability I want to learn about, I would search online for information, right? I would do tons of Google searches about SQL injection and read all the articles that come back in my Google search. And what I found was that there was tons and tons of content online at that time to learn about web security, right? But a lot of the times, these blog posts only mention one or two very limited aspects of that topic, or sometimes these articles can be sort of outdated or misleading in some way, right? So it's really, really hard to learn everything about a single topic as a beginner because it's really hard to get the big picture or the comprehensive view because there's no such resource online for beginners in that way. Like take SQL injection, for example, it often takes like 10 to 20 Google searches and reading every single article that comes back from these searches just to understand the big picture of how it all works and what someone can do with it. So I started to do a lot of research by myself, organizing, fact-checking, and curating the information myself. And with all that Googling and organization, I started to accumulate a lot of notes that turned into a large repository of knowledge about web security that I accumulated while I was learning myself. So I thought, hey, I can turn this research and this content curation I've done for myself into a book so I can expedite the learning process for others. And this is why I started writing Bug Bounty Bootcamp. And the expectation before I started the book was sort of like, this is going to be an easy side project, and I'm going to be done with this project within 6 months of working on the weekends. I was very innocent. The reality was that it took me nearly 2 years and over 40 hours per week of work to complete the entire book. So it was a giant, massive undertaking that I didn't expect. But no regrets, because I feel like I've learned a lot about web security in the process. I had a lot of fun, and I met a lot of interesting people because a lot of people in the security industry actually started reaching out to me once my book was announced. And I also really love the process of technical writing because it's a way of sharing knowledge. And you can share what you've learned and really use that to expedite the learning process for others without ever meeting them in person. I've had people reach out to me saying that Bug Bounty can help them learn web security for themselves and start hunting for bug bounty themselves. So I encourage most security folks to give technical writing a try because it's a great way of clarifying your own thoughts and helping yourself learn and understand a concept more deeply, and also participate in this sort of indirect mentorship and knowledge sharing using the time that you've already invested in research. But the one caveat is that writing is really, really difficult, right? Writing is really a specialist skill that a lot of the time are not taught to us either when we're in college studying some sort of technical topic or on our jobs, right? There's no really any formal training program that we can take on writing. And it's one thing to produce documentation and notes that you can understand yourself, but it's a lot more difficult to write something that can be used and understood by other people. So in this talk, I want to talk about how I make this process easier for myself and how you can optimize your technical writing process to produce better, more understandable technical content more efficiently. So I think writing is way easier. Technical writing in particular is way easier if you break it down into 3 distinct steps: research and outlining, content dumping, and editing. So let's get started with the first step, research and outlining. This is where you're figuring out what information to include in your article, what information to not include, what sequence to introduce concepts in, and what structure of writing would be the best to present your information at hand. So I will first do research on the topic. I try to find out everything I can about the topic, right? Even if I'm already familiar with what I'm trying to write about, I try to read as much documentation, blog posts, write-ups, and books about a technology, and just in general, collect as much information about a subject as possible, just in case I'm missing some aspect of the topic or that I want to enrich some parts of my article, right? I will make detailed notes during this process and organize the information I found. I also fact check everything I read about and test out all the payload and all the code to make sure that they all work. And it's really, really important to do all of this research prior to starting to write, because it helps you get the full picture of what you're writing about. And it also helps you with planning and thinking about how you can structure the content and best present this content to your reader. After research, you can slowly, well, even during research, you can slowly start listing out the topics that you want to talk about and try to think about what a logical progression would be for your article. And this is where you get your first draft of outline. So here you can see that, let's say that we are writing an article that teaches developers what SQL injections are and how they can prevent it. You can start to list out the different things that you want to include in the article, such as how SQL queries work and how that leads to SQL injections. What are some types of SQL injection vulnerabilities? And perhaps include some real life examples of SQL injections that you've seen. And then include a section on how to prevent SQL injections. And it's important to remember that outlines, just like articles, they go through multiple drafts. And this outline can be changed and refined as you do more research or as you start writing. And this step often takes lots and lots of times, right? And I often find myself changing the outline and the structure of an article later in the writing process or the research process. So for example, you can add subtopics to refine the points that you want to touch on, or you can delete something that you think is too much for this article and perhaps move it to a subsequent article, or even break everything that you want to talk about down into a series. So here you can see that I added some points to my outline, and the outline is really becoming more detailed and is starting to provide you with a concrete direction for what you want to write about, right? So you can see here that in the prevention section, we added parameterization so that you know that you're going to have to touch on that point when you are writing that part of the article. And most planning of the article should really be done at this stage before you start writing, because this is where you'll be deciding exactly what to present to the reader and how. And outlining and planning the article in advance this way will really help you write a more coherent article and make sure that you're not missing any important point that might be important for your reader to know. And once you have your outline ready, you can start going through your outline and filling out all the relevant information you have for each outline item. I call this my content dumping phase. I typically will have my notes from my research phase by my side, and then I'll start translating the concepts that I've learned during the research phase into plain spoken English. So think about how you would explain a concept like SQL injection to your friends, and start dumping out whatever thoughts you have into either a text editor or on paper, if that's how you prefer to write. And all you're doing at this point is dumping content out, right? A very, very important thing to remember at this point is not to edit yourself when you're writing. I think a big tip about writer's block is that a lot of times when people feel like, oh, they can't figure out what to write or they can't put anything on paper is because it's caused by inhibition and the fear of their words not coming out right. So you don't want to censor yourself at this point. Simply capture all your thoughts that you want to express and don't worry about styling or grammar or even typos or anything that would affect the reader's experience. Those can all come later in the process, and it's very, very important to compartmentalize writing and editing because you'll be able to write much more freely. All you're doing right now is to say everything you want to say about a topic and make sure you have all the content down onto paper or a text editor. But this also means that your first draft would probably be absolutely trash. Like my first draft, 100% of the times, is not something I want to present to my reader, right? That's where editing comes into play. But we can talk a little bit about that later. Here you can see that we have an outline here from our previous step, and we can simply pick one item in the outline. It doesn't have to be, you don't have to work on every single item in the outline like one by one. You can also skip to a certain outline item if you feel like it and start filling out information that you feel like is relevant for the reader at that point. And after you have the baseline of technical content ready, the next step is to ensure that your article is something that you can present to your reader, right? And that's when editing comes into play. And for editing, I typically do 3 types of editing in sequence. So I first go through a technical edit, and then I do what I call a common knowledge edit, and then finally copy edit. For the technical editing phase, this step is to ensure that both your text and your messages and your images and your diagrams are technically correct and don't contain any mistakes. And besides blatant technical mistakes, you should also look for things like technical holes in the content. Are there anything that you fail to explain? Are there any logical jumps in the article? Or do you have anything that you need to rearrange to make it easier to read? Or is there something that could use more explanation or reference to another resource? And after you do a technical edit, the next step is what I call the common knowledge edit. And this is really the phase where you will try to optimize your article for the reader's experience. So in this phase, I try to read my writing as my target reader, as someone with no prior knowledge about my topic, and is instead equipped with the common knowledge for my target audience. So for example, if I am writing a security code review article for developers, I can probably assume that my readers already understand concepts like HTTP, cookies, encryption, but I shouldn't assume that they already know about how to conduct a security code review. And at this point, the technical content of your article is fixed. The next thing to do is to refine the words and sentences. So everything that we skipped during the last phase. So you can start deleting the content that don't add any meaning or clarity to your article, or think of ways of phrasing each sentence or each word better. Just in general, clean up the language and make sure that the article flows and makes logical sense and that it's easy to read. And then finally, I run my article through a grammar checker and read my article out loud or in my mind as a final sanity check that the article indeed flows and doesn't contain any last-minute mistakes. So that's basically the process that I take and the strategy I use to optimize my technical writing process. But now that you have a good framework for writing technical documents efficiently, a lot of people tell me they want to start a technical blog. I think writing an internet blog is very different from how you produce other documents. While the principles of good writing still very much applies. You have to plan in advance, you have to read your article as the reader, and you have to do fact checks and grammar checks. But if you want to write an approachable and appealing tech blog, there are two more principles to keep in mind to optimize your experience for the online reader experience. So the first tip I have for you to write an approachable blog post that people will want to read is to simplify, and then the next one is to keep things short and sweet. And what do I mean by simplify, right? Good technical writing is always easy to read, but this is especially true when you're writing on the internet. Because on the internet, your technical blog post has the potential to be shared anywhere in the world, right? And you never know who will come across your content and what their background will be. And simplifying articles allow people like non-native speakers and novices to consume your article as well. And you want your content to be understood by the largest group of readers. And even if your readers don't have prior experience with your content and are indeed native English speakers, making your article simpler just makes it easier and faster to read by everyone. So try to use simple words and sentence structures whenever possible. And when you can explain something in one sentence, never use 10. Avoid things like jargon, abbreviation, acronyms, and obscure references, because a lot of the times these will not be common knowledge for every one of your readers. So here we have an example of me trying to explain SQL injections. And it says that SQL injection attacks are a type of malicious activity that enables dangerous attackers to craft malicious SQL code to change the structure of a victim application SQL queries illicitly, to steal sensitive data, modify confidential data, or potentially execute arbitrary commands in the underlying operating system. And you can see that this is an extremely long sentence with a complex sentence structure and a lot of unnecessary adjectives. And all that does is that it takes away from my main message and makes it difficult to understand what I'm really trying to say in this sentence. So we can instead rewrite the sentence as SQL injections allow attacker code to change the structure of an application's SQL queries to steal data, modify data, or potentially execute arbitrary commands in the underlying operating system. And you can see that the sentence is a lot shorter and more to the point. And as compared to the last sentence, it actually doesn't take away any meaning from the actual sentence itself. So this is how you simplify a sentence, right? And I know sometimes it's difficult to figure out how to simplify a sentence or a paragraph. And a good rule of thumb that I use is to delete every single thing in a sentence or in a paragraph that doesn't help you illustrate or clarify the message that you're trying to convey. So as you go through your sentence or your entire article, you want to look at each component and really question yourself, does this really help me say what I want to say? Or is this just fluff? Or does this even detract from my message that I'm trying to convey in the article? Another thing to keep in mind is that when writing for the internet, it's very, very important to keep things short and sweet and to divide things up into chunks. So writing a blog post, it sounds like writing a research paper or a report, because the way that people consume information on the internet is different. When people are reading your blog post, they might scan the entire article for headers before committing time to reading it. I know I do that a lot. And they might also be browsing Twitter or checking their phones at the same time while they're reading your article. Or they might be reading your article on the tiny, tiny smartphone screen, right? It's very different from the traditional reading from a paper or even reading an entire PDF on your laptop. So when you're writing internet content, it's very, very important to optimize for a digital experience. So part of that is to divide your article up into easily digestible chunks. Ensure that each section is marked with appropriate headers and subheaders. And this makes it easier for your readers to jump to different sections of your article if they do get distracted, and to just in general revisit different sections that they're interested in, or share or reference different parts of their article with people online. Also try to keep things short and to the point to make your article more digestible during a short time frame. So if you're covering multiple topics in a blog post, you should consider chunking it up into multiple sections with headers and subheaders ready, so that people can quickly skip to the parts that they're interested in. And another rule of thumb I use when I am deciding how to divide things up in my article is one idea per sentence and one concept per paragraph. So I'll only try to say one thing per sentence, and I also only try to explain one concept per paragraph. Don't try to say too much in one go. Keep your sentences short. If your sentence is getting too long, then you can divide it up into 2 sentences. If your paragraph is too long, break it down into multiple sections. And finally, if your blog post is getting too long as in more than 5 minutes of reading, which is approximately 1,500 words, consider making your blog post into a series of blog posts instead of stuffing everything into one single article. Because we probably all know people don't really have that long of an attention span on the internet. So it's important to make your article feel like it's easily digestible and very quickly readable. Short sentences and paragraphs also make your article much easier to read when people are using mobile devices if they don't have that big of a screen to work with. And I think, so those are my tips for you for optimizing for the internet. But now that you understand how to write technical content, what if you want to write a technical book, right? There's a lot that goes into writing and publishing a technical book that's not just writing, but business and marketing decisions. And it's really a long and complicated process. In this presentation, I want to present with you a small overview of the process. I won't be able to go too much into it, but if you're really, really interested in writing and publishing a technical book and my experience doing it, feel free to reach out to me after the talk or via Twitter, and I'll be happy to answer any of your questions. So this is what I think the overall process of writing a technical book would be like. Of course, this process will be different for every single author, but this is what I think most authors would need to do. Some parts of the process is like we just discussed, like you have to research your content, you'll have to structure and write the book, you have to work on the text, the diagrams, the code examples, and you have to work with multiple editors through multiple edits to make sure that your book is technically correct. But a lot of other decisions and processes that goes into writing a book doesn't really relate to the writing itself. Things like choosing a publisher or deciding how to package and market the book. These are, I think, what traditionally we don't consider when we're writing blog posts or technical articles. And so I'd like to just quickly go through 2 key decisions that you'll also have to make that would impact your book writing experience a lot. And the first key decision that you have to make is deciding on the scope and the audience of the book. So with blog articles, you're most often just writing about a single topic at a time, right? But writing a book is different. When you're producing like a 300-page book or a 400-page book, it's more like designing a college course or a curriculum. So you really need to think about who should read it and what they should get out of it. So a good strategy of doing that is to define broad but clear learning goals for a specific audience. So you can say things like, I'm writing a book to help beginners how to find their first bug, or I'm writing a book to help Python developers build dedicated security tools using Python. So defining these broad but clear learning goals will help you really decide what topics to include, what kind of prerequisites you need to require for your book, and how fast and with how much detail should you introduce concepts in the book. And another key decision that you have to make very early on in the process is whether you want to use a publisher or not. Publishers usually help you with things like book editing, and they coordinate things like printing, shipping, and making sure that your book hits different sales channels. And they also help with some marketing and some PR tasks. And you don't have to use a publisher if you do decide to publish a book. A lot of people choose to self-publish with great success as well. But the pros of self-publishing is that you get to do whatever you want with your book, right? Publishers sometimes have certain styling or writing standards that they stick with. If you self-publish, you are in complete control of your book. And you also get to keep more of the profits. Usually when you work with a publisher, you'll get anywhere between 5 to 20% of the proceeds. If you self-publish, you'll probably see more of that income. But working with a publisher means that a lot of the messy task of making a book is done for you. Right? Things like finding the right editors, the right illustrators, making art, and dealing with marketing tasks. These can be very tedious and really probably not in most technical people's expertise. So it just makes things easier if you do decide to outsource that to a publisher. So it's really, you know, a trade-off of what you want from your book writing experience. And lastly, which publisher should you choose, right? There are quite a few publishers that specialize in tech. And I honestly have to say that they are quite different in the way that how they work with authors or how they edit books and how they draft their contracts. I'll be happy to talk more about it in person. So just reach out to me if you're interested in that. So to wrap up, technical writing is a great way to help you learn faster, learn more deeply, and help you share knowledge back to the community and mentor others. And a few takeaways that will help you write better technical articles more efficiently is first to write with simple language, right? You want to write as though you are speaking to really make the reading process a smooth and easy one for the reader. Second is don't write and edit at the same time. When you write and edit at the same time, a lot of the times you're censoring yourself and you're filling yourself with inhibition and fear of your words not coming out right. So if you can compartmentalize these two tasks, a lot of the times you'll be able to produce a lot more content more quickly. The third one is that you should always keep your reader in mind and really optimize for their experience when you're writing your article. Thanks, and please ask any questions in Slido, and if you have any private questions about this talk, either about writing, about publishing, about blogging, feel free to DM me as well on Twitter.
All right, thank you, Vickie. So we're already running a little bit late, so we'll take a 2-minute break before our next talk. So see you in 2 minutes. So I see a lot more people in the room, so that's pretty cool. Welcome, everyone. So for the second talk, can we see? Ah, hi. All right. Hi. So we have here Abhay Bhargav. He's the founder of We45 and chief research officer at AppSec Engineering. He's focusing, of course, on AppSec. Abhay is a builder and breaker of application. He's the chief architect of Orchestron, a leading application vulnerability correlation orchestration framework. He has created some pioneer works in the area of DevSecOps and AppSec automation, including the world first hands-on training program of DevSecOps, focused on application security automation. Abhay is a speaker and trainer at major industry events, including DevCon, Black Hat, OAPS, and AppSec Cali. And yeah, so please join me in welcoming Abhay for his talk today, and we'll be right with you after this.
Thank you. Thank you so much. Thank you for the introduction. I really wish I could have been there in person, but unfortunately, travel is still a little elusive, at least to Canada at this point in time. Nevertheless, I'm really happy to be here. This is my first ever talk at NorthSec, and I'm really looking forward to it. I'm looking forward to hearing, getting some questions and comments on the talk that I have as well. So I'm going to quickly get to it because I have 30 minutes and I don't have too much time, and my talk is loaded with a lot of content. So I'm going to quickly start sharing my screen. I'm guessing everyone is able to see my screen. Yeah. Okay. Sorry about that. I think you're. Yeah, I'm presenting from one screen, so this is unlike probably most speakers who are going to be doing it remote. I'm just going to start my slide deck and I'm going to get started. All right. So this talk actually is a culmination of a bunch of research efforts from 2021 that is now being showcased all over. So this is called Hook, Line, and Sinker Pillaging API Webhooks. Now, webhooks are something that a lot of us use, and I'm sure members of this audience as well are quite familiar with what webhooks are. We're going to quickly get into what it is and how it works and all of that stuff, and then I'm going to be looking at attacking it and some case studies around how we actually went about this particular piece of research. So just a quick introduction. My name is Abhay. I work for a company called We45, and I'm also the Chief Research Officer of AppSec Engineer. We run a training platform on AppSec, cloud security, Kubernetes, and so on. I do a lot of training. I do a lot of talking. I do a lot of research on mostly defensive stuff. So this talk actually is a departure from my typical style of talks, which is way more defensive than offensive. So most of my research is defensive, but in this case, the talk I'm going to be focusing on is explicitly offensive. So I'm going to get started with it. If you're interested, we have a very interesting YouTube channel where you can check out a lot of interesting stuff on AppSec and so on. And if you want to check out my blog, that's there as well. I highly encourage you ask your questions on Twitter because I am currently suffering from a back injury and I'm not going to be there for a Q&A session on the NorthSec channel. So if you want to ask questions, please reach out to me on Twitter. I'm going to respond. I'm barely holding it together, sitting and talking right now. I'm just on a lot of pain meds. So that's, I just wanted to let you know that if you want Q&A, please reach out to me on Twitter. That's the best way that I can respond to you. All right. So my talk today is going to be full of memes. I'm sure, I'm not sure how many presenters use memes in NorthSec, but my talk is going to be nauseatingly full of memes. And I have one live demo as well. So I am going to have to pray to the demo god. And I'm going to have to ask all of you to pray to the demo gods on my behalf so that everything works, because live demos as they go, a lot of things can go really, really wrong. So I'm hoping that everything goes pretty well. I did test it before I just started, but things can go wrong every single time. So you never really know. Anyway, today's agenda is going to be pretty quickly. What are webhooks? How do they work? We're going to get into this pretty quickly. I have 30 minutes, so I'm not going to take too much time in the explanatory segments. We're going to be looking at some common webhook attack patterns, and this attack is not in the common webhook attack pattern. So the attack that I'm going to be referring to in this specific presentation is not a very commonly seen attack, but I think it has the potential to really explode on the scene. We've seen it explode on the scene, at least with the kind of bug bounty targets that we've been working with. It's really performed really well against a lot of these targets. We're going to do a quick introduction to SSRF because that's the underpinning of this. And SSRF, I'm sure a lot of you have heard of SSRF, probably do a lot of SSRF as part of your offensive work, or even do defend against SSRF, in which case I pity you. But nevertheless, SSRF is something that we're going to be focusing on. This talk is a lot about SSRF. We're going to look at SSRF. We're going to look at a new class of flaws that we dub webhook boomerang flaws. Now, these flaws have been there. They've been in and around, but they've not been as well exploited, I think, as they could have been. So this is where we're going to be talking about. This is the meat of the presentation, and then I'll talk about some subvariants and so on, right? So basically, when you are building an API, the first thought you have is interaction, right? You want to respond to events. And one of the big things when you're building an API is to respond to events. So when a new user is created, or when there's a new customer that signs up, or a new payment that comes in, or, blah, 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 whatever it is, you are typically dealing with events, right? APIs, especially with APIs, you have a lot of events that you want to deal with. And a lot of times, when you are dealing with events, you need webhooks because you need to post that event somewhere. So let us say I'm a new e-commerce, I'm a new e-commerce merchant, and I've set up a new site on whatever, and I'm using Stripe or Shopify or what have you. Now, in that case, the first thing that I'd like to know is, hey, when am I getting paid? Have I gotten this customer? When have I gotten this customer? So webhooks makes it a really, really powerful way for your API to start reacting to these events. So when a new customer is created, you can send a webhook to Slack and say that, hey, a new customer signed up, or you received payment of this. Webhooks make all of that possible, right? So I'm sure a lot of you have heard of webhooks. Most of you are probably dealing with webhooks on a day-to-day basis. Most of you are probably writing a lot of webhooks as well. Now, so webhooks basically are user-generated callbacks. So I set up a webhook. So I'm a user, and I set up something called a consumer. So I say that, whenever a new user is created on my e-commerce store, I want you to make a webhook request to my consumer app. So I've written this app somewhere here, and I want you to make a request to that. So with a particular JSON that says that this user with this email, with this whatever other information is signed up. So in a webhook transaction, there are typically two entities that are involved. One is the provider, which would be your Shopify or Stripe or what have you, any of these providers that are reacting to the events. And then there would be a consumer that would actually be receiving that event and saying that, and they're using it for processing whatever they need to process, right? So this is a very common setup that you have. So these are essentially user-generated callbacks, right? So that's how webhooks work. So in this case, we have a webhook setup. Whenever a new user is created, there is this event that is triggered that hits the consumer. The consumer app essentially uses that to maybe store it or send them an email or process it forward or whatever they need to do, right? So these are basically how webhooks work. Now, webhooks are literally everywhere, right? Now, you'll see webhooks in not only apps like Stripe and Zapier and Shopify and all of that jazz. You see this all over the place. You see this with Kubernetes. You see it with CI/CD systems. You see it with CI/CD systems. I would say use them extensively, right? Any kind of build systems or CI/CD tool use webhooks all over the place. Even basic, even apps that are related to marketing automation and so on use webhooks extensively. Anything that needs to integrate with a whole bunch of other applications, especially through event-driven workflows, webhooks are the number one way to do that. And it's very popular, very commonly seen pattern that you do. In fact, companies like Zapier, I'm sure you've realized, also they run their entire business on top of running webhooks or triggering webhooks as consumers and providers, depending on who they are in a piece of the transaction. Now, common webhooks traits, at least they're event-driven. They're typically post request, which is basically post JSON. Of course, you still have the odd XML one, but most of them today are post JSON, which means they post JSON to the consumer. They also, they also are sometimes protected by HMAC or API keys with an HTTP header. So just to ensure that the webhook consumer is somebody that is actually legitimate, they also make, you also need to authenticate the transaction through an HMAC or an API key, depending on the kind of webhook. Sometimes they're there and sometimes they're not. It really depends on the provider and the kind of configuration the provider is using. And of course, in some cases, remember, especially in the case of build tools or CI/CD tools, you will see that producer systems allow you to add your own custom header. So let's say you need to add an API key for your system or your application, which is your consumer application. You can set up a webhook with additional headers as well. It's not only that you just give it a URL. You might also be able to add your own custom header so that you can actually get your event, and that would be identified with this HTTP header with a bunch of custom headers, right? So that's basically what the common webhook traits are. Now, if you come to think of it, the natural type of assumptions or attack focus that one would have. So let's say you're a pen tester or somebody doing offensive security on a webhook. The natural assumptions would be that let's try and compromise the consumer. Most of the attacks are trying to compromise the consumer, right? And to prevent other kind of replays and things like that. Again, most of it is trying to compromise the consumer. So can I compromise the consumer with a deserialization payload, which means that, let's say I put in some kind of malicious JSON or YAML or whatever it is. Can I run my code on the consumer? Can I compromise a whole bunch of consumers, with an ecosystem style attack? Can I tamper with the payload? Can the consumer detect tampered payload? Can I replay the attacks? Can I attack from unknown sources? So it depends on whether whether the consumer is the provider can make random requests to another consumer. So a lot of these are typical attack scenarios that you come up with, right? So these are typical attack scenarios that you see, and a lot of them, and a lot of you, I'm sure, do this as well. So when you're trying to, can you do a replay? Can you run the same transaction a whole bunch of times? Is there a way for the consumer to detect that it's a replay happening? So all of these things are natural attacks. But in our case, what we're going to do is we're kind of flipping the script in this case. What we're trying to do is, can I compromise the provider? Our focus today and our focus in this entire class of attacks is, can I compromise that provider? This provider that is sending me the event payload, can I compromise that particular provider through some type of attack? So basically what I'm trying to do in this case is that I have a provider, which is my, Stripe, Shopify, what have you. I mean, I'm just using them as examples. I'm not saying that they're vulnerable. Please keep that in mind. So whatever, I have this provider. Now this provider makes a request, obviously sends this HTTP request to the consumer. Now the consumer, in turn, instead of processing this legitimately like a normal or a good consumer would, the consumer makes a request or somehow finds a way of attacking and compromising the provider and the internal applications of that provider. It could be a database, it could be an internal application, it could be metadata, it could be whatever. Now, as soon as you think of a scenario like this, I'm sure the first thing that comes to mind is naturally SSRF, right? Now, SSRF is one of those attacks that orients itself towards doing something like this, right? Because SSRF allows you to redirect or facilitates a redirect based on a user-controlled URL. So in this case, it has all the natural makings of a classic SSRF attack. The idea here is that when I, the user, can use a particular URL of my choosing. So it could be a URL that I can select or I can enter or I can use as part of the attributes. And I can get this application, this target or victim application, to make an internal request to one of their internal URLs or to a metadata URL. So let's say I want to compromise AWS credentials. I make a call to a metadata URL, and that metadata URL gets, I get access to the credentials, and from there I get those credentials and then start exfiltrating information from AWS. I can escalate privileges on top of your AWS account. So this is SSRF. This is classically SSRF, right? Most of us are aware of this. Most of us have seen this. SSRF is super common. You see this in nearly every third bug bounty report, at least is, I obviously don't have the exact stats, but SSRF is super popular. It's very, very commonly seen. Now, you see, of course, SSRF, you have a lot of attacks. The Capital One breach where the attacker was able to find SSRF on the mod security deployed by Capital One. They were able to use that, get the make a call to the internal 169.254.169.254 AWS metadata. They were able to get the credentials. Those credentials had a large scope access to the Amazon S3 infrastructure that was run by Capital One, and they were able to gain access to all those S3 buckets and exfiltrate a whole bunch of user information from there. Then, of course, you've constantly seen this. SSRF is super common. You've seen this as part of the proxy logon exploit chain. It is one of those extremely common and extremely popular attacks that is also hard to prevent, by the way. It's not very easy to prevent SSRF. There are a lot of different nuances to prevent SSRF. Anyway, so the idea here is that with SSRF, you can do all of this stuff. One of the reasons why SSRF has become so popular is because SSRF is used extensively to compromise cloud environments. So if you're running Kubernetes or AWS or Azure or GCP, the idea here is that you have some metadata URL or metadata file path, and you can access that particular file path, gain access to sensitive credentials that are mounted on that particular file path or URL, and then use that to escalate privileges into the account. SSRF can also be you reading a remote file and executing that through a remote code execution. It can be denial of service. It can be information disclosure. So through SSRF, I'm able to access internal hosts, and those internal hosts have sensitive information that could be information disclosure. So you have a wide array of possibilities with what you can do with SSRF. So I'm sure a lot of you are aware of this. Now here, what we want to do is leverage SSRF against our provider. So we want to use this attack essentially as a boomerang. So what we want to do is to say that, look, hey, the provider is going to make a request to me, the consumer. I am an evil consumer, and I get a request through the provider. Now I want to be able to use that same request chain against the provider, right? So I want to redirect a request back to the provider where I do something, where I'm able to compromise internal assets. So the idea here is that my provider makes a webhook request, whereas my consumer redirects that particular request back to an internal URL or metadata or what have you, and I'm able to compromise that as part of this. Now, remember, a lot of times the reason that this also works is because a lot of these providers store previous results of webhook execution, right? So, for instance, let's say I'm Stripe, and every single time I receive a payment, I trigger a webhook, or the user has configured a webhook where I can trigger a webhook on this particular event. Now I keep a log of those the requests and responses. So Stripe maintains a log of that, and a lot of times you as the user are able to see that log. So the idea here is that the consumer, who's also a legitimate user of the application, wants to leverage this attack and then use the webhook that they have set up to compromise that provider application or that victim application, right? That's basically what they want to do. But there is also a problem. Now, if you are familiar with SSRF, you'll know that SSRF works extensively with GET requests, right? SSRF works when there is a GET request involved. So when you take a GET request and you're able to use another GET request, you can do SSRF. You can manage SSRF. However, most of the webhooks, right? I'm not saying all, but probably close to all. Most webhooks make post request or put request, right? Because they are sending data. They're not only making a GET request. There's no point of a GET request. Most of the time, they are making post request because they're posting JSON to that particular consumer, right? So the idea here is that you're getting a post request, but how do you use that to make to redirect that into a GET request? So it's hard to weaponize, especially with pure SSRF. So this is where a very interesting header comes in. Now there's a header which is a very popular, I wouldn't say very popular, but at least a well-known redirect header, which is called the HTTP 303 redirect. Now the way this works is that if you send it a post or a put, this redirects as a GET. So you can set up a redirect on your consumer application that says, hey, whenever you get a post request to this particular path, let's say whatever / webhook, whatever, you need to 303 redirected. Now, a 303 redirect automatically converts that post request to a get request on the redirect, and it requests a particular new location. And that is where this really works. This attack really works because 303 converts that redirect into a get request and sends it back to wherever you've redirected it. Now, obviously, people creating the standard didn't imagine that this would be the case or this would be how it would use, but 303 allows that to happen, right? Unlike most other redirects that you have. So the idea here is that in a response, so whenever you have a HTTP 303, which is see other, it essentially says, hey, this way, please, and makes it a GET request. So basically redirects it as a GET request, and your clients essentially just follow along. They just said, oh, okay, I need to redirect to this location, so I'm going to make a GET request to this particular location, and that request turns now into a GET request now, which means that you can leverage that SSRF in full scope, right? So this is something that 303 allows you to do. So what we want is essentially, we want a provider application, we want this webhook request to come in, and once this webhook post request hits my consumer, the consumer, remember, the consumer is another web application that's just listening for these requests. So as soon as this post request comes in, this sends back an HTTP 303 that redirects to an internal metadata service like 169.254 or some local host service or some internal IP address or whatever it is, that it's able to access that URL and get whatever information, whatever response that comes from that particular URL GET request is stored as part of the webhook logs, right? So that's the idea. So the attacker wants to be able to do this because the attacker wants to be able to store, redirect, boomerang this attack back to the provider, get that provider to talk to an internal metadata service, steal credentials, and then use that in the webhook logs, use those stolen credentials and escalate privileges into their AWS account, or use that to access an internal resource or what have you, right? There are a whole bunch of things that you can potentially do with this. Now, this is something that we have extensively used against a whole bunch of public bug bounty targets. Wherever we've seen bug bounty system, wherever we've had bounty programs, we have tried this out, and it has had amazing results. The kind of results that you've seen with the webhooks system that they had have been quite amazing. And we've used this on Docker, and we were able to use this successfully on Docker, right? Now, Docker, obviously, as all of you, I'm sure a lot of you use Docker every day. Docker is a massive service that allows you to host your container images in their container registry. Docker was the original registry. Of course, now you have a whole bunch of other registries, but we were able to do this on Docker. We were able to compromise and gain complete access to their whatever their AWS credential provided, which was quite highly scoped at this particular point in time. So I'm going to explain how we did this. Now, in Docker Hub, there is a functionality where you can create your own webhook. Right, so we created a webhook in this case, and we set up the webhook to a ngrok URL to a URL that we controlled, of course. And behind the scenes, we essentially wrote a small piece of code that said, "Hey, you know what? Whenever you get a request, a post request here, what we want you to do is run a 303 redirect back to 169.254.169.254/latest/metadata, which is a very common path for the metadata in an AWS EC2 instance, or not only EC2, but many other compute instances of AWS. We're talking about Elastic Beanstalk. We're talking about Fargate. I think Fargate has a slightly different IP address, but it's pretty much the same idea regardless, right? So, but it is essentially gets you access to the instance metadata on that particular node. And through that, we were able to identify this. So once we did this, we pushed. So this webhook would be triggered every time we pushed a new container image to this particular Docker registry, Docker repository, right? So we pushed this container image, which was generally a random container image. And once we did that, we saw that the Docker Hub, the webhook trigger, the Docker Hub essentially was triggering the webhook, of course, but we were not able to get the webhook logs. We were not able to get the log of the webhook. And when we actually saw the requests and responses, we found the webhook log in the request. It was not being shown up on screen, but we found the webhook log. And in the webhook log, we found that they used a metadata credential, the AWS role name called this, right? So prod, whatever, something. They used some AWS role name here. And once we used that particular URL in a subsequent request, we were able to dump the AWS credentials. And as it so happens, those AWS credentials were related to their EKS infrastructure that they used to run Docker Hub with. So the EKS infrastructure, and probably a lot more. We didn't go beyond this because obviously we wanted to report it as soon as possible in the interest of vulnerability disclosure. So as soon as we found this, and of course they mentioned to us that this was scoped to their EKS cluster on Amazon, and obviously this means that this could have been a much larger attack, because the Docker Hub, which contains a lot of the base images and the trusted images, potentially, I don't know, maybe they could have been compromised as well. So the idea here was those AWS credentials we were able to identify, and using those AWS credentials, we were able to access their AWS account. We were able to potentially compromise their AWS account and gain access to whatever scope that particular role and that particular privileges granted to that role could provide us. So this was a huge attack, simply because Docker is, as you all know, a extremely public service that all of us use. And this could have had a pretty huge impact. So we immediately reported it to them. In fact, we just did a get caller identity, and it was giving us a legitimate role on their AWS account. So we immediately reported it to them, and they fixed it in a matter of about 2 hours. As soon as we reported it, a couple of hours later, they said that we'd fixed it. We reran the checks, and we had found that they had actually indeed fixed it. So that is one of the things we found, and thankfully it was fixed quite a while back. So it's quite this is not something that we need to worry about anymore. So they were able to address it almost immediately. So I have a quick demo that I have set up here as well. I'm going to quickly run this. Now, if you see here, we have our application. So I'm just going to quickly walk you through how the demo works, or the demo app. So I have a provider application, as you can see here, and I have my evil webhook consumer that I've set up. Now, every time I make a webhook post request payload, when I trigger a post request payload here, my evil consumer would HTTP 303 with a redirect to a CouchDB database. So CouchDB is a very popular NoSQL database that you can directly access through HTTP, like a REST API. So the idea here is that I'm going to use this to access my data internally on the CouchDB. So CouchDB should not be exposed, but because I'm redirecting it, and because this application has access to CouchDB, the idea here is to get this application to connect to CouchDB and store those results as part of the webhook request and response framework. Right. So now let's quickly go into this. I've already set up the demo. I'm running my application stack here. So this I'm running on our training platform on AppSec Engineer, in fact. So now let's, I think I've already set up everything I need to. I'm just going to log in and explain how the attack. So I'm going to log in as the user. So this is me logging in as the user, and I get a JWT, or an authorization token once I've logged in as this particular user, right? So if I do an echo $toke, I get this, right? So if I just paste it here, it's a genuine jot that I can use on my application. So in this application, so you'll see that it's a valid JWT, blah, 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 it's logged in, right? Now I am going to list the user's data. So I'm going to list the user's information as part of my application. So the user in this case has set up a webhook, and this webhook makes a post request whenever a new build happens. So imagine that this is a CI/CD system, and a new build happens. This triggers a request to my to this particular URL, right? So that's basically what happens. Now I'm going to quickly simulate this. I'm going to simulate a request. In this case, what I'm going to do is here I have set up my webhook. Now in my webhook, what I have done is I have set up my redirect URI to the CouchDB service. So I have said that whenever you're trying to do this, redirect it internally to a CouchDB instance. So make a 303 request back to the CouchDB instance, right? I've just set it up as a redirect. So if you see my code, you'll see what I'm talking about. You'll see that every single time a request comes in, make a 303 redirect to this URL, this hook URL that I've set up, right? So that's basically what's happening. So I'm going to run my hook. This is me running my webhook, my malicious webhook. And once I make a request, which is basically like, I'm going to trigger an event. You'll see once I trigger an event, this comes back with the CouchDB all databases information. So if I see what is actually returned by this, you'll see that the CouchDB database has a database called users. Now, if I change this request hook URI, and instead of all databases, I make this users. Now, this is me escalating privileges. 984/user/all docs. Sorry about that. 3. So every time my hook is reconfigured to redirect to another location. So in this case, now, if I trigger another webhook event, you will see that it fetches. Oops. I'm not sure what happened. Okay. I think there is something wrong with the URL that I was trying to access. Oh, that was the issue. Sorry. Looks like I've added some unnecessary characters here. And so let me just rerun the webhook simulation. Yeah, I think I already have it here. So you'll see that it returned with a whole bunch of characters. So if I do echo, I wish I'd just done a JQ here. So you'll see that it returned all these user values, right? So these are just user IDs, but of course I can fetch pretty much anything at this particular point in time. Now, so this was the demo of how this would work, right? Now, of course, one of the common things is, okay, this is a GET request. What's so great? Yeah, in many cases, if you have metadata, a lot of times those metadata, to access cloud metadata, if it's not AWS, in many cases, you have to add additional headers. But a lot of times you will see that a lot of services allow you to add custom headers, right, to the webhook. So in that case, one of the things you can do is add custom headers. So in this case, we were able to compromise a CI system where they were using GCP. And because we were able to add custom headers, we were able to simulate a system where we were able to add the metadata flavor header, which means that this would make a GET request to the GCP metadata with that mandatory HTTP header, which is metadata flavor Google. And through that, we were able to still perform this attack. So if you have a webhook system that allows for custom headers, you have that possibility as well. I think I've run out of time. Now, I'm just going to quickly run through the defense. The first thing you have to do is, one of the simplest things that you should do for this is to not follow redirect. So when you have a webhook set up, when you're using APIs and you're using webhook functionality, the first thing you have to do is turn off follow redirect on your HTTP client. That would essentially bring down the possibility of this attack by quite a bit. You have to figure out what type of HTTP client you're using and not follow redirect in that particular HTTP client. That's something that you have to do. Of course, you can add additional security elements like network security policy. You can add DNS so that it does not resolve to a local internal IP address. You can add a validation for the webhook URL, although that's a little difficult to do if you have a where users are providing their own URL, so that may be difficult to do. Or you might have an IP deny list to say that anything that tries to talk to 169.254 or localhost or 10 series or whatever it is, you do not allow that in your webhook URL. So these are some of the areas of defense that you can use. That's really it. Conclusions, again, webhooks are a very powerful way to integrate. But again, with these kind of boomerang attacks, you can have a very serious set of issues with webhooks. So definitely look at those possibilities and consider this as part of your threat model. I think the first thing you should do is consider this as part of your threat model. That really makes it a lot more powerful for you to think about these type of attacks and how you can potentially get hosed by these kind of attacks. So that's something you'll see. SSRF, of course, is the attacker's very good friend in this particular case. With that, I come to the end of my talk. I realize that it was probably a little rushed, but I hope I was able to convey everything I wanted to convey, and I hope it was useful. Thank you so much for having me, and that's really it.
All right, thank you so much for the talk. I think there's some echo. All right. So, quick break again this time, so a few minutes, 2 to 5. And the next speaker will be live, so it's pretty exciting. We're kind of shifting in second gear for our next section of the talk. If you do have questions, please, for Abhay, please go on Twitter. He's not going to be part of the Q&A session at the end. And don't forget, for the next speaker, if you have any questions, go on Slido, and we'll answer them during the talk. Merci. welcome back. I see a lot more faces. This is very exciting again. All right, so we'll have our third talk today. Please, let's welcome Yossi Weizman. Yossi is a senior security researcher in the cloud security research team. Yeah, welcome in. Come on in. He has more than 10 years of experience in security research field, starting in Israeli military. His current role, in his current role, he focuses on container security. All right, so please go ahead.
Thank you very much. Hello. Hello. I'm Yossi. First of all, it's very nice to be here. I'm Yossi Weizman. I'm a senior security researcher at Microsoft. And today I'm going to talk about lateral movements in Kubernetes. So this is the agenda for today. We're going to start with a short overview of Kubernetes. Then we'll talk about identity types in Kubernetes. We'll speak about lateral movements, both in the cluster and from the cluster to outside resources. And then we'll have some takeaways. So let's start. So first, what is Kubernetes? But before that, what are containers? So container is a unit of software that packages your code, your application's code, with all of its dependencies. So you can run it everywhere without worrying about your dependencies. The executable itself is called image, and at runtime, images become containers, which are run isolated from each other. Now, usually it's not enough to run one container on one computer. You want to run multiple containers on multiple VMs or computers, and you need to manage it somehow. And that's why you have Kubernetes. Kubernetes is a container orchestrator, and it basically manages a cluster of computers. Each computer runs multiple containers. So let's see how it looks like. So this is a Kubernetes cluster, and you can see that it has two main parts. It has the control plane, which is like the brain of the cluster, and we have the nodes, which run the actual containers. So the control plane has several components. What's especially interesting for us is the API server, which is like the front end of the cluster. So every request to the cluster goes via the API server. For example, if you want to create new containers, it goes through the API server. If you want to list all the resources in your cluster, it goes via the API server. So that's what's especially important for us to this session. And then we have the nodes, which run the containers. And each node also have an agent that is called kubelet, which allows Kubernetes to manage that node, that computer. In managed clusters in the cloud, such as AKS in Azure, EKS in Amazon, or GCP in Google, GKE, sorry, in Google, the control plane is fully managed by the cloud provider. So you, as a user, don't have a direct access to that control plane. In Kubernetes, we usually don't talk about containers because containers are not Kubernetes objects. We're talking about pods, which are the lowest level components in Kubernetes. So in this session also, we're going to talk about pods. Usually users don't even deploy pods, they deploy higher level components, but since pods are the lowest level components in Kubernetes, we'll focus on pods. Pod can run one or more containers that share resources. So in this session, we'll concentrate on pods. So now that we know what is Kubernetes, let's talk about identity types in Kubernetes. And we can split it into three main areas. So the first one is how users from outside the clusters, like the administrator, can authenticate with the cluster, with the API server, actually. The second topic is how applications in the cluster authenticate with the cluster, and again, with the API server. And the third is how applications in the cluster authenticate with resources outside the cluster in the cloud. So in this talk, we are going to focus on questions 2 and 3, because that's what's important for us for lateral movement. So what is lateral movement in Kubernetes? So back in 2020, so this is the threat metrics to Kubernetes. which we released at Microsoft back in 2020. The threat matrix is a knowledge base of attacking techniques of Kubernetes, and it was actually the first attempt to systematically map the attack landscape of Kubernetes. Last year, in 2021, we released a second version. And as you can see, we used the format of MITRE ATT&CK. Probably many of you are familiar with MITRE ATT&CK. And last year, MITRE released their own metrics for containers as part of MITRE ATT&CK framework that was actually a result of a joint project of MITRE with other companies, including us at Microsoft. If you want to hear more about the threat metrics and the differences between the threat metrics and MITRE ATT&CK, you can watch our session at KubeCon from a few months ago. But for now, we can see that the lateral movement has many techniques, and we're going to cover some of them during the session. So we're going to start with inner cluster lateral movement. But first, we should know some basic terms of cluster authentication and authorization. The first term is service account, which represent an identity of application in Kubernetes. Kubernetes uses RBAC, role-based access control. It's not unique for Kubernetes, of course. And RBAC has roles, which is a set of permissions, and role binding, which attach identities to the roles. So for example, here we have service accounts 1, 2, and 3, and we have roles 1, 2, and 3, and you can see that service account 1 has roles 1 and 2, and role 3 has service account 2 and 3 attached to it. So this is RBAC, and that's how RBAC works in Kubernetes. So service accounts can be mounted into pods, allowing the pods to authenticate with the API server. So the full chains look like this. We have pod, the pod has service account mounted to it, service account has roles attached to it, and each role has permissions, which are the rules. So here's our cluster again, and now we know that we have service account in the pods. For example, pod A has service account, and with that service account, it can communicate with the API server. So let's talk about the lateral movement. So what is lateral movement inside the cluster? So let's assume that we have a pod that is compromised, and how pods can become compromised. So for example, if the pod runs a container which runs a web application, and that web application is vulnerable, and somebody exploited it, so now we have a vulnerable container, compromised container or compromised pod in our cluster. So let's say the pod A is now compromised. So what is lateral movement? It could be a movement between one pod to another pod in the cluster. It can also be a movement between a pod to a node in the cluster. And if attacker gets access to a node, usually it means that the attacker can perform a full cluster takeover because the node has a strong permission, it has an identity in the cluster, and if the attacker has access to the node, it can read the credentials of that identity and perform a full cluster takeover. So usually access to a node allowing takeover of the cluster. So the key point here is that attackers can use the service accounts of the pods in order to move laterally in the cluster. So we have pod, and the pod has a service account, and the attacker can use it. So which permissions might lead to inner cluster lateral movement? In other words, which permissions the service account of the compromised pod should have to allow the attacker to perform lateral movement? And the answer is that there are many permissions that may lead to lateral movement, and we're going to see two examples, real-world examples that we saw in real environments. So the first example is read permission to secret. So Kubernetes secrets are objects that store sensitive data in Kubernetes. For example, if you have an application that needs a connection string or a password, you can store it as a Kubernetes secret and then load it into your running app. Kubernetes itself uses secrets to store tokens of the service accounts. So if attacker has permissions to read those secrets, they can steal the tokens of the service accounts. So in this example, on the left, we can see a role definition that allows reading all the secrets in the cluster. So if the compromised pod has this permission, It can allow the attacker to use this permission to read token of a privileged service account, and in that way to move laterally in the cluster. So let's see an example. So pod A has read permissions. So now pod A the attacker can request a token to a privileged service account token, and with that token, it can impersonate to that service account, and now the attacker can move laterally in the cluster. For example, it can deploy a new container, or it can change the configuration of an existing containers to run its own malicious code. So that was the first example. Now we're going to see another example of a permission that allowing lateral movement, and this is self-update permissions, and this one is based on a vulnerability that we recently discovered. And the root cause in that vulnerability was self-update permission. Now, in this case, what happened is that application had permissions to update themselves. Now, it sounds maybe harmless because you can update only it yourself, but it means that applications could change their own configuration, and specifically change their own configuration into privileged. And if you change your own permission, your own configuration into privileged, it means that now you have a privileged container in the cluster, which allows access to the underlying node. And again, if you have access to the underlying node, in most cases, it means that you can perform a cluster takeover. So let's see how it looks like. So pod A has a permission to change its own configuration. So it turned itself into privileged. Now a new pod is deployed. This time the pod runs a privileged container. So we have the new container here, the new pod. And from that pod, the attacker can access to the underlying node and perform cluster takeover. So those were two examples of permissions in Kubernetes RBAC that allowed lateral movement in the cluster. So now for mitigation and detection, how we as defenders can prevent it. So first is adhere to the least privilege principle, which means don't give service account permissions they don't need. Second, in most cases, your pods don't even need any access to the API server. They don't need any service account. By default, Kubernetes loads or mounts a service account to each pod, but you can disable it. So in the pod configuration, you can specify that you don't want a service account. So if your application doesn't need access to the API server, just don't mount service account. And as for mitigations, so what we need to do basically is to monitor the API server of Kubernetes. And luckily, we have a very powerful tool to do it, and it's native in Kubernetes, and that is the Kubernetes audit log, which allows you to basically see every operation in the API server. In that way, you can find suspicious deployment of a container with suspicious images. You can find deployment of pods with suspicious configurations, such as privileged containers. And you can also monitor suspicious or sensitive API operations, such as read secrets from Kubernetes. All right. So we talked about inner cluster lateral movement. Now let's move to cluster to cloud lateral movement, which is, in my opinion, even more interesting. So workloads in Kubernetes may need access to cloud resources. For example, let's say that we have an application that needs to store data. Many applications need to store data. So we can use cloud storage for that. Now, if we use cloud storage, so we need to authenticate with that cloud storage, so we need to access to cloud resource. In case of managed clusters, such as AKS, EKS, GKE, they must access cloud resources because they rely on cloud services. For example, the Kubernetes nodes are virtual machines, or the cluster uses a cloud load balancer. So they must access cloud resources. And the question is, how do workloads in Kubernetes authenticate with the cloud provider API? And there are several methods to achieve that. We're going to go over the main ones. So the first one is specific to Azure. And it used to be, until quite recently, the default method that Azure used to authenticate the AKS cluster to the cloud. And in that method, we use service principals. And service principals are application identities in Azure. It's like in Kubernetes we have service accounts, so in Azure we have service principals, very similar. And with this method, each Kubernetes node stores a file with credentials to a service principal. And by default, this service principal has contributor role to the node's resource group. Contributor is a strong role in Azure. So basically, it means that that service principal can modify or do whatever it wants to the resources of that particular cluster. But users can bring their own service principal or giving more permissions to this service principal according to their needs. So again, if we have an application that needs access to a specific blob storage, a cloud storage, so the user can grant permissions to this service principal to that storage account. So, so here's our cluster again. But this time we have one more type of an identity. So we have, besides the Kubernetes service account, we have also the Azure service principal in each node. And let's say once again that pod A is compromised. And again, pod A, I mean, the container that is running in pod A is compromised, not the pod itself, because pods are just a Kubernetes object. What's actually compromised is the running container. So let's say that pod A or the container of pod A is compromised, and what the attacker wants is to access to the service principal. Now, the problem that the attacker cannot access to the service principal because there is isolation in containers. So containers cannot access to the files in the underlying nodes. So what the attacker can do is to try to use the methods that we saw before, and that's leveraging the service account, the Kubernetes service account, to create a new pod in the cluster, but this time to mount the service principal into the new pod. Because in Kubernetes, you can, it's not only Kubernetes, also in Docker containers, you can mount files into containers from the nodes, but you need to specify it in the containers configuration. So if pod A, if the service account has permission to create new pods, the attacker can use it to create a new pod, and this time to mount the service principal, and now the attacker has a backdoor pod with the service principal in it, and with this service principal, the attacker can access to cloud environment. So we saw one method, and the limitation here, the limitation of the attacker is that the attacker needs to somehow create a new pod and mount the service principal into it, which in many cases, it's not the case. I mean, nobody says that pod A, the service account of pod A has permissions to create new pods. And second, this method is only for Azure. So now we're going to see another method that doesn't require any operations with the API server of Kubernetes. It doesn't require any service accounts, and also working in other cloud providers. And this is, and it's also related to the last talk, and this is using the metadata service. So the metadata service is a special endpoint that allows VMs to query information about themselves. And this endpoint is implemented by all major cloud providers. You can see here Azure, AWS, and GCP. And among other information, this special endpoint, the metadata service, allows the VMs to get tokens for cloud identities that are attached to them. Now, in all cloud providers, you can attach identities to VMs, allowing them to authenticate with the cloud API. Every cloud provider has a different name for that concept. In Azure, it's called the managed identities. In AWS, it's EC2 roles. In Google, it's called IAM roles, IAM service accounts. But all cloud providers have this concept. And with the metadata service, VMs can query the token of the attached identities. And this query doesn't require any authentication. So every application on the VM can query that endpoint, can send a request to that endpoint and get a token to the attached identities. Now, in the cloud, Kubernetes nodes are actually VMs, which also have metadata service. And by default, pods can access freely to the metadata service of their nodes. So it means that pods can acquire tokens to those identities that are attached to the underlying nodes. The permissions of those identities are really depend on the cloud provider, because each one has different default settings, but also by the specific environment, because users grant different permissions according to their needs. So now we are going to go over the various cloud providers, and we are going to see the default settings. But we'll see that in each one of them, users can also modify it, and users very often modify the default permissions to grant more permissions according to what their application actually needs, or in many cases, not only what their application needs, but also excessive permissions. So in AKS, we have managed identities. Managed identities are those identities that we can attach to VMs, and not only VMs in Azure. And AKS uses several managed identities to operate the Kubernetes cluster, the AKS clusters, but users can also add more managed identities if they need to. If they want to add more permissions, they can add more managed identities, or alternatively, they can also give more permissions to the existing managed identities. And this is the list of the default managed identities that AKS uses. There are quite a lot. It really depends on the AKS configuration. And we see many cases in which users give very strong permissions to those managed identities, according subscription owner, which is super powerful. So that was AKS. Now let's talk about EKS, Amazon. So EKS has EC2 roles. And by default, the EC2 role has two policies in it. The first one allows it to pull images from the container registry, and the second one allows it to read its read permission to the compute environment. So read its read permissions for the EC2s, VPCs, and etc. But again, users can add more policies if their containers require to access additional cloud services. In GKE, we have IAM service accounts, not to be confused with the Kubernetes service accounts. IAM service accounts is the term of Google to those identities that you attach to virtual machines. And by default, all the VMs in a project share the same default service account. And by default, this service account has editor role, which is quite permissive. And users can also add more permissions to that service account, or replace it to another service account. So this is a summary of what we just talked. So by default, pods can access to the metadata service of their underlying nodes. So pods can acquire tokens of that nodes, and the permissions vary based on the cloud provider and the specific environment as the user configure it. And here you can see that you can actually access to the tokens from a running container in each one of the cloud providers. So let's see how it looks like, how lateral movement using the metadata service looks like. So here again, we have our cluster with pod A, which is compromised. And now we are going to make some space. So we're going to remove nodes 2 and 3 just to make some space. You can imagine that they're still there. So now we have node 1 with pod A, and node 1 has its metadata server. And pod A can now request a token. The metadata service returns a token of the cloud identity, and with that cloud identity, based on the permissions, pod A can perform all kinds of operations. For example, list storage account, keys, or get blobs. It can be list secrets from a secret store like Azure Key Vault or KMS. And it also can, the attacker might get credentials of other Kubernetes clusters that are deployed in the cloud. I'm out of time, so 5 minutes. All right, so I have 5 minutes. Great. I need less. So the problem that we just saw is that the pods can freely access to the metadata service, and they can acquire tokens to the node's cloud identities, and all the pods share the same cloud resources, the same cloud identities, and those identities are actually the node's identities. What we want is to allocate a specific identity to each pod, if the pod actually needs to access to the cloud API, and make sure that pods can access only to their own identities, so they don't share identities. Luckily, all cloud providers allowing us to do it. We don't have time to go over each one of them with details, but we'll just mention that those are the solutions that allowing you to give specific identities to specific pods. They work differently. Some of them are based on intercepting the traffic to the metadata service. Some of them are work by using Kubernetes as an identity provider. You can read about all of them, but we'll just say that they are not enabled by default. By default, what we just saw is working, and if you want to restrict and use this option, you need to enable it. This is for MITRE ATT&CK. This is a technique that talks about using the metadata server to get cloud identity tokens. And if you go to that technique, you can also see details about attacking groups that use it in containers. So what is the mitigation? So first, again, adhere to the least privilege principle. Don't give to the cloud identities permissions they don't need. Second is, as we just said, allocate specific cloud identities to your pods that actually need access. And third is to restrict the access of the pods to the metadata server. As for detection, what we should do is to track the activity of the cloud identities that are related to our Kubernetes workloads or nodes. And in many times, it's quite easy to do it because the behavior is relatively constant. So if we can see that there are some suspicious operations, we can look for it, and in many cases, the normal behavior is going to be quite consistent. For example, in Azure, we have the Azure activity log. So you can see in this example that there is a managed identity that is used by the Kubernetes nodes to list storage keys, which is not one of the normal operations. And we have the same thing also in AWS, and we have the same thing in GCP. In AWS, it's CloudTrail. In GCP, Cloud Audit Log. So key takeaways. So when you secure your cluster, consider the various identity types, also the identities in the cluster and outside the cluster. Always adhere to the least privilege principle, again, both for identities that are into your Kubernetes cluster and your cloud identities. And third is to monitor the activity of the identities and look for suspicious operations. That's it. Thank you very much. I hope you found it interesting.
All right, merci Yossi. So we'll take a 5-minute breaks, and after we'll have our last talk for the block of AppSec. Please go on Slido and answer or submit any question that you might have. We will answer them during the Q&A. Merci. All right, everyone, we're back for the last talk of this block, which is AppSec. We have here on stage Nate Warfield. He has been an hacker since his first lay hands on 2004, 2400 bought modern. After his first hack on dial-up BBS at 12, he was hooked, and over the following 25 years, he sharpened his skills through job in network engineering, vulnerability response, endpoint research, and side projects such as hacking phones and researching network attack surface. So please join me to welcome Nate to the stage for his amazing talk.
Thank you.
The mic?
I've got it. Test. Are we live? Can you hear me? No. Not yet? Oh, there we go. All right. Thank you, everybody. Welcome to I am Become Load Balancer, owner of your network. I'll do a little introduction about myself. Yeah, I'm Nate. I have been hacking networks since I was about 12 years old. I spent about 17 years building and troubleshooting networks. I worked for Microsoft for 7 years. 2 of those years, I was in the network engineering group. I spent a bunch of years shipping out Windows patches for Patch Tuesday, so I'm sorry, but that's what I did. And I did a stint in Defender for Endpoints, doing some endpoint research, and I'm about to start a new job on Monday that I'm not going to give away the secret just yet. I worked at F5 Networks for 10 years. 7 of those years, I was Microsoft's dedicated engineering, design, escalation, support contact, which is where I get fun pictures like an F5 device encased in a block of ice, which we will kind of get to the story behind that a little bit later. I like to speak at conferences. This is my first time at NorthSec. I've done primarily blue team, sort of defensive focused talks, so this is the first talk that's more on sort of offensive, like evil shenanigans thing, which I'm kind of excited for. Getting a little bit of feedback. I was featured in Wired Magazine in 2020. I helped start a group called CTI League. We built a 1,500-person volunteer InfoSec group that was giving out free threat intelligence and sort of perimeter assessments to hospitals to try to prevent them from getting ransomware during the pandemic. And then my side stuff, I like to spin drum and bass music because I'm an old school techno kind of guy. Enough about me. So the TLDR, for those are maybe uninitiated, what are load balancers? These are very large, expensive pieces of networking hardware. They're usually deployed in what they call a failover pair. So if you think of like HSRP for routers, it's the same concept, right? You've got a device that's passing traffic. If something happens to it, you can fail over and can ideally not lose any of your connectivity. They do layer 4 to layer 7 load balancing. Some of them can be web application firewalls. You can do VPN. You can do DNS load balancing. They're sort of like a Swiss Army knife of networking for things that are not just your basic switching and routing. They also do SSL and TLS offloading. So people will use these things when they're actually F5's biggest selling point at first was you could have a very powerful SSL accelerator chip, slap a certificate on it, load balance it across your pool of dozens or hundreds of servers, and save money on SSL and also be more performant than going to specific servers themselves. The nice thing about these things is because they're such a sort of a core routing and traffic shaping device, you get almost unfettered access to the internal network once you hack onto one of these devices. They're generally on multiple VLANs. Most of them have internet connectivity. Some of them are talking to Active Directory. There may be VPN sessions. So they're a very juicy kind of fun thing once you get on it to see where you can laterally move and pivot and the other sort of maliciousness that you can perform. And they're mission critical, right? These things are, you think of like your core routers, these are very important devices which are generally not updated unless someone absolutely has to. F5 has had some code quality issues over the years, and people who've managed them kind of get to know that if you don't need to upgrade the thing, just leave it running. So a lot of these things are running 2, 3, 4, 5, 10-year outdated versions of code. And the nice thing about these from the attack perspective is because they're proprietary, you don't have much in the way of EDR or endpoints, so like solutions that can monitor what's going on with these devices. So even when we were at Microsoft, we had remote logging and things like that, but there wasn't really any way you could detect if someone got on the device, at least not in any timely fashion. Another fun thing about it, which is we're going to get into here with these vulnerabilities, is that these devices always have a web GUI enabled. The F5s in particular are Apache with Tomcat. I wish I could tell you it was updated. It's not. So there's also other vendors like Citrix, A10, a few other companies. I'm going to be specifically talking F5 today, but the design concepts are very much the same, right? Citrix runs BSD as their management operating system. F5 runs CentOS. You can pretty much, most of what they do is identical. It's just slightly different like commands and things to get around. And then they also have shells. So Bash is the standard one. They have their proprietary TMSH one. I will point out that as I'm going through these slides, you're going to see TMSH commands. The reason I'm sticking them in there verbatim is because you can then plug them into the POC that came out last week and run these commands. So the idea is you can copy, paste, and play with this stuff in a lab, which at the end we'll talk about how to build one. So the deployment methodology. When I was building this talk, I was initially going to use the CVE from 2020, this 5902 past traversal vulnerability that F5 had in June of 2020. That was what I was going to use to show all the demonstration stuff for you. However, they blessed me a week ago with an even more easy to exploit and an even easier to POC vulnerability that's also a CVSS10, which essentially, without getting too deep in the weeds, you take a connection header, you basically stuff a authentication connection header inside the connection, like the connection colon header, feed it to the device, and it believes you now have root access to the machine. Zero authentication required. You can run any command as root. It's gorgeous. And all devices have OOB management. So they sell these things. It's generally a big networking switch. They also sell VM versions of it. We're not going to go too much into the VM stuff except at the end because that's how I built the lab to show you this stuff. And I hope that's kind of readable. I mean, it's green on black. If you're not using green on black, are you really hacking things? So they have an OOB management interface. The hardware devices will have a bank of switch ports, and they'll have an actual like gigabit interface that people can plug into the management side. They also have, with these network interfaces, you generally plug them in to a trunk port. A lot of people then tag VLANs on top of them. And then because it's in a HSRP kind of design, each device will have its own a static IP that's attached to the device, and then there's an IP that they call the floating address. This is bound to the device that's passing traffic. This is where your server's default gateway will be. If the device fails over, that IP address will float over to the other device as it takes over. The thing that people don't realize, and we saw this last week when people were doing incident response, is that not only is the management GUI and SSH enabled on the management interface, every single self-IP address on the device by default will be listening on management traffic. So people may be thinking, oh, I'll just turn the management interface off and I'm safe. Well, no, every other self-IP the device has is also listening on those management ports. So it makes locking these things down complex. Behind these things are generally pools. This is the taxonomy that F5 uses. Pools of servers, which is just your server resources. This is all stuff you can look at in the config. You can kind of figure out what's back there. Most people name these pools fairly explicitly. So it's like web server pool or my Active Directory pool or whatever they're load balancing. So there's all sorts of juicy stuff that we may not be able to get too deep in the weeds on. The virtual servers are the actual traffic interfaces. This is the thing that's going to be facing the internet, facing the clients. This is what everybody talks to, and then it sort of just disperses traffic across the back. They use these concept of profiles. This isn't super relevant, but I'm trying to give you an idea, or isn't super relevant to attacking them, but it's useful to know how these things operate. So they'll make a virtual server. What these things will have is like a layer 4 profile if it's going to serve, let's say it's serving TLS. It'll have a layer 4 profile for TCP. Then it will have a profile for HTTP because it's going to be doing HTTP traffic. Then it will have another profile for SSL, which is where the certificate and all these other details are stored. So these things have it's a very kind of convoluted way of configuring them. But once you start digging around, you can start to understand, okay, what is this thing doing? And it just takes time. One of the other things to notice about these is that when they fail over, because they need to shift the layer 2 address that all the servers are talking to for their default gateway, and at the very least, they need to update the switch with where this layer 2 address is. Like they have a concept that they call MAC masquerading, where you can have a MAC address that's on the floating address. So if it fails over, the MAC address isn't going to change for the backend servers, but what it is going to have to do is the CAM tables in your switch are going to have to know this MAC address changed from this port to that port. So if you fail these things over by accident, that's going to get noticed. They're going to all of a sudden see a failover event. They may notice that traffic gets interrupted for a second. The idea here is I'm trying to teach you how to not get caught if you hack onto one of these things, and only a red teaming environment, of course. So a little bit about how these things work at the low level. This is a slightly outdated slide or a slightly outdated picture. They split the things into sort of two planes. This AOM part of the graphic that you're looking at is for one of their older platforms. I don't believe the new platforms have these anymore. That was the always-on management. It was literally a separate CPU that ran its own separate instance of Linux that you could mess around with if you got onto it. But the really important part is there's what they call the traffic management microkernel. This is the code that F5 writes that processes all of the traffic. It's what handles all the load balancing. It's all of the sort of brains of this device. Everything production happens there. You'll see this HMS part. This is the host management subsystem. So this is where your Linux stuff works. This is the part we're going to be attacking. The other important thing, if you break TMM, if you do something that causes it to lock up, the devices will fail over and you will probably get caught. If people are paying attention, this is usually noticeable. Now, the management side is CentOS. It's not a very updated version of CentOS. I think their most current up-to-date code is running like CentOS 7.3, and I believe CentOS 8 is current. Some of their older platforms go all the way down to CentOS like 6.5. So you can pretty much do whatever you want here. And the interesting thing about how the architecture works is when the devices boot up, at least the hardware ones, the first thing that takes over all of the resources of CPU and memory is their proprietary TMM code. Then it yields back a certain percentage back to the Linux side. So you're kind of protected from really breaking anything too badly because there's a check there. It says, okay, if the Linux side uses too much CPU resources, it just stops giving it resources. So the idea is they want to always pass traffic and never let you, infinitely loop something in Linux that then takes down the whole device. Now, your traffic planes on these things can be tens, possibly hundreds of gigabits a second at this point. This is a little bit out of order, but should you get on one of these and should you decide to start sniffing around, or maybe you just trying to capture sensitive information or whatever your sort of mission in this engagement might be, don't put TCP dump on any of these interfaces that have TMM attached to them. If you've ever been a Cisco router or a switch person, that's like doing a set debug all. You will basically be dumping 40 to 100 gigabits of traffic into TCP dump on the Linux side. That will cause TMM to lock up, the device will stop working, and you will probably get caught. One of the ways to figure out what platform you're on is, this is our first of the TMSH commands. If you ask it to show sys hardware, and I apologize that I don't have an example of what it looks like, it will actually tell you like what hardware platform it is it a virtual instance, how much processing power. It gives you ideas, and then you just go look it up on their website and say, okay, how big of a box am I on, right? Am I on the $2 million chassis, or am I on the like $40,000 chassis? So once you get on one of these things, let's say we use one of our fun exploits to get root, there's some things you need to know to not get caught. These devices, because they're in failover pairs, use the concept of a shared configuration, right? So this is the stuff where you add your virtual servers, your server pools, your SSL things, and this is, of course, synchronized between both devices so that if it fails over, it has the same config. If you change things here, there's a fairly good chance you'll get noticed. The devices are smart enough to notice when a change is made to one side, and it'll say, oh, I'm no longer in synchronization. And if somebody's paying attention, a big if, they may say, well, why did the devices just go out of sync in their config? Let's go take a look. As I said, changes that impact the traffic plane will definitely be noticed. If you start doing things like if you start messing around with the load balancing configuration or trying to fiddle with the actual stuff that's serving traffic, a lot of times what will happen when you apply the change, it sort of resets that configuration. So you may drop active sessions, you may cause a traffic interruption, like some blip that will get caught. People say, what happened to my F5? Why did it like have a blip? Now, if you just change stuff on a single device, there is a section of the config, as I mentioned, like the self IPs are just for the single device. That doesn't get synchronized. Nobody really notices that. So keep that in mind. And if you don't know how these things work, if you're not familiar with the underlying tech, don't touch the traffic plane. They have this cool technology that they call iRoles, which is basically a TCL/TK, modified TCL/TK language, which allows you to do deep packet inspection on traffic flowing through the device, and then you can manipulate and steer traffic based on like binary payloads. I think I know one person in the world that's good with these things, Yeah, I mean, if you want to mess around there, you can, but I would highly advise that you either steal their config and then set up a VM lab and try to do it. But there be dragons there. So once you get on, all of this is CentOS, right? So the logging is all in varlog. They do have, like I mentioned, remote logging. So this is the type of thing you can check. Using this exploit, you can actually say, before you maybe jump on the box and start doing things, you could say tmsh list syslog. It'll tell you if the device is doing a remote syslog. If you dig further into their configuration documentation, you could, in theory, disable the remote logging before you hack onto the device and sort of pre-cover your tracks. They have a somewhat proprietary authentication system. It's based loosely on Linux PAM. The only account you will ever be able to add to the Linux side the only account you can log in that's actually a Linux account is root. So trying to echo something into Etsy password or create a user through the add user thing, it's not gonna work. You can create the user, but it won't let you log in with that user. History files, clearing our tracks. Home user is where all your history files are created. There's two of them. There's your normal bash history, and then you've got the TMSH history. You need to clear out both of those if you're trying to keep people from seeing what you're doing. And let's see here. So user accounts. So if we're going to hack on to one of these devices, right, we've got this cool exploit from last week. The idea, because it gives you root access, you're going to need to log into this thing somehow. Now, more advanced red teamers, you may be able to spawn like a netcat reverse shell. I'm not a red teamer, full disclosure, so you probably have better tricks than I do, and if you want to talk about it later, please come see me. But you can create user accounts and it will be noticed, right? If you created a user account, you'll notice that it goes from online and in sync to online and changes pending. So this is the kind of visual cue that if someone's watching it, they'll notice, well, something just went differently. However, because users are not a traffic serving part of the configuration, you could then just synchronize the configuration. It won't interrupt anything, and all of a sudden the devices will go back to being in sync, and you've created your own user, and now you can log in and do whatever you want. The advanced shell, and I have an example of this coming up. When you create a user, when these user accounts are created, they give a whole bunch of different permissions, but there is an option of which shell you give them. If you say shell none, then they can only log in via the GUI. If they say shell TMSH, then they can log in only with TMSH, which restricts command line access. You can generally feed bash commands through it. It has a bash option. You say, okay, just bash -c, give it the bash command, it'll run it. But what it won't let you do is just drop to a full bash shell and start running around in the file system and doing all the fun, evil things we like to do. The other interesting thing about these devices is you can actually disable the root account. At Microsoft, we did this all the time. We would basically set them up, we'd lock them down, we restricted SSH access, we turned off the root account. The fun thing about this, I was testing this in my lab, is I disabled it, and then I used the exploit to check whether it was disabled, and it was like, oh, the root account is disabled. So then I used the exploit to re-enable the root account, and now I could log back in. Now, this seems like pretty cool, but keep in mind, I knew the password for the device. So if I don't know the password for the root account, my options are either change it, which now if they go to log in and it doesn't work, that's definitely a sign that something's wrong, or just, add a user and give them bash access and then continue on with your day. But it's just fun. It's an interesting way that these the management stuff that they've done is sort of convoluted, and there's so many attack paths. The vulnerability that came out in 2020, like I said, path traversal against a Java servlet page in Tomcat that allowed you to run TMSH commands as root. This one was, the connection header, which hit the REST API that allowed you to run commands as root. It seems like we're in Groundhog Day sometimes. The other interesting thing about it is they don't have a firewall per se. Like these things have the concept of what they call a net, it's a self-allow list. Let me see, I have a picture of that. So what this is it's essentially just a list of ports and protocols that you will allow to be accessed on the self-IP address. Now some of them, if it's a SSH, there is a daemon running there. If it is TLS, there's a daemon running there. If you turn on some random other port, it just means that you can talk to it on that port. The fun part about this is because they're not shared, and again, we can go and if you get one of these devices, you see, okay, well, there's a root account, or I've created myself a new account, and then you try to SSH in and you get a connection refused. Well, you throw the exploit payload and you look at what the actual self-allow list is, and you're like, okay, well, SSH is disabled. Well, then you just throw the exploit payload and enable the SSH port, and now you can get back in. And this isn't shared. Nobody's going to notice unless they're paying extremely close attention. They also allow outbound connections by default. The thing, though, to keep in mind is, and the way we would deploy these in sort of a really good environment is the actual device itself had no default gateway. There would be a default gateway for the management network, but what we would do is we would put them in a network, we would plug them in, trunk them, put a bunch of VLANs, and then the device doesn't need a gateway to talk to pass traffic back and forth. They use this funky thing that they call auto last hop, which essentially the device will record the layer 2 address that it received traffic from, and then when it goes to respond, or it's passing the load balance traffic back, it'll say, well, I don't have a default gateway in this network. I'm just going to send it to the layer 2 address that sent it to me. So it's an interesting way of routing without actually needing a router, if you will. And then to be consistent, they have 3 different names for their self-IP ACLs. If you get on the device itself, it's called a self-allow list in the configuration, or it's a self-allow list when you're changing it. When you look in the config file, it's called an allow service in the net self configuration. And then if you go to the GUI, it's called port lockdown. Confused yet? Backdoors and web shells. So the thing about these devices, like I said, they run CentOS. They only have Python 2. I was going to do a whole bunch of cool demos with like Impacket and a bunch of other things, and I realized most of the fun hacking tools are written in Python 3 now. The other thing about these devices is they've stripped out all of the stuff that would be useful for you. So there's no compilers. They are CentOS, but they don't have the RPM command, so you couldn't even like grab a Python 3 RPM and just install it when you got on there. So if you're going to take post-exploitation tools with you, you're going to need to build them and test them in a lab or in an F5 VM lab, make sure that they work, and then you can just drag them over to the device when you actually get onto it. They are mostly CentOS on x86-64. Most of these devices run Intel chips, so it's not really that difficult to do this stuff. It's just, it takes some preparation and planning. What they do have, because of the way these devices are set up and because of some of the things that they need to be able to do, is they have a full suite of LDAP tools. So this is, I believe it's all the standard CentOS stuff. So you've got LDAP tools, you've got SMB client, you've got Netcat, ironically, it's cron, your RC scripts, you've got an SSH daemon. I think they might even have FTP and Telnet on them still. Not as a service, just in the daemon itself or the client itself. So this brings me to a kind of fun part, which is, as I was building this talk, I was like, okay, this is cool, and then I don't know if anybody's going to grok this. Mandiant comes out with a report 2 weeks ago about this threat actor called UNC3524, which they believe is a Russian associated state actor whose way of getting into networks was hacking into load balancers, SAN devices, conference room cameras, phone systems, all of the devices that run proprietary code where you cannot run EDR. It was almost like they copied my slide for their blog, and I was like so honored. So if you want more information, I highly recommend this article. It's super fun. So I noticed as I'm reading this, they're talking about their quiet exit backdoor, which is this modified drop bear SSH daemon. And this really funny part was somebody sent me this while I was building the slides, and I had just finished pocking out a cron entry to build a reverse SSH tunnel on reboot. Now, again, not a red teamer, probably not the most efficient way to do it because I had to, generate an SSH shared key, put the private key on my C2 server, and do all this other sort of tomfoolery. But this worked. I was like, okay, I just plopped this in there, I rebooted the device, and then it boots back up, and it makes an SSH tunnel back to my C2. Once again, I have to log in with an actual username and password on the device. But again, you red teamers, you can do all of this stuff probably much more elegantly than I can. And then the other thing to note is if you're going to drop a web shell, I believe the web path is like user share www something. They mount the user file system read only. So I've seen a lot of attempts when we were doing IR where there's these commands trying to sort of echo a PHP file into the web directory. That's not going to work. The advanced actors have figured this out, and we saw this in 2020. The first they would send was a remount command to remount user as read-write. Then they'd throw their web shell on there, and then they put it back to read-only, so it doesn't look like anything happened. And that K number is the knowledge base article on F5's website that you can go and find out more about this. There's also a bunch of links at the end that may be useful for you. There's some fun things you can do with network device discovery on these things. So one of the features that their customers from F5 really love is this concept of cookie persistence. I believe they actually have a patent on this thing. But what it does is you say, okay, I want users to get a cookie that persists them to this specific server, and that way, the traffic will work. And the concept too is, if it fails over, because the configuration is the same, you'll still be rehomed to the very same server because you have the cookie. The device says, oh, I know what server to send you to. So it's actually one of their cooler features. The better part about this feature is you can decode these cookies and you can figure out what the back-end sort of IP addressing scheme looks like. Because, and it might be a little hard to read, you do a showdown search for big IP server. That's what the cookie's named by default. And then you can actually look in the details of it, and it tells you the pool name inside of the device, and then the numeric strings or the IP address, and then the port that it's running on. And I think there's some other piece of detail that it's been 10 years since I worked there. So that's kind of a fun thing. If you don't even have access to it yet, you figure, okay, what does the back-end server network look like? The other fun thing, like I said, these things are SSL, TLS concentrators. So a lot of places will just not run SSL on the back end. So they'll do it securely on the front, and then everything in the back is clear text. Now, most banks don't do this. They do have the ability to do re-encryption on the back end. So you see like financial institutions and people that are super security aware will re-encrypt. But a lot of people that are like, I have an online commerce website, I'm just gonna SSL it in the front and then clear text it in the back, YOLO. So, like I said, be careful if you TCP dump, but it is a full-fledged TCP dump. If you start to figure out what server you're going for, just craft a TCP dump string to only pull traffic for that specific system, and then it's far less chance of you getting in trouble. They do remote authentication, so they can authenticate against LDAP, Active Directory, Radius, TACACS. This is all stuff you can see in their config files. So, again, TMSH list auth will show you whatever their remote authentication stuff is set up as. If you see an auth source of just an empty parens, it means that it's only using local accounts on the device. If you see anything else, it'll say, type is Active Directory. It'll have the SAM, like the DN search path. It'll have the SAM account name. I couldn't figure out how to crack the passwords. I think they are using salted encryption when they do these things, but if you're a password cracker, go to town on it. Then TMSH show auth will give you users, failed logins, and accounts that have been locked out. I have never seen anybody actually set up a lockout, like a login limit on their local the devices. They just kind of leave it as the defaults, and the default does not lock you out after a number of failed attempts. And then one of the fun things about these is because they deploy them in pairs, they actually have this concept of clustering. So you can deploy 3, 4, 5 of these things in a cluster. I don't know why you would. But you can use the exploit and you could actually discover other devices on the network. So let's say somebody forgets and leaves just one interface in a place where you can reach it and everything else is firewalled off. Well, you can use this list CM device and it'll show you all of the other devices in the cluster, and then you can go and theoretically laterally move. I'm going to redevelop this talk later in the year and probably try to basically have the device exploit the next device by using the exploit. Say, okay, send this command, use the payload to get to the next device, pull a shell back to me. So it's just how evil are you. Then the GUI runs on 8443 for VMs. So if you're scanning 443 in a network, scan 8443, you might find some virtualized F5s. And then I have showed queries that I like to throw out there. I like to discover things on the internet when a vulnerability comes out. You can get some of those there. Valuable config items, and this is where the beer thing comes in. So this was actually one of the Xbox Live F5 devices. When they decommissioned it, they were so happy to have it out of their network, they threw a party, and this turned into the world's most expensive beer tap. You're looking at a $750,000 piece of networking hardware that they ran beer lines through and then encased in a block of ice. Not even joking. And the beer was pretty good. So configuration items are all in /config. The big IP base conf is your base device and networking. This big IP conf is your shared configuration. The user config is here in big IP user. You'll notice that this is actually the old 2020 payload, pulling out the user information, which is kind of ugly. And then this was the new one from 2022, which is cool because it's JSON, so it actually comes out formatted and it looks beautiful. And then TMSH list auth user will give you hashes. The hashes are not in the config. Config file store, this is where all the configuration SSL certs, keys, all the juicy stuff that these devices can have is stored in there. Config GTM, we don't have time to go into the DNS side of these things, but if they're doing DNS load balancing and you can get root on one of these, you can imagine all the evil things you can do. It's all in config GTM. You can also do what I would prefer to tell you to do is do a TMSH, save the UCS, which is the config backup. It's just a tar.gz file that they renamed to .ucs. Save it, download it, rename to TGZ, unpack it. You have every valuable file that the device has, and you can go through it without as much risk of getting caught. So how to build a test lab. This is what I did. So they give away virtual edition VMs for free for all your major hypervisors, right? So we got KVM, Hyper-V, VMware. They also give away vulnerable versions. So the version that I was running was vulnerable to the 2020 CVE. It turns out it was also vulnerable, of course, to the 2022 CVE, but it's cool if you figure out what version it's on, just download that version and now you can start messing around with it. I thought you would delete vulnerable versions of code from your repositories, but they don't. Like I said, this is how you test your toys, and if you want to do load balancing, like actually license it, you need a 30-day demo license. You can use a throwaway email to get one of these. Like they don't check to see if it's a valid, like a legitimate company. You just go to like throwaway mail or any of those sites. You set up an account, ask for registration keys. They give you a set of 3. They're good for 30 days. You can do this as many times as you want. I think I generated 30 of them in the process of testing this lab. I use Proxmox. This screenshot is actually the config from my Proxmox server. It's very complicated and finicky to get this working. If you have problems, see me afterwards. You can also run these in clouds, Azure, AWS, virtualized instances, same process for a demo license, except you also now have to pay for cloud computing time, up to you. And then you can download ISOs too, the same thing with a throwaway account. So if you'd like to pull apart ISOs and look at all the stuff that's installed and see if there's old packages that you can exploit, you can do that too. Don't buy them off eBay. If you buy it off eBay, you will not be able to use it until you have a valid support contract from F5, which costs thousands and thousands and thousands of dollars a year. And if you're interested in doing any of this stuff, I'm happy to help you with research. Find me later, hit me up on Twitter. And with that, your reference material is here. I will be posting these slides to my GitHub later on today. Like I said, come find me. And thank you very much. And like I said, I mentioned I was a DJ. This is me 20 years ago, before the beard. I promise I wasn't born with this thing. I have a SoundCloud because it's what you do. And thank you very much, NorthSec.
All right, thank you. Very interesting. We'll take a few minutes break, and after we'll please join us for the Q&A. Merci.
Thank you for the time.
right, so we're back at it again. So we're here to have a quick, 30 minutes Q&A regarding AppSec or any kind of related topic. Do we also have Vickie connected? All right, awesome. Well, hi Vickie. All right, so how it's going to work is that there might be a slight delay, so we'll be careful about that. So before we start, I'm curious, I know Vickie, your talk was specifically about how to write better technical doc. Are you guys writing some technical documentation, blogs or books or anything of some sort?
I'm not, but I probably should start.
Okay.
Yeah, I release from time to time blog posts, and I also talked in the session about the threat metrics, which was quite a significant publication of us. So yeah, and the tips in the session were definitely helpful.
All right, awesome. So this is supposed to be a conversation. So Vickie, if you also have questions for people on-prem or live with us, please ask away. If not, what I'll do is I'll go through some of the popular question on Slido. So we do have some. All right, this one is very generic. Okay. So we're open to any tips and tricks, but what kind of protection can we implement on database of the provider side to prevent an evil consumer from stealing data? Is using a different database an option? It's to everyone. It's fine if we don't have the answer. Perhaps it's a question, too generic question for our speaker today.
I mean, I'm not a database guy, but I have done a talk about basically finding unsecured NoSQL databases out there, and it seemed like the biggest problem was people forgot to put authentication on it, or they forgot and they left it open to the internet. I don't know that you could switch from, say, like Elastic to Mongo. I'm pretty sure that there's very different data structures, but basically Security 101 is the only advice that I would give someone.
All right, sounds good. Vickie, raise your hand if you have any additional comments to add on this question. All right. Follow-up question. Can we restrict unknown IP addresses with ACL in F5? If there is indeed an ACL in place, how can we work our way around it? Again, is that too generic?
No. So the F5s, the only place you're going to be able to put an ACL on that's realistic is the management side of the network. So you can either ACL down the management IP or the self IPs. It's pretty robust though. You're not going to have an easy way of working your way around it because even using the exploit, you won't be able to view that ACL list because it's going to just kick any request out that's not coming from a trusted network. That's actually how when we secured them at Microsoft was Microsoft has of course a very robust networking team. We had a network, a full private address space that was only for management, and every device before it was even plugged into the network had ACLs applied, so only that trusted network could get to it. So yeah, good luck.
All right, so the next question is specifically for Vickie. Any tips for people who aren't native English speaker on writing better technical content?
Sure. Yeah, that's a great question. I am not a native English speaker myself, and I certainly struggled with writing and even speaking English when I first moved to the United States. And I think the most important tip that I have is to do intentional practices. So what does that mean, right? Getting good at writing takes time, and it's very, very important to write a lot, right? Your first few pieces would probably suck, but that's okay because you'll gradually get better over time. But another thing to remember when you're practicing writing is that it's not enough just to write a lot. It's also really important to get feedback about your writing, right? So when I first moved to the United States, the way that I got better at writing is that I had a writing mentor that would take my pieces and tell me how she would improve the piece. But I do understand that. I think that's the best way of actually improve your writing. a lot in a short time frame, but that is not available to everyone, right? Another way that you can get feedback from your writing is through grammar checkers. So you can install one of those free grammar checking software and run your articles through that grammar checker, see what kind of feedback it's giving you, and try to model correct grammar or good sentence structures from the recommendation you get back from grammar checker. And another thing you can do is that you can find similar articles online that you think are well written that talks about the same topic that you are talking about and compare what makes their writing better than yours and what can you improve in your own writing and model how they're structuring their articles, they're structuring their sentences and their word choices as well.
All right, awesome tips and tricks. Maybe it can be useful for English speaker as well. All right. Let's do a question for Yossi, pardon. It seems that in all cases, we rely on Kubernetes to be the IDP to the cloud IDP. That means trusting the configuration of the cloud providers, configuration, and key management. Question mark. I don't know if that's a well-written question, but
not sure that I understood it. But if it talks about the IDP,
it does.
Yeah. All right. So yeah, I just mentioned it in the word in the session. I didn't get into it, but what I tried to say, I mean, I didn't get into the details, but now cloud providers have the option to trust Kubernetes as an IDP. So service accounts from the cluster are trusted by the cloud provider, and that's another way to authenticate your workloads, your pods, with the cloud. You can read about, for example, in Azure, it's called Workload Identity Federation, I think, and in the AWS, it's called RSA. So you can read about the whole flow, but generally, it means that the cluster is trusted as an identity provider.
All right, thank you. This is more a generic question that maybe has nothing to do with your specific talk, but since we're here talking about application security, you all know that it's hard for them to take security seriously. Does anyone has experience and maybe tips and tricks on how to, or has experience on how teaching developer to know when their stuff is broken?
Well, I can say that well, I work in on a product group at Microsoft, and it's really important to be aware that as a developer, you should. I mean, I think we do it quite well at Microsoft. Is to really be with security in mind, and it could be with education, just to show examples of how simple mistakes at code become vulnerabilities or misconfigurations. And so I think that the main thing is that you need to educate the devs to be with security in mind. It's a generic answer, but I think it's really important, and that's the first step.
And how do you do that? With bribes and cookies?
Well, I think that first show examples and to show, to show how sometimes simple things that looks like just little bugs can cause to a serious vulnerability, to a serious security issue. I think it's helpful, and I think it's another thing is the organizational culture. I mean, to be aware of the security. So at Microsoft, a big organization, it's obviously a thing. So everyone is aware of the security, but maybe in smaller dev groups, it's different, and it's super important. So I think that's another thing.
Absolument. Nate, I feel like you have something to say about this.
So in my experience, and this is not from the sort of developer side, but I did another talk about the last F5 vulnerability in 2020. The interesting takeaway from that was the 2020 CVE, the path traversal one. It was almost the exact same POC as a Citrix vulnerability from 6 months prior against their load balancing devices. Both of those used a technique that Orange Sai had talked about at Black Hat in 2018. So the advice that I would give is, especially when you're using open source software, you need to be paying attention to the ecosystem. Your developers and your security teams need to be looking at what the current attack surface is. Don't send them to Black Hat just so they can go to parties and drink. They need to be going and looking at these talks and saying, hey, do we use these components in our product? If we do, you know, like quite literally, Orange's, his slides had the same POC ... / that was used in both those attacks. So they had 18 months to look at their code and say, hey, is this something that would affect us? Had they done that, they would have realized, yes, it did. So like keeping abreast of the ecosystem and also looking at your competitors and seeing what types of vulnerabilities affect them. You know, in the load balancing world, like I said, they're very similar products. So had someone from F5 said, hey, Citrix just got whacked with this really bad vulnerability. We do almost the same thing. We should go take a look. You need to be cognizant of what's going on around you and not just head down, you know, writing new shiny features. Like security's boring, we get it, but new shiny is what's going to get you in trouble.
All right, thanks. So I'll relate a question to Vickie. Vickie, do you have any tips and tricks on how to onboard dev into the security journey?
Sure, I think I can share one of my experiences. That's sort of like my aha moment in security, right? Before I got into security, I was actually a developer and I wrote lots of code. And because I was a web developer, a lot of the vulnerabilities that I studied as a security person actually relates to the code that I wrote for my development job, right? So one of the great aha moments I had about security and how to teach developers security is that I went back to one of the projects that I made when I was a developer, and I just started to find like all of these different ways to exploit it, right? And that really showed me what the experience should be like when we're teaching developers security. It should be about context, right? We should make it relevant to their work. We should make it understand this is exactly why this is bad, and this is what the attacker can do with your customers, with your clients, and with your data. I think grounding the security education in that sort of context is very important into making people actually care.
Absolutely. Thank you for that, Vickie. Let's jump into a different topic. I believe this question's for Nate. For load balancers, would a honeypot based on your lab setup catch anything interesting, you think?
Oh, absolutely. I believe that Kevin Beaumont, who goes by Gossi the Dog on Twitter, set up a F5 honeypot shortly after this vulnerability came out. I know that people, as soon as these vulnerabilities have come out, different security groups have set up honeypots just to see what sorts of exploit payloads are coming in. So I guess you, in theory, could set one up on your own internal network to sort of like maybe try to, you know, confuse an attacker. However, if I'm an attacker, if I'm playing around in your network, the first thing I'm going to do is see, is this device actually interesting? And if I find it that it's just sitting there with no load balance configuration or it's not passing any traffic, I'm going to either assume, okay, this is just a lab box, or maybe this is a honeypot. So yes, it could work. I think it's more useful for sort of the internet spray of attack payloads and sort of collecting and seeing what the TTPs or, you know, the IOCs of what's being dropped.
All right, awesome. Question regarding Kubernetes. For lateral movement, why it moves, sorry. Why were PUD security policies config mentioned, as it would allow escalating the node even faster? Maybe this is a trick question. Yeah. For Kubernetes, lateral movement, so for you, why weren't PUD's security policies config mentioned? As security policies config mentioned. Did you mention that in your talk? Yeah? Yeah. As it would allow escalating the node even faster.
All right, the question is, which configurations of the pod can allow us to move to the node faster?
We can take the question however we want and make it your own. I can select another one if you want, no worries.
I'm not sure that I understood, but if the question is about pod configurations?
Perhaps let's take it this way, yeah.
Okay. So I'm not sure that I'm answering the right question, but regarding pod configurations that may lead to lateral movement. So we talked about several in the talk. I mean, we mentioned it really briefly, but privileged container first have full access to the underlying node. We also talk about mounting files. So if we have a pod with the configuration of mounting file into it, so it also may lead to lateral movement. Then there is the whole topic of networking. So for example, you can specify that pod has access to the host networking. So there are a bunch of configurations of pods that may lead to lateral movements, if it was the question. And if not, so you can ask me again and I'll answer.
All right. If not, they can hit you up on Twitter and see the real answer for you. All right. For Nate, another question for you. Yeah. What do you think of asking for a software bill of material that lists all their dependencies and their version on those proprietary devices?
I think it's a good idea, and at least in terms of F5, you can somewhat figure it out. There's one of the reference links I had in my slides. They do list what operating system versions they use for the management side of things. So you could, take a look and say, what is CentOS 7.3 running? What libraries does it have? Those operating systems are not updated the way that we would update our Linux servers. So I think it's during like major revs, like when they go from 11 to 12 or 12 to 13, they'll update to a degree. But you're not going to get much of a software bill of materials from them as far as I know. Unless, of course, you're a big enough customer and you pay them enough money, then that was one of the things that I would have done, which was to say, okay, let me pull this for you. But yeah, and that's only going to be the Linux side of things. If you start asking about like supply chains of where their firmware is coming from and the code that's running their ASICs or their FPGAs, you're going to have a non-trivial time getting that out of them.
All right. So Vickie, maybe a question that it's for you, but also from one of the speakers that could not join us today. So it's kind of a in-between or a hybrid question. What do you think about webhooks, and would it be a good target for bug bounties program or any? I don't know if you've written any blogs or anything about it in your experience.
Mm-hmm. So I've actually written about webhooks before, and I think they can potentially be a good target for bug bounties, but in reality, I haven't really hunted that much in bug bounty programs for webhook related bugs. So I don't really know the answer to that. I think potentially, I don't really know how prevalent it is though.
Do we have any strong opinion? No. Parfait, sounds good. All right. So I'm reading the question that are remaining. They're quite similar to or uncomprehensive. So I won't go through. I won't go give you any weird question anymore. All right. So thank you guys so much. Please ask them your question privately. If you do, hit them on Twitter or we're just here to help. So please feel free to reach out. Merci tout le monde.
All right, welcome back. So now we're kicking the last afternoon of the conference with the cryptography block. Your moderator has been president of NorthSec, challenge designer, conference organizer, everything pretty much. So he has 15 years of experience. He loves cryptography. He was working at Delve that got acquired by SecureWorks. You might know him for his smart card challenges. That reminds me that my first Montreal was the smart card challenges, and I was like, oh my God, I'm not smart enough for security. But yeah, I stick around, and whatever happens, happens. So let's give it up for Pierre-David Auriol.
Thank you. It's a trick. There's not a lot of smart things about smart cards. It's just overly complex for no good reason, to be honest. And he agrees. So welcome to the cryptography block. If you thought this was about any other use of the term crypto, even though there's mushrooms everywhere, I'm sorry for you. It's really about cryptography. So I'm here to present Yolan Romailler. He's a cryptographer, worked at Kudeski, and now works at a startup where today he's going to talk about randomness. It's going to be a very interesting talk. He's a previous NorthSec speaker. He also spoke at Black Hat, besides other crypto villages. So I'm really pleased that he could come again to Montreal. I think it was 3 years ago that you had your talk here. And so I'm very pleased to introduce Yolan. So please give it up for Yolan.
Hello, thank you, thank you. Hello, everyone. So yeah, I'm super happy to be back on stage after all these years without conferences. It's super nice to be able to present again. And as Pierre-David said, I'm currently a software engineer working on randomness. I used to be an applied cryptographer looking at other software engineers' code and having nightmare about what I saw, So I'm here to make sure that you won't do the same mistakes when it comes to randomness as what I saw in the past. And I'm also super happy to play the CTF tomorrow, tonight already. And let's start. So today we'll discuss about what is randomness and its different flavors. Next we'll talk about why do we even need randomness, when do we use it, why, and so on. We'll see what are the problems with randomness and why it's hard. And finally, we'll see how we do good randomness in practice and what remains to be done. So what is randomness? If you look up in the dictionary, that's a quality of being random. Great. They go on and refine a bit, saying, so that's the quality of being random, happening, done, or chosen by chance rather than according to a plan. That's not exactly how we see randomness in computer sciences, right? So I found another dictionary which has a bit of a better definition. So randomness is the quality or state of lacking a pattern. And here there is a very important word. It says unpredictability. And we'll see why it's very important later on. So here I've picked a few random strings, binary strings, 37 bits. Who can tell me if the first one is random? Doesn't look random, right? So how about the second one? Is it random? Probably. The third one doesn't look random neither, right? So probably not random. The fourth one looks random, but if you look at the hexadecimal representation, it doesn't look random anymore. And the last one also definitely doesn't look random. So what that means is that even though all of these 37-bit random strings have the same probability of being drawn at random, we have some kind of intuition of what's random and what's not, right? So we'll see what that intuition actually means right now. And when we talk about randomness, we have a way to formalize it a bit. We use the Kolmogorov complexity to look at randomness and say, oh, that looks random, or oh, that doesn't look random. And the Kolmogorov complexity of a string is basically a way to see if you can compress it, you know? How much can you compress the whole one binary string? Well, a lot, because it's only ones. So you just say, oh, it's 37 times 1, and you've compressed it. On the other hand, if you've got a truly random value, it's way more difficult to compress in a general manner. So that's the intuition we have about randomness. And it's going to, yeah, that's also why we want about randomness, right? Being able to not easily guess what's next and so on. And we'll see what unpredictability and bias are later on. So next is the, you know, my talk is about public, verifiable, distributed randomness. And you might be asking yourself, what are all those keywords, right? So public randomness is basically just a value that is random, but that is meant to be public. Like, think of lotteries. If you buy a ticket, you choose your numbers. At some point, they will draw the winning ticket by drawing a random value, and that random value is public. Anybody can look it up and see, oh, that's the winning number for today's lottery. And that's really what public randomness is about. It's something you want everybody to be able to access and use for their own needs, whatever it is, be it for, I don't know, like a lottery, game, like if you want to have some kind of gambling and so on. And next, we'll make the difference between public and secret randomness, because public randomness is cool, but I guess you've all UB keys, SSH keys, PGP keys on your computers, right? And these are secret keys that are not meant to be public. So if you take a public value, a public random value, and use that value to produce your secret key, that's not going to work well. So we also have the notion of secret randomness that is meant to stay secret. And that's typically the one we'll use for cryptography stuff, like generating key material, nonces, so numbers that are meant to be used only once, and so on. So it's super important to keep that in mind. Do not, never, use public randomness to generate secret keys. Seems obvious, right? So next, public randomness is cool, but how do you know it's actually random, right? We've seen earlier, it's very difficult to have an intuition of what's random and what's not. And even though we have one, we might have some doubts about, like the honesty of the person in front of us. Like if you create a tombola game and you give tickets to everybody, and then one of your good friends win the tombola, people might be like, hey, you cheated. So that's not something you typically want when you do something public. Like on a blockchain, typically you have smart contracts which need random values, or in the lottery ecosystem, and for other use cases as well. So what we need next is a way to verify the randomness. And verifiable randomness is just that. It's a public random value that you can verify somehow. That's typically done using hashes, signatures, or complex cryptography, and we'll touch on the ways to do it when we'll see the concrete instantiation in the in-practice part of my talk. And finally, we got the distributed keyword in the title. And distributed randomness is just like what you think it is when you hear it. It's a random value that was achieved, that was created by a distributed system. And that distributed system needs to achieve consensus on the random value, because otherwise it's not going to be a good distributed system if each node has different values at the same timing point. And that's very difficult to do because you want your randomness to be unpredictable, but at the same time, you want all of your nodes in your network to be able to generate the same value at the same moment. So how do you make it so that it's unpredictable, but still generated on time by all nodes? And that's, again, a very difficult task. And blockchain systems have struggled with that. If you look at Ethereum, for example, smart contracts on Ethereum have a very hard time trying to generate random values. And if you look at other distributed systems, usually what you'll find is that you have some kind of trusted third party providing the randomness. And that's not too great because you need to trust somebody, and decentralization and distributed system usually try to decentralize trust, So we don't want to trust a single third party about anything, even our random values. So that's going to be a short section, but why do we need randomness? Well, I spoke about lotteries and gambling already. These are like obvious things. Other things you could think of is like jury election or sortition. These are the kind of things where you really need proper public randomness, probably, because you want it to be publicly auditable, and so you want it to also be verifiable as well. Next, you obviously have all the cryptographic protocols. If you connect to a website nowadays, your computer is probably generating between 2 and 5 random values just for the initial connection, like generating ephemeral keys, nonces, and that's a lot of secret randomness, obviously. Next, we have the obvious case of statistics and control trials in medicine. If you can, if you have a biased distribution when you pick your sample, the results of your study won't be really good, and it won't be, what you want it to be. So you need good randomness there as well, without any bias. And finally, we use it a lot in software in general. Like if you do fuzzing, chaos monkey, and so on, you also want to take random values. But these values can be generated by by a PRNG, a pseudo-random number generator, that's going to be seeded in a way that's repeatable. So it can be deterministic. It doesn't need to be secret. It doesn't need to be public. But it still needs to be uniformly distributed in the, in the values you're interested in. So next, we'll look into what are the problems we have with randomness, because randomness seems easy, right? You just take a random value and you're done. So why is it a problem? And I've talked about this a lot already, but randomness is difficult because you want it to be unpredictable and bias resistant. Being unpredictable, it's kind of obvious. If you can predict the next lottery ticket, you can win it. Or if you can predict the loot you'll get in a game, you can cheat and so on. So it makes sense, right? But the bias-resistant thing is a bit less obvious. And actually, for cryptographic algorithms, it's super important. Because the most used signature scheme nowadays is probably ECDSA. It's used for TLS, it's used on Bitcoin, Ethereum, and a lot of new systems nowadays are running using elliptic curve cryptography. And signature schemes such as ECDSA are super sensitive to bias. You will typically take at random a 256-bit value. Well, if you have just 1 bit that is biased, or 3 bits, it's already a potential vulnerability that could leak your private key. So leaking the private key is the most catastrophic thing that can happen for a cryptographic system. You really don't want that to happen. So it's super important to have really unbiased random values for such cryptographic schemes. And I guess a lot of you have already developed something where you needed a random number, right? So how do you do that? If you want a number between 0 and 255, that's easy, right? You take a random byte, you can call your block device urandom to get a random byte out of your machine entropy pool, and you get a value between 0 and 255. Now it gets trickier if you want a value between 0 and 106, right? How do you do that? Well, the typical way people will do that is taking a random byte and then reducing it modulo the values they want to be the limit, right? So here, if I reduce it modulo 107, I'm happy because every numbers up to 106 will stay the same, and then 107 will become 0, 108 will become 1. Everything is mapped, onto the range you want to query from. But that's actually an issue, because you don't have a multiple of 107 amongst the 256 possibilities you can get from a random byte. So what you've just done here is introducing a modulo bias. Because for the first 106 values, that's fine. The next 106 values, it's fine again. But once you reach 214 up to 255, these are going to be mapped towards the first 42 first values. And so you get biased randomness. And it's super easy to get biased randomness because you just picked a random value, which was good. You reduced it modulo the value you wanted to reduce it to, and suddenly it's not a good random value anymore. And this is leaking your private key already if you're signing stuff with a value that was generated in that way. And so the best way to avoid such bias is obviously to not do it yourself and rely on your cryptographic library. Python has a secret module since Python 3.6. Go and Rust have very good random generator functions. But in general, if you need to do it yourself, what you want to do is rely on so-called rejection sampling, where you will pick a value at random, see if it's in the range you want. If it is, then you're fine. If not, you reject it and you pick a new one against at random. And that's going to be uniformly distributed, and it's not going to be biased. And I've got a cool link to a guide to modulo bias and how to avoid it. It's a blog post I wrote like 2 or 3 years ago, and if you want to check it out, I recommend you read it. So now, we've seen this cool different kind of randomness. Let's see how we can solve the issue of public verifiable distributed randomness, right? So if we look a bit at the history of public randomness, we can see that Michael Rabin already proposed the use of random beacons, and that's where the beacon word comes from, in 1993 to secure transactions. Well, that was before Bitcoin and before blockchain, so these transactions are not the same as the transaction we might be looking at nowadays, but the base idea was the same as what we have now. And what he says in his paper is that it is impossible without a trusted third party. And that's something we are actually going to challenge in a bit. Next, we can see in 1998 a website such as random.org that offers a true random number generator anybody can use, and they are getting their randomness from the atmospheric noise. Physical process, good entropy, everybody's happy, right? Well, how do you verify it was actually taken from atmospheric noise? You cannot. And so you have to trust them. And usually you don't like trusting random people on the internet, right? So next we have NIST, which comes in 2011 and says, the internet needs a public, verifiable, trusted randomness beacon system. And it's funny because NIST is not the most trusted party out there, right? But they went ahead and they launched their first NIST beacon in 2013. And the NIST beacon is based on secure hardware. So you have to trust the secure hardware NIST is using to produce the proper true randomness from quantum entanglements, which is a cool way of producing randomness. And then they publish it online with a signature. You can verify the signature and everything. That's that's public verifiable randomness, except it's generated by a single trusted third party, which is not something we want, right? So when we look at previous attempts to generate public randomness, we can see none of them are really great. There was a paper about using Bitcoin to try and do it, because why not? Promising, but Bitcoin is super slow, and it relies on proof of work, which is not something we really like nowadays, right? So, meh. Next, in 2016, another paper came out which had a super cool technique to do distributed randomness in a publicly verifiable way. So that sounds like the way to go, right? Except it was super slow, and it was using Schnorr signatures, which are, yeah, it was doing a bunch of really nice things, but it was not so efficient. So the question we had was, can we do it in a simpler and faster way? And that's how we came up with the answer that yes, we can. And so the internet needed a randomness service that is just like the NTP servers you use to get the time on your device, right? That is public, free, and available. And so we came up with the notion of DRAN, which stands for distributed randomness, which is a highly available, decentralized, and publicly verifiable source of randomness. And we'll see how that works. So DRAN is an open source software. You can download it on GitHub. You can check it. You can review it. It was even audited, so far so good. Next, it is really meant to be run as a network of nodes. So you will have multiple nodes running the same software. I mean, you could re-implement it as well. There is a spec. But running the DRAN software spec. And then what it does is basically it relies on distributed key generation, which is a cool way of using verifiable secret sharing and threshold cryptography to generate a key that no single node ever sees or gets in memory, but that every node in the network can agree is the right key. And then it will use BLS, so Bonelin-Shasham signature scheme on the BLS 12381 pairing curve to do signatures. And the funny thing with BLS signatures is that you can take any number of BLS signatures and you can aggregate them into a single signature. And so each node in the network is going to sign a value, and that signed value means nothing until you take them together, aggregate them, and get the aggregate signature which can be verified to be coming from that group. And the nice thing is you only need a threshold of nodes. So if you have 20 nodes, you could say, okay, my threshold is 10, and you generate during the distributed key generation a public key that will allow any 10 nodes to generate a valid signature for the group. So those are called group signatures. And we use the signature as a way to produce randomness, because a good signature cannot be distinguished from a random value. So that's a rule for cryptographic signatures. If you have a good signature scheme, you cannot distinguish a signature from a random value. So we take the group signature from the group of nodes, and that gives us a random value. And that random value is generated in a decentralized way, is unpredictable because it's indistinguishable from random. It's resistant to bias, and you can verify it was generated by that group of nodes since it's a signature. So, yay, we did it, right? And we actually did it. So we launched in 2019 the League of Entropy, which was a team of people who decided to run DRAN on their servers. And you can try it out now on your browser. You just, or using curl, whatever. You can just see it running for 3 years now. And the League of Entropy was actually founded by Cloudflare, Kudelski Security, Protocol Labs, a bunch of other companies which are running, internet stuff. And it's really meant to provide you with public verifiable randomness, which is unbiased, which is unpredictable, and that's highly available. And it's been running like that with these 16 members with 23 nodes on a threshold of 12. So it means half of the nodes can get offline and you would still get proper randomness produced. And it's been running like that, since 2019, which is pretty cool because it means we did it, right? And a nice thing is also Cloudflare has a set of lava lamps in their offices they could use as a true random generator to bring fresh entropy into the network. So we get all the benefits from, on one side, we get a set of nodes where we don't need to trust a single node. On the other side, we get some nodes which are providing fresh, true random values, like the University of Chile is also part of the network, and they use the data from like seismic events in Chile to produce the randomness and so on. So that's pretty nice. And the nice thing also with DRAN is that it's supporting so-called multi-protocol support since very recently. We launched it last week, actually. And that means we can expand the network to do more things that we couldn't before. Like we could have post-quantum algorithms running. We could have a faster network because the current tick is like every 30 seconds. So we could say, oh, it's ongoing. And the other nice thing about DRAN is also that it used to be chain randomness because we were looking at blockchain tech and all they did thing, and we decided it was pretty cool to be able to, chain all the beacons together. And what we recently changed about DRAN is that instead of producing rounds that are linked to the previous round, which means it's super difficult to verify because you need a stateful system and look at the previous round, and it's a bit annoying, we decided we could just get rid of the chains. And now we have like one round, which is signed, and the next round, which is signed, and they are independent, so you don't need the state anymore. And why am I talking about unchained randomness, you might be asking, is because it's pretty interesting, because it enables us to do super cool things, such as time lock encryption. And that's something that's upcoming. We're currently developing it, but it basically says you can encrypt something toward the futures. So let's say I want to encrypt something which cannot be decrypted until, I say, August. I could use the trust assumption that we have in the League of Entropy to produce proper randomness on time every 30 seconds until August. And thanks to the pairings and all the fun crypto we use behind the scene, we can encrypt data that you can decrypt once the network will produce a signature. So we are kind of using a signature as a secret key. Yeah, you heard me. But it actually works. And nobody can decrypt the data until the given time has arrived, as long as the network still runs, obviously. And this is pretty cool because it's something which was first, it was an ID in the cypherpunk mailing list that was submitted by Tim May, which is like the founder of the cypherpunk movement and the crypto anarchists. And that has been unsolved for 30 years. And now we're bringing it live soon. And yeah, I'm looking forward to it. So obviously, it's cool to have a public randomness service, but we need people to use it. So I'm here to tell you it exists. We did it. We solved the issue of public, verifiable, distributed randomness. It's highly available. It's been running for 3 years without a single disruption. So yeah, if you have any kind of cool project where you need to do, I don't know, a lottery, or you need public randomness, please use it. And I'm here to also answer your questions and help you with that if you need. And finally, I know I'm talking to a lot of security professionals. So you could go ahead and say, oh, we want to build our own public network, which is running next to yours. That's cool. Do it, please, by any means. But you could also say, hey, I want to join the cool League of Entropy thing because I got a server sitting in my house and I'm not using it. So please do as well. We were looking for new members. It's not taking too much time to set up, and then it runs. So yeah. And with that, I'm done. So thank you very much for listening about randomness and public randomness. And you can send the questions on Slido.
All right, superb. Thanks, everyone. So you can send some questions on Slido. You might have been given the URL before. I don't have it handy, unfortunately. I think it's on the website. Send some questions. Thanks a lot, Yolan. I guess this is maybe something we should be looking into at NorthSec, seeding the randomness with incorrect flags being submitted over time or types of drinks at the bar that are being chosen. So we'll take a short break, probably 5 minutes, I guess. And then we'll be back for the next talk. Thanks, everyone. Okay. All right, so my next speaker here is Christian Paquin. He's a principal program manager at Microsoft Research in the security and crypto team, cryptography team. For the last 20 years, he's been living at the edge of academic research, industry, and a focus on privacy preserving identity technologies, notably UProve. But he recently joined the COVID response effort and helped with the design of the Smart Health Card framework, contributed to the specifications and co-implementation of the dev tools to validate SHC implementation. So, the VaxiCode app that some of you might have used makes use of this. He also very passionate in post-quantum crypto and zero-knowledge proof, based in DC, but of course, repeat speaker for NorthSec, likes to come back to his native Montreal. So please join me in welcoming Christian to the stage. Thank you.
Merci beaucoup. Thank you, everyone. And I'm happy to be back at NorthSec, especially on a beautiful day like today. It was awesome to go have lunch outside in super sunny Old Port, Montreal. It's the best time of the year to visit, as I tell all my American colleagues now. I'm from around here. I've been studied a long time ago, quantum cryptography at the University of Montreal, right here. And after that, I joined the industry, did most of my career doing cryptographic development. I'm now at MSR, working on all sorts of cool advanced crypto technologies, trying to bring them to market and see what can be the future of security. A lot of it deals with privacy-enhancing identity technologies, zero-knowledge proofs. A lot of the focus the last few years has been in post-quantum cryptography. We're avidly waiting for the NIST decision for what's going to be the next post-quantum algorithm. If NIST makes the announcement during my talk, please just interrupt me and let me know. We've been waiting on that news. But like most of the world in the last 2 years, there's been some interruptions because of COVID, and I joined an effort to help with the Smart Health Card framework, which I'm here to talk about. So first, what's that? What's a Smart Health Card? So I hope the organizers did not invite me because I thought it was smart cards, especially we heard that our host here is interested in smart cards. Well, yeah, it has nothing to do with that. That's an acronym or a backronym from the medical community. It stands for, I have to read it because I don't know it by heart, Substitutable Medical Application Reusable Technology. It's a set of APIs in the healthcare industry to avoid vendors lock-in and whatnot. So it's for health cards to be able to present medical information in a convenient way. So what it means for the COVID, so in the US, nationwide, people had these little paper cards. Here in Canada, the provinces at the beginning, before the QR codes came in, everybody had a different solution, either a little sticker with the information, either a PDF you would download, which would contain your name, date of birth, your vaccination history. And that's what you could use to prove to various people that you've been vaccinated. So, of course, that's very susceptible to fraud and forgery, modifications. So the question becomes, how do you create a digital version that can prove authenticity and cannot be modified? And so that's what a Smart Health Card is. So the QR code, first, it's not a URL like it typically is. When you scan these with your phone, it brings you to a website. These QR codes actually contain all the information, and that's all you need. You don't need a call back somewhere to verify the information. Of course, most of you here in Quebec, you might have not known that you've been using this standard. Here it's been branded as VaxiCode by the government. But your VaxiCode is actually a Smart Health Card. So if you want to learn more about what's contained there, then I guess that's a good talk for you. Before I delve into the details of the framework, how it came to be, and some of the security properties, I'm just going to give a description of how this QR code is created. to just have a clear representation in your mind of what's going on. So the paper information, name, date of birth, vaccination history, it's transformed into what's called a FHIR bundle. FHIR is another healthcare standard. It's called, I have to read it again, Fast Health Interoperability Resources. So that's how the medical EHR vendors, electronic health record vendors, they talk through FHIR protocols. So it's just a JSON structure with, if you can zoom in, you see the highlighted data is what's on the paper. That gets then encoded into a JSON web token payload that has some metadata about who created the smart health cards, some other metadata, the FHIR bundles in there. And then this is signed into a JSON web signature. But because the target is a small QR code with very limited payload size, we have to make an effort to make it small, so it's minimized, compressed, and then it's base64 URL. Then it is signed using the JSON web signature format, a standard, some header that's added, the signature is added there, and then anyone who has this data is able to verify, because they can look up the public key of the issuer that's in the header and verify the signature. This is then transformed into a numeric QR encoding. If you know anything about QR code, that's very standard. If you didn't know anything about that, like I did a year plus ago, then you go read that, and it's just a normal way to do that, to transform any data into a QR code. And voila, you have your final QR image. Of course, there's a lot of details surrounding what's happening there. So that's where all this is defined and specified in the Smart Health Card framework. So the goal of this framework, I've highlighted here, is to provide a way to provide authenticated and immutable medical facts. So it's not to act as an identity document. It's not meant to be a green check mark saying, yes, I can go into this thing. It's policies around the world, policies even across time, week to week, change. So the medical community wanted to provide a way, just here's the medical facts. These facts happen, and then some other part of the process needs to make decisions if that's an okay condition to do activity X or whatever. So as I said, it's not an identity document. It only has a name, date of birth, and it needs to be matched onto some other form of identification to make sure it belongs to the right person. And all this minimal set of data has been highly debated in the framework community to see, is that not enough data, too much data, and the level of risk about the usage of these things, and whatever level of fraud, right? So somebody with a matching name and date of birth could use your QR codes. Okay, acceptable, that's fine. All the specifications are open, and the work started before the pandemic in the medical industry, but of course it got accelerated, and COVID became the focus of the use case. And the success of this framework versus other approaches, there have been a lot of competing proposals in the US. There have been some other approaches selected in Europe. For example, they have the digital COVID certificate, the DCC thing, which is very similar to the Smart Health Card. It's just different set of decisions. They came up with a slightly different format. India has their own solution, and other parts of the world as well. But this one, you can find everything you want to know about that at the smarthealth.cards. My team, actually, we developed this portal, demo portals.smarthealth.cards. It allows you, if you want to go scan your own QR code and see all the details of it, as I've shown in the previous slide, you can do that. And a part of the success of the framework is its large implementation base. So it's been picked up by Apple and Google. So in your phone, they support it natively. There's a lot of specific apps in different jurisdictions, like Vaxicode here, New York, they call it the Excelsior Pass, and Louisiana also had their own wallet. A lot of states in the US chose to just use the common apps without their own in-province or in-state app. Okay, let's leave it at that for now here. Just to give you an idea of the adoption of the Smart Health Card framework, you can see it's mostly in North American or Canada and US standard with the deployments, but there's some other parts of the world that have adopted it and are more and more. Okay, so now how these things are issued. So first, to become a Smart Health Card issuer, you just set up you just create a key pair, very conventional cryptography. And well, in Canada, it's mostly the provinces and health ministries that do that. In the US, it's a bit more complicated. There's no central health authority that oversees everything. And if they do, they don't have the mandate to issue vaccination certificates to everybody. So it's mostly industry-based. So you will have some state registries. You're going to have some big pharmacies, like Walgreens or CVS. You're going to have your hospitals. They're going to be issuers. So there's a wide variety of parties. So they can all self-host and create their own key pair. And when a user, given a specific interaction with that party, can prove that, well, they got their vaccination, then they can get this QR code. It can be held on any medium. So it could be in a specific app. It could be on the Apple Wallet or the Google Wallet. It could be printed on paper. Makes no difference. And then later, when you go and present that to a party that has a verifier, you can they can just download the key that's identified in the QR code and validate the information. So in fact, that's one value of using a framework that's common and that's standard, is that when I came here during the pandemic visiting, I had my Virginia QR code, and at the beginning, the Vaxi code would not validate it because it did not recognize external keys, but at some point it did, so I was super happy that I could go to a restaurant, just scan my US QR code, and it was validated by the app, just because it was based on a standard and not a one-off solution, and vice versa. So my family, when they came to visit in the US, also they're external, because you have two versions here. The one that's made for travel is a confirmant Smart Health Card, so it can be validated anywhere in the world that supports the standard. So now, as I mentioned, anybody can just start issuing Smart Health Cards. Very easy to self-set up. There's a lot of software for it. Of course, not everybody should be trusted to be a valid Smart Health Card issuers. So the question becomes, okay, how do you create that list? In security and cryptography, we have this notion of PKI, right? Public key infrastructures. That's very convenient. That's the most common mechanism to establish trust. There's a trusted authority, and it can delegate trust in different environments, which in Canada was very simple, because everything here, the health care, is provided by the provinces. So here, each province became the authority about issuing these credentials. In the US, it was a mismatch of different things, as I said before. So there was a need to create, in PKI, we would call that a PKD, which is a public key directory. And this organizations, the VCI, which has been kind of renamed with a broader scope to verifiable clinical information, their goal is not only to oversee the Smart Health Card specification, but also to decide who is a trusted issuer. So there's a set to make sure that there are verified healthcare organizations that are actually handing out COVID vaccines. And then once they've been vetted and audited and verified, then they can be part of this VCI trusted directory. In fact, all the Canadian provinces are part of that directory. The directory is public. If you go to vci.org, you can see all the information. You can verify there. In fact, we were part of our team wrote some auditing software for that directory to make sure that everyone there is online, that their key sets are cryptographically correct, and that all the information is secure using the right TLS config and all these things. Okay, so that's the kind of overview of this kind of smart hell cards. I hope you have a clearer idea now what's in these QR codes. I'll now discuss a few few more security aspects because we're here at NorthSec. One thing that became very apparent, or soon, is that there was a need for a revocation feature for the smart hell cards. Normal certificates can be revoked, and in the smart hell cards, there's at the beginning of the framework, because of the rapidity at which the standard came to be, and because of the nature of the information, which are just clinical facts, so they should not change, or you don't lose access to these facts. So there's, the security practitioners among this group were not able to get a revocation feature day one in the specification. But of course, as it was easy to predict, there was some reported fraud, and not really on the cryptography of the system, but mostly on the human factor. Here, I've seen some headlines in Quebec about either nurses or medical practitioners getting bribed to get invalid entry in the vaccination registry, or you could have fake the paper trail and coming from cross-jurisdiction to say that you had your vaccine, then you get issued a valid credential that can be later proven false by the police. So we had to develop this revocation mechanism that was added to the specification. It came a bit later than after the first wave of QR codes were issued. So there are two mechanisms to revoke these cards. One that's forward-looking, where these cards can now have a revocation ID built in that can be listed on we use the acronym CRL for card revocation list here. And there's a legacy one that derives a dynamic revocation ID based on the content of the FIRE payload there. So you just do a hash of a few fields there. And these can also be time-stamped in the certificate list, the revocation list, so that if you're a naughty user who got fake your paper trail and then got convinced to go get a vaccine and therefore a valid card, then if you get your revocation ID, a card with the same revocation ID later, then you can be revoked up to a certain point, and then later your card would be valid. So that's one thing that emerged after the initial launch of the framework. The other work that I've hinted to a bit earlier was the VCI directory auditing and snapshopping. So the cryptography and all the security of the card itself is not too complicated. It's pretty standard. But the devil is in the details, and a big part of making sure of the security hygiene of the system is to making sure that these issuers are not they are trusted, right? So if you start seeing weird issuers there's going to be a lack of trust in the system. And the VCI got a lot of proposals to be joined, like, hey, I'm a clinic here, and I'd like to start issuing smart health cards. So there's been a big list of proposed issuers that have just been rejected because they didn't meet the minimal requirement of what's a trusted issuer. So so our team, we've been involved in the creating of two things. One is the audit script that I mentioned that just makes sure that once you pass the test to get into the directory, then you're still okay day after day, and not just your security just goes crazy, or you go offline, or you disappear. Then we keep track of that. The other thing that we've enabled also is to create a snapshot of the directory, including all the keys. Because the flow of if you remember the diagram, is that when you verify this QR code, so if you're the Quebec app and you verify Quebec QR codes every 5 seconds, it's fine. You have the public key. But if you're at a Super Bowl a sports stadium with visitors from all around the continent, then you might need to get different keys, and there's a lot of fetching keys all over the place. So you're able to download this offline version of the directory that the VCI provides, and you're able to validate the QR codes in an offline manner. Which, yeah, for big, when there's a lot of users and you don't want to have a lot of bandwidth, it could be like a transit station, New York metro station, for example, that would be useful. Okay, I think that's all I want to say about that. Let's see, how am I on time? Okay, that's good. So I wanted to present the work that's been done on smart health cards, but I wanted to reserve some time to talk about the future of digital identity. So I've been in this field for a while, and we've been pushing this idea of user-centric identity documents for users to be able to prove any identity facts about themselves to whichever stakeholder. It could be online, it could be in person. And I guess now the QR code that people had to present forever in the last year, then that kind of unlocked the imagination there and helped to explain some of these scenarios and make them very concrete. So as a immediate next step, we prototyped a system that's similar to the smart health cards, but instead of having a medical payload, it could have any claims there. So any JSON Web Token payload or data, any attributes, you can encode them in these QR codes. And you're able to present them and verify them in a similar manner. So, okay, let's. But one important aspect of that is the ability to add privacy on top of the framework. For smart health card, that's something that's been debated a lot. Okay, are you disclosing too much information every time you're presenting it? So when you go and board an airplane, you disclose your name, date of birth, and along with all this information already that they already know about you, and way more data that you have to present. But when you go to see a movie, you typically wouldn't want to or need to present a date of birth and a name even. So for a general identity document, then you don't want to force always presenting everything about yourself. And the main identity document that people have in North America is a driver's license. That's what you show to present some identity attributes about yourself. So to this claim QR framework, we've added the ability to present a subset of these things. So it's a simple mechanism versus more advanced cryptographic ones using zero-knowledge proofs that you could prove properties of yourself. Like I have a date of birth, and I can prove that I'm over 21. But that's a bit more complicated. What's very easy is just the ability to take the equivalent of a black marker pen on your driver's license and just hide the data you don't want to show and present the rest. So we call that subset claim disclosure. And the way it's achieved is that instead of the issuer encoding these claim data, these attributes directly, they're hashed and salted so that for brute force resistance. And that's what gets encoded in the QR code. And to disclose this value, you have to show to the verifier these digests, along with the data that was used to generate these digests. So it's as if you're presenting this driver's license with little puzzle pieces cut off. And you can see, you're seeing, you don't know what the pieces I removed, but if I take a piece, I can put it back, and you see that it matches perfectly. And that's the only value that could have been there. So just as an example, I have a little demo, but I think my slides might be more illustrative. So I'll just start with these. So imagine I have this data that I want to encode in a QR code. So I have a JSON Web Token, there's an issuer, the example.org issuer, there's an expiry date, and these claims on the right are the ones that I want to be able to selectively disclose. So it's my name, my real date of birth, I'm super young. And then these are transformed by the issuer, and there's a random salt, which is just a random value, and along with the claim attributes. And then these get hashed using the salt and the claim value, and they get encoded in the JSON web signature payload. Then using the mechanism I've explained before, these gets transformed into a JSON web signature. They get signed and then turned into a QR code. Now that I have that, if it's on paper, oh, sorry, I forget to mention the last part on the little green part of this GWS. It's an appendix, so it's extra data, and it's actually the claim data that would allow a verifier to understand these digests there that otherwise would be opaque. Now, when I'm presenting that, if I'm presenting that on paper for legacy kind of users, everything gets disclosed. But if I have an app, a client app that understands this, the user could decide to remove some claims, let's say removing these two pieces of data from the claim data object, and then regenerate the appendix with these two pieces removed, then regenerate the QR code, and present that instead. So what will the verifier do? He's going to verify that, yeah, the QR code is signed. The data that's on the bottom left side didn't change. That's the one that's signed. And I can prove that these two pieces out of 4 that I'm presenting corresponds to the data that was encoded in there by the issuer. So that's the mathematics of what I just said. I will go to my final slide instead of presenting the demo, which is something you can go and run yourself. It's an open source project, so if you want to do it, it's just a web portal that's going that would allow you to try that. But I wanted instead to spend a minute to discuss what I think is the future of digital identity for a user-centric approach. So some of us cryptographers that are dealing with digital identity have been proposing some of these ideas for many years. Almost 20 years ago, as part of a company here in Montreal that developed the U-proof system that's listed down the list here, doing all sorts of cool zero-knowledge proofs on data and being to prove properties about yourself without disclosing these said attributes. And it takes a lot of add some complexity to these systems. So I think these claim QR approach that I've just explained with the selective disclosure is kind of a let's go step by step in improving from the status quo and what's going on today. So that's why the type of projects I just presented, stepping off from what people have been used to, will allow us to get to these advanced features. Which, so one interesting thing, development, is that there's a new ISO standard that's coming out. It's called the Mobile Driver's License, the MDL, which supports a flavor of selective disclosure like I've disclosed. And it's going to be for, as the name says, for driver's license. I know it's going to be adopted in some parts of the States. I'm not sure about Canada. But that is that will be a big stepping stone and a big milestone for the world of user-centric digital identity. But there are more privacy features that will be needed also for long-term benefits. One is unlinkability. So all these tokens that you receive that are signed by an issuer, a signature is just, ends up being a random value, unpredictable value. But once you have it and you're presenting it, you're presenting essentially a long-lived cookie to different parties. So if two parties collude, or if a party goes back to the issuer, is okay, I got a ticket for the claim said it's an over 21 user. I don't know which one it is, but you sign and the signature is 0613. Then say, oh yeah, I gave that to Christian like 2 months ago. So, so this data can be randomized using what's called blind signatures, or you could prove you have a signature with zero-knowledge proofs without disclosing its value itself. So there are some approaches in cryptography that will allow us to break this linkage between issuance and presentation. And derived claims, which I've briefly talked about earlier, are a good way also to add some features and give power to the user. For example, to be able to show that, yeah, my date of birth is such that I'm over 21 without disclosing it, or here I would say over 18. or that my name is not listed on this denial list or this no-fly list or whatever without actually disclosing my name. So there's a lot of powerful techniques that have been explored. We've prototyped some of that. I'll just cite one of the projects I've been involved with in the past. YouProve does that, and there's some activity in the W3C verifiable credential standard that's upcoming, and people are also working on these type of features. And love it or hate it, the Web3 blockchain community have been developing some of these techniques, which is going to be for some of their blockchain type use cases, but also a lot of this base cryptography can be reused and applied in a wider variety of scenarios. So I'm kind of very excited about this work and the future for user-centric digital identity, which gives a lot of power and privacy to the user. So on these words, I'll conclude, and I'm looking forward to the questions in the next session. Thank you.
Thank you. Thanks a lot. So we'll be back at 3 for the Q&A. You still have some time to send some questions on Slido. Please do. There's a bunch of them, but you only have 10 minutes left to send some more. So eagerly waiting all your questions. Thanks a lot, everyone. right, awesome. Welcome to NorthSec Psychedelic Edition. So you're not seeing it, but I don't have the Q&A anymore. But it's all right, I have it here. So welcome to the cryptography block Q&A panel discussion. We're doing this live, so it'll take its own form. There's been a lot of questions on Slido, so I'm quite happy about that. With very interesting topics to be discussed. I think the first one, really, the first group of questions about DRAND, quite a lot of interest on the resilience of the network, the threshold, how many new nodes introduction would become a problem, what kind of protection mechanisms exist to avoid these kind of takeovers by nefarious actors, maybe someone thinking about what we have heard potentially could happen with Tor or other types of distributed systems. I don't know if you want to talk a bit about this, Yolan.
Can you hear? Oula. Yeah, so that's a thing I haven't really discussed in my talk, but the trust assumption and the way the randomness is generated make it so that it's enough for just a single node to generate proper randomness during the setup process for the whole thing to be properly random. So that's a very strong assumption. It's a very strong result because you don't need to trust any node but one, and then you're sure you get proper randomness at the end. So that's super cool. The current threshold is at like 12, so it means half of the network could go down, and that's I've discussed. But the thing is, as long as among the 12 signers you have one honest party and the signatures checkouts at the end, you're good to go. So the main issue is as soon as you have a threshold of malicious node, then they can collude, they can work together and produce signatures ahead of time, they can go faster, they can break the trust assumption you have in the network, and that's the main issue you have if you have a threshold number of nodes that are malicious. So the bigger the threshold, the safer you are against collisions, but the bigger the threshold, the less safe you are from a liveness point of view, because if a few nodes go down, I don't know, like if AWS goes down and we have like maybe 6 nodes on AWS, then we need to make sure the rest of the network will keep working properly.
Thanks. Yeah. All right. That's. I think it's a very good answer. There. Of course, lots of concern on resilience, but probably also on capacity. What's the speed like? How many random nonces can it generate per second, per minute, per hour? What are we looking like? Is the addition of nodes going to influence that? Are these sorts of things? I don't know if you can cover a bit on that.
Yeah. So the current way it works is each node will generate a signature every X seconds. So the current networks is generating one random 256-bit value every 30 seconds. So that's really the current bandwidth. The new network we launched on testnet is generating one value every 3 seconds. So it's way faster. The lowest we tried to go is 1 second. You could go lower in theory, but then you start to have issues with latency and the current latency on signature aggregation is around 800 milliseconds. So if you want to go below 1 second, you would need very good connections between the nodes, and it becomes then very also difficult to consume.
Yeah. All right. Quite a few questions for you, Christian. About claim QR and SHC. I think at the end of the talk, I'm talking about digital identity. some people, I guess, were kind of asking because it's in the air, so to speak, right? Especially here in Quebec, when we're talking about the efforts that the government is looking at for digital identity. Could Claim QR help, for instance, in replacing social security numbers or other elements of identity that we use on a not daily basis, but quite a regular basis, and we've seen issues with, leaks and whatnot.
Well, I think these types of credentials can help in day-to-day life. Maybe not so much social security numbers, because that's typically a very infrequent way, and the way they're leaked, it's not when they're presented, but mostly when they're stored in the database, and then the database gets exposed. But it's easy to imagine scenarios for things we use already, right? So the driver's license is the one that most people use to get into a bar or whatever. And but once you have these type of things in place, then you can imagine a lot more scenarios, especially online. Let's say your school could issue you a alumni credential you could use to get some rebates online at some restaurants or whatnot, or same thing, employers or employment verification. I hate to use this word, the metaverse identity. You could give your online avatars and present some actually identity attributes, and of course they wouldn't be in the form of a QR there. But if they're just packaged in a type of credential for which the user controls the key, therefore the ownership, and they can decide and select how this information can be disclosed and by whom. So I mean, user-centric in the sense of user empowerment. So okay, that's what the verifier want to see, and then I can make the decision if I want to present that information, and what's the minimal set I can present. That's why I like to use the word minimal disclosure. So the minimum that's needed for a particular transaction. So sometimes that's nothing, it's anonymous. Sometimes it's your full identity for crossing a border. So the QR form is interesting because it bridges the gap between these online credentials for which you need a key stored in maybe a smartphone, but there's a wide range of scenarios before that. That's just QR. You can carry it on paper, literally, and so there's a few opportunities, I think, that hopefully the ecosystem can help build.
Thanks a lot. And are there any attempts to kind of unify these various health cards that exist around the world? You mentioned that there were multiple competing standards, I guess. And when we're talking about digital identity, it might be just broader than vaccine scenarios. Are you aware of any such attempts to unify some of these standards?
Yeah, so there's no effort to unify them, the same way there's no effort to unify the passports. It's like each country do their own thing. And that's mainly the result of all the planet trying to solve the same problem at the same time in a very rapid time frame. So these identity specifications, they take typically years to develop. So it's a miracle that it happened in such. So I think the framework is like 1 year old. And the reason it succeeded because it was rooted in the medical world, where they want to use that for a long time, for for your kid's school vaccination history that you have to carry over from state to state and be able to present that to schools for travel immunizations in the future. So they say, okay, let's use this situation to build something that's going to be lasting and reusable. So that's why here it was successful, and other jurisdictions in the world had to solve the same problem for their own case. So in Europe, they decided their green certificate is not just the medical fact, it's also a decision. So it could be a lab test, it could be an exemption, and you get a green check mark out of that. So it was the different scope, different decision. Here I said, we don't want to make these decisions. Here's the facts, and whoever checks it makes the decision based on the current policy. Yeah.
Thanks. All right, I want to go back maybe to talking about we're talking about entities and how these get set up. You, Yolan, you've had to set up worked to set up the League of Entropy. I like this this name. But there were a few questions about how this was set up as an organization, how one gets to join it. Is there any paperwork involved? Is there any some formalities, or is it just open to anyone? I guess people want to maybe see what it entails and if they can help.
Yeah, so it's basically a question of how do you do your governance on your network, right? So currently the League of Entropy has a notion of each member is voting on new members to join. Maybe we'll come up with a better way to do the governance at some point where we can delegate voting power whatsoever, but currently that's how it is because we are only, as I said, 16 members, so it's still okay. To join, you just need to show interest, show that you've got the proper setup and infrastructure, and then you can onboard on the test net if you get accepted. And once you've shown you were able to run a node on testnet and it worked, you can upgrade to mainnet. So that's how it works on our side. Yeah.
So I guess if you got a bunch of lava lamps, you're good to go.
Yeah.
That's how it works.
Or even just a fish and some bubble generator in your aquarium, that's also chaotic. So.
Awesome. So there was a there was a mention, Yolan, in your talk about time-locked encryption, and I think there are a few folks that I'm seeing here asking, how does this work? I think it's a very new research and might be a bit complex, but can you maybe drill down a bit on how this is thought about and if there's going to be future work on that and what it's going to entail?
Yeah, so the time-lock encryption is something I'm super excited about because it's super cool, in my opinion, to be able to encrypt something toward the future. The thing is, we're still working on the paper and the blog post, so it's going to be released in July or maybe August, hopefully. We will also release an open source tool that allows you to use it, so no worries, it's coming. Technically, it's a bit difficult to just explain, like out of the blue without a whiteboard. But what you do is you take the value you want to encrypt, you pick a random value, which is secret. You can XOR the both together, and you get an encrypted message, which is a one-time pad, basically. You encrypted something with one-time pad. And now that random value will get committed towards the round in the future. And using the pairings, we can decommit that commitment as soon as the signature is published for that round. And that might give you a bit of an intuition of how it works, I guess.
So I guess his upcoming work, so maybe NorthSec 2023.
Yeah, we hope to be done before that, I guess.
All right, awesome. So let's step back a bit and maybe go into the the more theoretical applied crypto. There's been some questions about. I know, Christian, you've got maybe a bit of background there on quantum cryptography. What's in your opinion, and Yolan, of course, you as well being a cryptographer. What do you think? How far are we from mainstream adoption? What are the hurdles basically for it not to be post-quantum crypto, for it not to be adopted today? What kind of standardization do we need? Maybe what's the in your opinion, what's the road to getting there?
Yeah, first a little terminology explanation. So quantum cryptography, it's typically means quantum key distribution, which is the ability to using quantum mechanisms to establish a shared key that you can use then with conventional encryption. So I think that's very little chance of being widely deployed. It's been deployed kind of in pilot and very specialized environments. but the classical cryptography that we have today is sufficient, I think, for real-world scenarios. The other word, that's post-quantum cryptography, so that's what it means. It's normal cryptography that you run with ordinary classical computers, but for which we don't know how to break with a future quantum computer. So a quantum computer is a machine that, if we end up building, could break the crypto that we use today. And the problem, why is that a problem now, if it's going to be built in 20 years, is that you can record the traffic today and decrypt it in 20 years, which in some cases, if you're a Coca-Cola and you're trying to protect your recipe forever, then that might be a problem. This, as I mentioned in the talk at the beginning, just NIST is, which is the National Institute of Standards and Technology. They are working on replacements of quantum algorithms. So they're waiting any day now after a 3+ year process to see which is going to be the next round of algorithms that are going to replace RSA and the CDSA. And so these are the ones that they're very close to be picked, and then it's going to take a year or two to ride up and standardize. So we're in a comfortable, let's change the underpinning and the machinery of the crypto pipelines before it's too late. So I think that's in good shape.
Yeah, and if you look also at what's being done on the mailing lists and online, people are still not not agreeing on how we should do it. Like, should we combine current classical algorithms with the new quantum resistant algorithms? Should we switch over to the new algorithms even though the current ones have been battle tested and we know they work properly, or at least we hope they do? These are questions that still need to be answered, because if you want to do hybrid encryption, or you combine both quantum resistant algorithms with the classical algorithms, it's not the same as if you say, okay, we ditch the classical stuff and we jump on the new cool quantum resistant train, and people are getting worried as well, because recently, I think it was in the US, they said, okay, now all the top secret stuff needs to move on to quantum resistant tech, within 5 years or something like that. And people are like, what's happening? They didn't even standardize the post-quantum algorithms yet. Why do they do that now? So, yeah.
Yeah, I can just add a note to that. So that's a fair point, that there might be this transitional period where we're going to use hybrid encryption, hybrid in the sense of combining more than one scheme, and that's something that we've implemented. It's not something that's pushed necessarily by NIST, as their goal is to say is the new standard, but it's something that the industry is wondering about if that would be a good idea. There's this project which I've talked about in 2 NorthSecs ago. It's the Open Quantum Safe project. If you look that up, it's led by the University of Waterloo, and we've prototyped all the new algorithms, including in combinations in hybrid way with the current one with RSA or ECDSA or EC Diffie-Hellman. You can run that in OpenSSL and OpenSSH, see how it looks, and at the end of the day, there's going to be some people, it's going to be their choice, their policy to what's the performance versus expected security, and there's going to be a large body of people who won't care, that just follow the government standards, whichever they'll pick. So hopefully NIST will in the academic community will have picked good replacement. So at some point, that's going to be the new one.
All right, thanks a lot. I think that that leads kind of well into the next question, maybe a bit even broader. There's been a lot of we've seen the pickup of certain popular software like Wireshark, to give an example, versus OpenVPN. Very different approaches. And you've just mentioned that the government, the NIST will standardize some form of algorithm. Maybe people can use some other algorithm. In cryptography, there might have been some times where we had a discussion about enforcing sane defaults versus letting the users choose themselves what to use in terms of algorithms. What's your take on this? What would be a preferred approach? Should we let the users choose which algorithm when it gets standardized or some configuration, but then it could lead into the TLS, SSL TLS issues where basically death by a potential 1,000 paper cuts. So what's the theme there, the leading discussions around quantum resilient cryptography?
Yeah, I mean, I'll give a kind of large vendor answer. It's like Microsoft, which is we have such a varied set of customers from all over the spectrum. So it's really hard to pick for them. So as a crypto developer, it's kind of harmful to give too much choice, and it's easier to give just very minimal set of configurations so you can shoot yourself in the foot. On the other hand, it depends, so the cryptography in China is very different than in the US, and we provide software all around the globe. So the platform itself needs to be adaptable for that. But I think it's recognized, right? It's not mistakes because it's doing the best we can, but the crypto community learned a lot of lessons in the last 10 years. We see all the TLS attacks like Heartbleed and all these things year after year. And then the TLS 1.3 I think is a good example of a standard that had a good analysis and review by the academic community, and a lot of the research was applied there, and there's way fewer choices. So when it came out of the box, it was okay, great, like good configuration. And then the industry, or some part of the industry, fought back to trying to put back some features, like the RSA encryption, because they needed in middle boxes for traffic intercept for some time valid reasons, so that kids don't go and browse the nasty parts of the internet. So it's just when they're in school, right? There's going to be an equilibrium, but I kind of tend to like the direction where the practical security is going. So it's a complicated answer and situation for sure.
All right, Yolan, do you want to chime in? I know we discussed a bit about this topic earlier on.
Yeah, well, I would say crypto agility is a good thing for protocol designers and for software developers, but it's a terrible thing for users, in my opinion, because it allows non-crypto developers to shoot themselves in the foot way too easily. Like if you look at the Yossi spec, or they could choose the non-encryption algorithms, which wouldn't encrypt anything, and that kind of issues. I mean, sure, they wanted to do good and to provide a lot of options, but at the end it was too many. So I like also the way TLS 1.3 reduced the number of options to just a safe set, and how they did it. And I think it's super important for us as protocol designers to be able to quickly switch to new algorithms if we see something got broken and that's not working anymore. And it's, in my opinion, also a good reason to go the hybrid way rather than directly jump to quantum-resistant algorithms. But yeah, we'll see.
All right, so I guess the debate lives on, but there's a tendency towards simplifying things and leaving less options to shoot yourself in the foot. All right, so it was a great session, lots of good questions. I went through most of them. Thanks a lot, Yolan, and thanks a lot for all the help and answering these questions, Christian, as well. If you have any more questions, you can probably find both gentlemen maybe grabbing a beer at the bar or later in the chill room. Thank you all for submitting all these great questions, and I guess see you on the next block, and that will be the red team block in almost 30 minutes now. Have a good one, everyone.
Go ahead. Thank you.
Hello, hello, hello. So welcome to the last block of the conference, the red team block. So I'm going to present to you your moderator for the next few talks. His name is Martin Dubé. He's been hacking for 15 years. You might know him from his challenges and his Windows track at Hackfest. He also did it for 1 year at NorthSec. You remember the Neurosoft, the Windows track, that was him. So give all your thanks for all your points that year to Martin Dubé. And now he leads a large team of ethical hackers, one meeting at a time. Please welcome Martin Dubé.
Thank you, Hugo. I hope you have a very, very good NorthSec, as good as I do. I hope also that you will really enjoy the CTF this weekend. I'll jump right in with the introduction of our next guest, Olivier. Olivier, I know Olivier since a good time, and I really, really appreciate his work in, especially all the open source stuff he did, like mailboxes and many more products, tools. Olivier he gave so many conferences at Black Hat, DEF CON, BotConf, DerbyCon, Hackfest, NorthSec. He's involved in NorthSec Montreal, and you will see him at a lot of places. And today he's going to talk about RDP, which of course is a remote desktop protocol. He's been studying for the last 3 years this protocol, and today he's going to talk about how to attack and defend RDP. So I'm pretty sure it's going to be awesome. Thank you, Olivier.
Thanks so much, Martin. A round of applause for Martin. It's true that it starts to be way back, right? Since we know each other, it's pretty crazy. Anyway. All right, so originally today, I planned to talk about the risks of RDP and how to mitigate them, but then I realized I only have half an hour, so I needed to adjust. So this is some risks of RDP and how to mitigate them. But then I found some problems, and it became some risks of RDP, how to mitigate them, and a villain reported to Microsoft. So we're gonna go through this. It's a heavily edited edition of the talk I gave a month ago at ETSCon, which was 45 minutes. So I switched a bunch of things, and some of it might not be super coherent because I was doing CTF 101 yesterday, and I had a Hacker Jeopardy tomorrow, so I didn't have as much time as I wished I had to prepare. But you'll have a great ride, I'm sure. All right, so about us, no time for that. No, actually, I should say, so I was supposed to present with Lisandro, but Lisandro, his visa didn't get approved in time. So apparently, when Immigration Canada says it's gonna take 23 days, well, they don't mean 23 days for real. And it's not even 23 business days. It's like 23 days of Jupiter or I don't know what. But one day, you'll see Lisandro, I'm sure. He'll have a visa. They are good for 5 years. So once he'll have it, he'll present here. Either here or at GoSec, we'll see. All right, so it's just by myself. So RDP. RDP, as many of you know, is the remote desktop protocol. It allows you to connect to a remote system and have graphical mouse and different kinds of I/O forwarded in a secure fashion. And it is basically, like for geeks, it's like SSH with more features and or problems. So the RDP layers, so this is why this needs time, but you know what, let's forget about most of it. It's not that interesting, and it's been already hammered on a lot of time before. So we're gonna focus on I/O, clipboard, and drives. And by I/O, we mean display, keyboard, and mouse. So these are the areas of focus of RDP today. So RDP security, what happens with RDP? You have at the beginning, like ancient history of RDP, you had RC4 and graphical login. So why I precise graphical login? This is pretty important in the design of the RDP protocol, and its early flexibility, but was also a mistake. So we're gonna spend some time on that. But so RC4 was a custom, I think, semi-hard-coded key. Anyway, right now, almost nothing supports it. And if you do that, people can pwn you in like fractions of seconds. Kane Enable supported breaking the RC4 connection mechanism like 15 years ago, I think. So what most people doing non-NLA, which is the modern one that we're gonna get into, uses right now, it's TLS plus graphical login. And yes, this is the TLS like transport layer security, but then everything, like all the channels, IO channels are set up, and then you authenticate via the keyboard and mouse and graphical, which is a lot of code and surface. What happened after is TLS plus network level authentication, so NLA, which relies on CredSSP, and we're gonna talk about that. And I had planned on talking about remote credential guard and restricted admin, but these are not enabled by default either on the server or the client. So unfortunately, they didn't make the cut for the 30-minute version. So risk of RDP, well, of course, the biggest risk is monster in the middle attacks or Mallory in the middle or meddler in the middle. I don't know what to say anymore, but I don't want to say man. So it's going to be monster in the middle for me. All right. So what are the risks? Well, the risks are of a security downgrade attack. So NLA goes down to TLS, and this works by default. What happens also is that user can click through warnings, although you'll see later that this might not be relevant anymore. And the impact of that monster in the middle attack is access to display, access to keyboard, access to clipboard, server-side takeover, client-side file stealing, and client-side takeover, implementation pending. We'll have that one day. So why am I talking about RDP? Well, I have a shout-out slide way later, but I need to address that two of the guys who worked on PyRDP are back there in the corner, Emilio and Maxime. A round of applause for these guys. And Emilio presented about PyRDP here, but this talk is basically the broader protocol, look into the protocol instead of look at the tool of it. But so all these references, which you'll have available as clickable links in the slides, are to the stuff where we presented PyRDP and how to use it. So we're not going to spend time on that. Just going to focus on risks and impact. But without these guys, none of this would be possible. So what does a protocol downgrade looks like so you can identify that risk? So the normal flow for a modern RDP connection with NLA is you get a dialog, a native on the client side dialog that where you input your credentials, and then you go you get the certificate error, if any. If you don't have certificate error, you don't get any. If you map a drive, you'll get an additional warning because mapping a drive has security implications, which we'll see. Now, what does the degraded flow looks like? So if someone has PyRDP in front of you somehow, what you'll have is you'll have the certificate error first and then a graphical login. So on any system that you connect, then you get to a graphical login, there's something fishy going on because in most cases, even if RDP is not RDP, even if NLA is not enforced on the server, if your client supports it, it will be upgraded to NLA automatically. So having the graphical login is shows you that something's really trying to negotiate at the lower security level of RDP. So this is basically one of them is the graphical and the other is the Windows native. And so why did Microsoft did graphical login? Well, I assume that it's for flexibility reasons because everything is delegated to the graphical pipeline. So no matter how you want to authenticate now or later, you can do it because as long as it relies on keyboard and mouse and graphical interactions. Whereas when you implement this like the right-hand side, then it's at the protocol level. So if you want to change anything, it needs a change in the protocol, which means a change in the client and the server. So they kind of thought they were smart, but they weren't. So NLA, so it's, as I just said, authentication before the session establishment. What are the security advantages? Attack surface reduction. Think of all the code that is exercised to do all of these mouse input displays and stuff. I'll show a list later. Also, DOS resistance. So if you send one packet to connect to RDP, and then the server replies with like virtual channels and display bitmaps and stuff like that, then you can do potentially use that as a denial of service. And also, a lot of resources on the server side are allocated to set that up, right? Oh, I have a client, I need to set up a whole virtual desktop shell and allocate like at least 60 megs of RAM, maybe more. And so if you do that consecutively, then you have a DOS on the server side. Also allows a single sign-on. It was introduced in RDP 6 by default since Server 2012 and Windows 8. And it's the famous tick box, usually in a lot of legacy system or shady deployment things. You'll see like, oh, go untick that, you know, then you shouldn't do it. So I mentioned the attack surface reduction. Imagine all of this needs to happen at the server side and on the client side even before authentication is done. So the untrusted user has access to all that surface. And this is why they got rid of it by using NLA. Now, what does the authentication part of NLA looks like? So it's called CredSSP, and inside the SPNego, you can do either NTLM or Kerberos. I'm not super good with the AD stuff. I'll need help and some further research is related to that. But what's interesting that I want you to get out of this diagram is that the crypto prevents a monster in the middle attack because it mixes the fingerprint of the public key with the challenge, which means that you cannot monster in the middle it in the TLS sense, like negotiate on the one hand and then fake a new negotiation to the victim. This doesn't work because of that mix in the challenge. So how do we attack NLA? What are the risks? So the first one that was obvious, because I mentioned it earlier, is the downgrade attack. So that works. How do you prevent the downgrade attack? Well, you enforce NLA at the server side, obviously. And you can also enforce it with PowerShell or with group policies, which are listed here. And one of the group policy way prevents users from disabling it later, even administrators, which is good. Now, we were like, okay, that's not cool, but how do we attack these environments? So we thought, well, if the server decides, what if, and we are in the network path, how about we redirect it to a machine we control? Well, it works. So we detect that NLA is enforced on the server side. We decide, okay, we forward the packet to a different destination, to an attacker-controlled non-NLA system. And if the user is curious and clicks through the warnings, he'll get in and we'll have him. So this non-NLA redirection, unfortunately, is as designed. So we had an exchange on Twitter. I asked Marc-André Moreau, a very prominent expert on RDP, like, what can be done about it? Isn't there a way to enforce NLA in the client? And basically, it was like, not really. And unfortunately, the more mitigation advice, the good news that I had is the stuff I cut from the deck. So I'm going to tell you right now, if you want to mitigate this attack, you need to look at restricted admin or remote credential guard. Why are there two different features? Because one of them works for AD and Kerberos environment, and the other one works for when stuff is not domain joined. So they cannot overlap. The technologies are just incompatible. And this is why it's not enabled by default, and this is why this whole thing is a mess. So the third attack, Alex Beaulieu, who is probably, or maybe not, but he is at NorthSec, did implement that attack. And so we whiteboarded this with Emilio way back, and we were like, they got the crypto right. Unless we found an implementation error, there's no way we're gonna attack that. And then Alex, one day working on PyRDP, said, well, this blue part, you're right, we can't attack it. But I realized after it's done, we fall back to TLS. There's no keying material derived from that used after, which means that if we have the server's private key, which works in forensics context or honeypot contexts, well, we can just pass the encrypted blob, don't look at it, don't understand it, and then we fall back to TLS, and so the attack works. So we are able to attack, well, the whole world is able to attack RDP NLA if, and it's a big if, you have access to the target's private key. So I'm gonna demonstrate the NLA attack, the NLA bypass attack. And for this specific case, we decided to try if we use Let's Encrypt certificate. Does it work? Do we get warnings, certificate warnings, or not? Can we use pretty much any cert to authenticate RDP? And look at this. Gonna pause it a couple times. So we are connecting, so on the left-hand side is the victim. On the right-hand side, the shell is PyRDP running, and we are opening the player. So the player is the interactive attack tool where you can take control of the RDP session. So now we set all that up. So the victim connects. First warning. Okay. First warning, I'm mapping a drive. So this is expected unless someone click, don't ask me again. I never do that because I always want this to be in my demos because it's important, caveat, to understand. So if the users are properly trained, this doesn't happen. Well, I'm clicking through anyway here, but then no certificate demonstrated. I'm authenticating, the victim is authenticating regularly. We have control, and this is an NLA system. And you can see on the top, the padlock, right? So no certificate error whatsoever, nothing was, no warnings, and the padlock is there. And then access is granted. And so this now will become a generic short video of the risks of all the stuff that we can do once we convey the user to get in like that. But think about one scenario. So man-in-the-middling someone where you have access to the private key can be a relatively rare occurrence. But so one way this was weaponized in red teams is that you send a .rdp file as an email attachment, almost no provider blocks it. Credentials are pre-populated. Oh, like we see, so right now I am capturing all keystrokes. I am saving files from the client at the attack level without the client knowing that files are being looked at. And you can save them interactively. This can also all be automated to be done automatically because it doesn't scale in a pen test to be looking at people's screens like that. So now we're looking at the secret. And it was collected, and it's a video from ATS account, unfortunately. But so the red team technique that I just mentioned is called Rogue RDP. There was a nice blog post by Ready Today guy. It's in my notes. I don't have access to them. But Mike Fetcher, a red team guy from the US, and he's very good and very solid, and it works, right? Because all of the IOCs or all of the stuff generated is coming from legitimate processes of the Windows stuff that works on the server and the MSTSC on the client side. So it's kind of something that is flying under the radar right now from a lot of the EDR's perspective. So now we're taking control. So this is another feature that I wanted you to realize. So you can see that on the right-hand side, stuff is happening because we took control. But what we do on the client side is we just block it. So you don't see anything, and then you can run a payload. This was an example. And then we can give back control to the client, and then the client will have access to the system again. Last is the clipboard stealer. So an interesting thing about the clipboard stealer right now is that I use the clipboard on my host, but it is automatically shared to my client VM. And this is automatically shared to the server. And the server always says, I want it. So boom, clipboard stolen. We are collecting stuff from bad guys right now using this clipboard feature, and it's pretty interesting. Chat messages, IP addresses. All right. So, what's the vuln I mentioned at the top of the presentation? Well, it's the net NTLM hash capture. It's a feature Lisandro added back in November, December. I reviewed it for a long time. It was complicated. So we figured, like, the NTLM exchange, okay, we need the private key for the NLA stuff if we want to do the NLA bypass attack, but the handshake is still happening. Can we fake our own challenge? Instead of using the server's challenge, we can never do anything with it. Can we generate our own challenge, and then whatever the client sends back to us, we're going to use it for to crack the hash. So we can crack that net NTLM v2 hash. And we knew it was going to work because Responder implemented it. But it's like, it was super badly documented, and Responder is not a comprehensive RDP system, so they really did what they needed to do in order to do the attack. But we wanted to support all RDP versions and integrated this in our toolkit. So we thank them and we give them credit for having come up with the attack, but we implemented it in our own tool. And so what this looks like is that we basically, in the monster in the middle layer, send a challenge, as I mentioned, we steal the hash, and then you send this to John the Ripper or Hashcat. And so it looks like this. And when you crack it with John, for example, with the word list, you do then crack them. So again, this is a hash cracking attack. So depending on the complexity of the user's password, it might not yield to automatic results. But as Pentester will tell you, the more you collect, eventually you'll crack one. So how can you prevent this hash capture attack? You verify the connection to the RDP server. So server address, domain name. You always look for valid certificates. But as I've shown, you can get a Let's Encrypt one. And turns out that you don't even need to respond to the HTTP challenge of Let's Encrypt in order to get one. Someone, after seeing my talk, sent me a resource on how you can generate Let's Encrypt certificate for your LAN. So there is a way with the EFF to do that. So if attackers would be doing this, it could get nasty. But what I wanted to get at is, how bad really is it? And this is where we needed to report something to Microsoft. So we have our victim on the left, attack tool on the right, and we're connecting. We're sending a password. So okay, I did a failed login attempt just now. I know it's super small. Trust me, we have the hash at the right-hand side. It doesn't really matter. Just trust me here. But so I did a login attempt, failed, but we did collect a hash. But where was the certificate error? We didn't get it. Is it possible that it happens after? So this was for a login failed. Even if the login is failing, we could still crack that hash, by the way, and get the password that the person did input. So now, at the second time, I put in the right password. Whoops, missed it from a split second. So if the user correctly authenticates, you will get the hash that you could crack, and this puts the client in just a weird state, and so it happens to do an RDP connection, internal error occurred. And I've played with this for a long time, and the internal error is so deep that all subsequent connection, even good ones, are gonna fail. I don't know what's changing in the state of the client. Something's getting really weird here. But so this means that we can collect legit hash of a user that's successfully authenticated, and the error message is kind of not obvious, not something you're gonna report to if you're being attacked to your IT. and you had no certificate error. So this means, let's just finish. Is it long? I think, okay, so yeah, the video ends with, we're gonna take the hash and we're gonna crack it in John. I have time because I cut so much content, so I'll let it go to the end. We'll see. And the password is a bit, it's purple, I think. But, so, use John on the hash. So, PyRDP features can attack a whole LAN, by the way. So if you are in the middle on the network path, you could, just monster in the middle a whole /24 and then just collect these hashes and try to make sure that when the user gets pissed off, you just, shut down the thing so that they can work. It's pretty destructive attack, I have to admit. But so imagine in an internet cafe or something like that. So here, the video finishes with, we crack that hash. But so, what does that mean, okay? It means that pretty much you must never use RDP on untrusted networks, because everything by default that could be done, was enabled, but still we collect the hashes. So without VPN, RDP, thrown in the garbage. Or, at your home, maybe you trust your network, that's fine. We're not even in internet cafes much anymore anyway. But so the other thing we can recommend is avoid NTLM, use Kerberos, and audit NTLM usage. I was told this is possible, but I would need someone with better knowledge of AD to help me in that research. I just don't have the lab or the capacity or the enterprise network to validate that. And I don't know how practical this is anyway. So wrapping up, attacks on the client. What can we do? What are the risks? So we can steal files, clipboard, keystroke, record the screen, steal hash, or plain text credentials. So if we can perform the downgrade attack, we steal plain text. If we can't, we can steal hash passwords. We can do code execution via DLL sideloading, implementation pending. But this is what the red teamers are doing with the rogue RDP system, and they are using PyRDP, by the way. But so, the way I say implementation pending is that we have access to the file IO channel. We just created it to steal stuff right now, but probably before the next NorthSec we'll have a path to write files. And so the right now trendy attack is you put a DLL in the Teams, very popular Teams chat client. And Teams is vulnerable to DLL sideloading, so you implant a DLL with the good hijack stuff in it. And so if you generated the DLL specifically for the target, so it's not, the hash is not known, then what TTP can the blue team really get, right? Because this is coming from RDP, stuff that no one's looking at right now. So I think this is probably a very effective red team technique to use. But I'm only a researcher, so maybe the practicality is not there. If anyone is really trying to use it, go look at the rogue RDP stuff, and if you want help or feedback, I would be interested. But we need to talk about the blue stuff too, right? We need to fix this. So attack that can be done on the server, well, credential brute forcing, sessions takeover, command injection, as we demonstrated. Now, the future, we're just opened up so much. So RD gateway, I'm not looking at remote desktop gateways at all. Apparently, I can probably support them and attack them. I would like to see, do we have any options for, I want the TLS certificate to come from a specific CA, otherwise I don't allow the connection. This would get rid of the whole, let's encrypt can sign any cert, and this makes the user think he's safe. I want to look at NTLM restriction, shadow framework, which is both on the defensive and offensive. And I want to start documenting some of this stuff in blog posts. Now, what are the red team takeaways? I'm wrapping this up. So RDP is often misconfigured and under the radar, and you can do more than credential brute forcing with it, I think. So it should become part of your attack toolkit. And again, this is niche, corner. Try your regular stuff first, but think about it once you are against walls. The blue team takeaways now are never allow your employees to use RDP on protected networks. And I know this is completely opposite of the zero trust people who are trying to get rid of the VPN, but you'll have to encapsulate this in a web somehow, right, to remove all of these attacks. So if you're like, oh yeah, we're zero trust, but RDP is still going like on its own without a VPN, it doesn't work. Train your users not to click through certificate errors. Now, make sure NLA is enforced by default. And I gave the group policy to do that in the talk. And long term, we'll have to think about, and you didn't have the research, unfortunately, but you'll have to think about rolling out either remote credential guard or restricted admin for client-side enforcement. But since I've written these lines, Microsoft patched last patch Tuesday, maybe not this month, but the one before, it was a critical vulnerability in enterprise network having either of these activated. So some people are still finding problems around those security technologies. I want to give a big special shout out to Marc-André Moreau, Await Coding. He works for Devolution, and he is really helping me validate. Like when I'm like, is this a vulnerability, or does the Microsoft people already aware of this? And he's like, no, I think they're not aware of that. I think they haven't looked at it that way because they're not attacking it like you are. So he helps me a lot, and together, well, he's like really connected with the Microsoft guys, and he's like on Twitter, like tagging them and saying like, you should look at this and reply to this. And so Devolution are really trying to fix the problems of RDP that even Microsoft is in denial of it. I opened a case with them regarding the NetNTLM attack, and they said it's as designed. They closed it 2 weeks ago as designed. I don't know what I'm gonna do with it, but I mean, so while I'm looking at attacking RDP more, he's looking at like, okay, how can we completely ignore it? He works for Devolution, who are providers of remote access, security, and stuff, and they had a booth here at NorthSec. But they are really trying to do the right thing and have the problem fixed in Microsoft's product. So I'm going to finish with the thank you. Special thanks to those that made PyRDP possible. So Citroneur, the RDPy guy, Emilio Gonzalez in the back, Francis Labelle, I haven't seen him, but he might be here. Maxime Carbonneau in the back, Alexandre Beaulieu, and Cool Acid. And so I had a question, but it's more, see you at the panel. Thank you for being here.
Awesome work, Olivier. Awesome. So don't forget to send your questions on Slido, and we'll take a 5-minute break. We'll see you after. He has a diverse background with several experience in military, radio, satellite, IoT, home automation, and all kind of fun stuff. So, and I think you mentioned you were working on some certifications, so I wish you good luck with them. So we're gonna have a talk about passive recon and intelligence collection using cyber-squatted domains. The floor is yours.
Yeah, so hi guys. Thanks for sticking around until the last talk of the day. I know everybody's probably pretty tired. This is a little bit less high tech than Olivier, so hopefully easy to follow along with. And if we go through it a little bit quicker than half an hour, don't hold me too accountable. This is a subject that I've been thinking about quite a bit since some work I did with the Army about 2 years ago, taking a look at domain names in the public infrastructure. I've been quite curious about what's possible with a sort of a low-hanging fruit style of attack. Probably a lot of you, especially if you're more technical, familiar with the internet and the way it works. DNS is not a mystery, full of vulnerabilities. In the Army, we talk about something called an asymmetrical attack. So the cost of putting a roadside bomb, for example, is a fraction of the cost of defending against that attack. I think this is a similar thing in cyberspace that's worth considering. It's something that's been around for a long time, and we'll dig into that a little bit. Yeah, so introduction. Currently SOC analyst at Commissioners de Quebec. Big thanks to JP and the rest of the team for encouraging me to come up here today and give my first talk at a security conference. Thank you. It's a hell of a place to do it too, so it's exciting. Also cyber protection team lead with 34 Signal Regiment in Westmount. We're a reserve unit in the Army. Previously spent many years working as a home automation integrator, smart home guy, a lot of custom AV, home theaters, lighting control, HVAC, that kind of thing. Also software product manager for a mobile app where I spent a lot of time dealing specifically with user behavior and user issues. So there's a lot of overlap there too. I think this talk is a bit of a culmination of a lot of my experience. So what's on the agenda? I want to talk quickly about human fallacy and the role it plays in some attacks. I want to talk about DNS specifically, some of the challenges with that, and email security challenges. We're going to take a closer look at cyber squatting and maybe refresher for some of you, maybe some new angles to think about. And then I want to bring you sort of on the inside of a little evil experiment that I conducted over the last 45 days. And then obviously we'll talk about protecting ourselves and our organizations, and then some closing thoughts. Maybe we can talk about more in the panel. So it's a cartoon that resonates with me pretty well. On one side we've got data security and firewalls and everything that goes along with that. On the other side we have Dave, who's the walking epitome of human error. Because the point is that you can put a lot of technical controls in place, but it's really hard to account for some of the human factors involved. Now, we see that firsthand. A recent report, probably all saw this in the news, was released by Bellingcat. A bunch of US soldiers were using flashcards to study overseas, and were leaking top nuclear secrets. Some of the most top secret information in the United States was revealed. 100% human error, AppSec issue there. More recently, City of Ottawa, we saw humans involved in a scam, a social engineering experiment where somebody was pretending to be a partner on behalf of the Salvation Army, requesting the City of Ottawa change the bank account that they transfer money to, and made away with $558,000 in city funds, 100% human-driven. Probably my favorite example, if anybody should be secure, it's the President of the United States. AppSec fail. Even surrounded by the best people in the world in cybersecurity, arguably, still using a password like Mega 2020 was the first example, if I remember correctly. Second one was "You're fired." Happened twice. His account was guessed by security researchers from I think it was Denmark. So why does all of this matter? According to Egress report, 94% of organizations have experienced a data breach in the last year, with human error being the leading cause of serious incidents. On the other hand, only 21% of technology leaders surveyed said that human error was their biggest concern. Mid-pandemic, this issue's only grown. Accidental and improper sharing of data by employees has grown to become probably one of the most critical threats facing or concerning security leaders. And then finally, the last 5 years and even up to today, we see a growing concern with the introduction of things like GDPR, privacy protection laws, CCPA in California, more close to home, Bill 64 in Quebec, and other such privacy regimes, where the penalties imposed on organizations and the costs incurred are much, much higher, and it's now a regulated issue. It's no longer, should we care about security? It's you better care about security or it's going to cost a lot of money to the organization, and in some cases even criminal liability. So let's back up a little bit. Let's talk about what is DNS. I'm not going to read the slide. I'm not going to take you through how DNS works. You can do that research on your own. But essentially, DNS is a system that is designed to point users to IP addresses and software applications to IP addresses, because humans have a hard time remembering IP addresses. Names are a lot easier to remember. DNS has a long history, started all the way back with ARPANET in 1972. The concept of a host, or an ARPANET host name, was introduced. And then Dr. Paul Mock-Petras, pioneer of DNS, publishes RFCs 882, 883, with some evolutions by 1986 into RFC 973. And finally, the ISC is founded. DNS systems that we still use today, like bind, are introduced. By 1987, with RFC 1034, 1035, we basically have the DNS that we still have today. It's a 30-year-old technology that hasn't really evolved in 30 years, long before a time when people were thinking about cybersecurity and what are the security implications of the way DNS works. For those of you who study internet history, you'll know that the internet was not designed to be secure. It was designed to be robust. So a decentralized naming system was designed to stop a bomb from destroying our infrastructure, and it was to route packets and be resilient, but not necessarily concerned about data security or privacy. So, important considerations for putting on the black hat for a second. The important consideration is DNS, not built with security in mind. We didn't talk about it, but you probably all know that it's very trivial to register a domain name. You can do it anonymously, go buy a prepaid credit card at Shell, throw it into your registrar of choice and register a domain name. It's very inexpensive. And finally, humans often make mistakes, and the component that DNS relies on is human input, more than anything. It's built for humans. So those are the things we want to keep in mind. Step aside for a second and look at email. Let's look at email. Again, first thing we'll notice as we look at the diagram is that the very first step in composing an email is choosing a recipient. And how do you designate a recipient? You put in a name, add a domain, and right away, email is dependent on the domain name system. And if we take, forgetting the details of email, if we take this concept that DNS is inherently insecure, if email is dependent on it, well then email is also insecure. History of email, very similar timeline. I'm not going to go through it completely, but roughly the same timeline. We're looking at email that by and large hasn't changed. And I know some of you are probably thinking, oh, well, what about DNSSEC? And what about encryption? And what about all of these other protocol extensions that have come to pass since then? Well, let's do an exercise. Show of hands, who sent an encrypted email in the last month? Okay, I see about 5% of the room has done that. Now, show of hands, who sent a sensitive document by email in the last month? Okay. So different people, different priorities. It's maybe not the effect I was looking for there, but the point is that email is basically unchanged since the last 30 years with some minor caveats. Important considerations, we know email is not built with security or privacy in mind, really. It's trivial to send or receive emails anonymously. It's actually quite easy to stand up and operate an inexpensive email server or email infrastructure. And once again, humans make mistakes, and they make them quite often. Let's move into cyber squatting. So I'm sure you all know what cyber squatting is, but basically it's the practice of registering a domain name with the intention of infringing upon the intended destination of the user. So I could register SouthSec. That might be a form of domain squatting, trying to leverage the trademark of NorthSec. Just one shitty example. Many different types of cyber squatting. If you break them down into categories, we can look at typo squatting, which is quite common. So in this example, we have something like Gmail or Facebook with an extra O, simple typo mistake put in by the user. We have bit squatting, which is really interesting. It's when cosmic radiation from outer space comes and interferes with whatever's stored in your memory and flips a bit in the character. And all of a sudden, you typed in Microsoft, but you ended up with microsoft.com in memory in the computer. And that's what gets processed by, in this case, DNS. Combo squatting, so taking a brand name, putting a dash in some other trust word or something like that. It's not owned by FedEx, but it's made to look like it is. Homograph squatting, which this is an interesting example. Hotmail to a human looks exactly the same as Hotmail to a human, but in this case, it's a different character. It's not the same character that's registered in DNS. Finally, PayPal. This one is a shout out to all the francophones out there. paiepal.ca. And then level squatting is another interesting technique that we see a lot, especially with mobile, given limited screen size. Sometimes what happens is the domain name is truncated to the left-hand side and everything on the right-hand side is ignored, so the user's not actually paying attention to the real domain or TLD. So, cyber squatting, not a mystery. We see it all the time. It's very common in phishing campaigns, as a way to bait people into clicking links that seem trustworthy. It's also a very common technique in spam and marketing. One thing that's maybe a little less common, but still out there is watering hole attacks, man-in-the-middle attacks. And finally, the thing I want to focus on today is intelligence collection and using this as a tool to gather information against a target. So let's get to the fun part. Time for the experiment. I want to put a disclaimer out here. So when I started this thing, I didn't know what I was going to find. I was kind of hoping like maybe somebody's going to send me an email and it'll be interesting. It turns out I actually collected an enormous amount of personal, private, sensitive information. None of it's going to be shared. It's all going to be anonymized. I'm going to give you the meta-analysis, and everything that I've captured is basically analyzed and deleted on the spot. I'm not interested in anybody's private data, but I am interested in showing what's possible with this kind of attack. So I had a few hypotheses going into this thing. My first one was that some small, but given a large enough scale, not insignificant number of users, will mistype the domain name of a popular email address when they're typing in their recipient. I'm going to mistype the domain. We should be able to register some of those typo squatted variants. They shouldn't be that expensive, and we should be able to do that easily. And then finally, the hypothesis is if I put a catch-all email address on the end of that typo squatted domain, I should start receiving emails intended for other people, but they're coming to me. So some of the key questions I had is, what kind of data can we capture this way? Is it possible to remain passive and anonymous in doing so? And can we employ similar techniques, can we detect other actors employing similar techniques? Can we hypothesize who might be out there doing a similar approach? And finally, how can we defend ourselves against such an attack? So you'll remember the email diagram from before. So this is a shitty edit I've made to it to sort of convey the idea. So Alice means to send an email to bob at b.org, but he mistypes and he types in bob at c.org. Well, the email server has no problem with that. The email application accepts it, sends it for an NS lookup, and there's an MX record at c.org, and it says, yeah, sure. I'll take an email. Yeah, we've got a catch-all email address. I'm happy to receive an email for bob at c.org. And the email gets processed and delivered right into, in this case, the attacker or the malicious listener's email inbox. So just a little bit of info to set you up for how the experiment is set up. We have 12 different domain names that were registered, and I want to give a shout out to a colleague of mine at Commissionaires. I don't think he's here today, Simon, who'd also done some similar work here and was able to help me get this set up. We set them up on a shared webmail inbox with a catch-all email address on every single one of those domains, and we let it collect data for 45 days. Okay, so results. 123,000 emails. I was hoping to get like 5, okay? 2,700 emails per day. That's like 1 a minute or something ridiculous. You can watch them come in real time. It's really interesting. You might be wondering what kind of emails we received. Well, a lot of this. There's a lot of spam, which was the first challenge that I came across was, how am I going to eat all of this? There's like a ton of spam to deal with. It's ridiculous. So the vast majority of it is spam, frankly not unexpected when you stop and think about it. Maybe for the next iteration of this talk, we'll talk about who the top spammers are. And there's probably a lot of work that could be done just around analyzing that. But that wasn't the focus of the talk, so I didn't spend too much time on it. So emails of interest. Here's where things get really interesting. So I received, at last count, 204 Interac e-transfers with a total value of tens of thousands of dollars. A lot of package tracking links, and not the spam variant that you're all used to receiving. These were legitimate. Personal banking notifications. So whether those are like, you spent money. Some of you probably get those when you use your debit or credit card. You spent money here. You spent money there. There's a problem with your account. Your account balance is running low. Those types of emails we collected and classified them as personal banking. Sales receipts. Lots of sales receipts coming in. Sure, any one of you shopping downtown, you've probably been asked if you want to receive an email receipt. Well, maybe the girl mistyped your email and I got it. Account verification. This one's dangerous. So a lot of account verification and activation links. This we can talk a little bit more about types of attacks we can pull off with this. Appointment confirmations, dental appointments, doctor's appointments, sales meetings, all kinds of appointments. Personal resumes and employment applications. Think about the amount of data that's on your personal resumes. Sensitive data. There's, even over 45 days, this is almost, almost one a day. Password reset links, loan applications and service contracts, tenant notifications, personal medical information, x-rays, all kinds of information, people's private health data, lease documents. I got a completed security clearance application form, complete with passport photo and 10 years of personal history. And finally, the most impressive one I received was, I don't want to reveal too much, but it's one of the largest labor unions in the country. They were in the middle of a draft negotiation with the government, and I got an early version, an early look at the contract before anybody else, basically, except for the lawyers. So some idea of what can be accomplished and collected in, again, just 45 days, just 12 domains. So let's talk about the exploit opportunities here. They're basically endless. Identity theft comes to mind, extortion, social engineering. I can gather personal information that people may not be, aware is out and available to others. Doxing, I can do account and credential theft, financial theft, impersonation. I didn't claim any e-transfers. I don't know if that would work. I'm not interested in trying. Impersonation. Once I know enough about a target, I can pretend to be them. And finally, I'm in the Army. I've personally seen people send things over a Gmail account. I've seen them send things over Hotmail accounts. Is there a national security threat here? Maybe. So how common is it? I was curious to look around. I only registered 12 domains, but there's a lot of squatted variants of these things. So I looked at 3 examples. It's by, not anywhere near exhaustive, but as some examples, if you look at gmail.com and you start looking at typo squatted variants, you'll find that there's 155 adjacent domains registered, and about 70 of them have active MX records on the domain. Outlook.com, similar stats. Yahoo, I guess, has been around longer, more highly targeted. That's a lot of potential for theft right there, and we don't know who's behind these domains, and I can tell you when I looked at them, many of them share the same IP address. So one has to wonder who's listening, who's receiving those emails. Well, one thing that's interesting about this, and this is an example of what you can do against a public email service, but what about against an enterprise? What about against a company domain or an enterprise domain? Can we do the same type of attack? And part of what inspired me on this talk was one that I saw at the RSA conference, where they used this as a red teaming technique, and one of the researchers said, hey, you know what, for $12, let's register the domain and just see what we get. And they got the keys to the kingdom. By like day 6 of the engagement, they received a mistyped password reset for their most sensitive database. They were able to change the password and log in with admin rights to the thing that the company most wanted to protect. If you want to see the talk, I highly recommend it. I'll share the slides afterwards, I guess, through NorthSec. I can probably do that. This link will take you right to the interesting part of the talk. Okay, so how can we defend against this? The first thing I want to talk about, as I alluded to it earlier, is encryption. I wouldn't have really learned anything, or at least not anything meaningful, if these emails were encrypted. They were all in clear text, and I could read them however I wanted. There was no S/MIME certificates in use. I didn't detect a single encrypted email in what I gathered. Awareness training is a really big one. So I was digging for stats because I started asking myself, well, what about digital literacy? Do people understand that this is possible? For me, it's shocking, but what about for other people? StatsCan, the most recent stats I could pull were from 2018, where they were looking at student digital literacy ratings. So in this case, 15-year-old students, only like in Quebec, I think Canada-wide, 38%. In Quebec, we're actually the lowest in the country. 30% of students reported being taught how to identify phishing or spam emails. You know, that's a pretty big problem. I think awareness training across the board, maybe in school all the way up into the enterprise, is really important. And then finally, DNS solutions, I think, solve a lot of these problems. So monitor your DNS. Take a look at what requests are happening. There's DNS firewalls, DNS filtering out there. Passive DNS is another interesting tool to detect things like newly registered domain names. There's a lot of research out there that shows if a domain name is new enough, it's probably malicious with a high degree of confidence. So don't resolve new domains. There's a lot of tools for this, Farsight security, domain tools. There's a few vendors here today. Flare Systems was there. They have a really neat platform that looks at a lot of this kind of thing. And then finally, if you talk to Dr. Paul Vickie, the guy who wrote Bind and maintains Bind for many, many years, or the father of the DNS, they'll tell you to run your own DNS resolver. It's really easy to set up. I know it's really easy to go and say, hey, you know what, get your domains from, or your IP addresses from 8.8.8.8, or you know, what Cloudflare, wherever you want to resolve your DNS, but take control back. It's actually quite easy. You can throw it up on a Raspberry Pi, play with it. And you can use things that are called DNS response policy zones. So if you detect domains that are targeting your enterprise domain, you can set up a response policy zone that says, hey, if somebody asks for gmail.com, well, send them to gmail.com. Give them the result for that instead. You can set that up, and you can do it in response to the things that you're seeing on your network, maybe specific to your domain or the types of traffic that's happening on your network. So DNS, big one. And then finally, some food for thought. You know, the question is this brought up for me. It was quite shocking. The first one was, is email an essential service or a critical infrastructure? You know, for the importance that it has in our lives, is it considered critical infrastructure? And if so, who's responsible for protecting it? Does this fall on the public email service providers? Does it fall on us as individuals, or maybe the root authorities in the domain name system? The second question I had is, can I automate the analysis? You know, I started getting a little bit uncomfortable looking at some of this data and tried to remove myself from it as much as possible. So can we do this kind of research in a more automated way that generates meaningful threat intelligence but also respects privacy? And finally, can we use similar approaches exploiting typo squatting against other services? There's really interesting research done regarding NTP bit flips. Some of you may have seen that research. The researcher that basically realized that I think it's every day, every 24 hours, a Windows machine checks in with time.microsoft.com. And he knew that bit flips were a thing and they were theorized, but he wanted to measure the rate that they happened at. And he registered some bit flipped version of Microsoft.com. And he got millions of NTP requests to his server in a very short amount of time. And then finally, man in the middle, monster in the middle. We'll make that a standard. Or reverse proxying against web pages and popular web portals. You know, there could be another abuse that's interesting to look at. Thank you.
working? Okay, it works. Thanks and good job for your first talk. Honestly, very good. Great results. So guys, again, if you can ask questions on Slido, I'm gonna take care of them right after. One talk left. We probably start in 5 minutes. Thank you. All right, ladies and gentlemen, welcome back to our panel of Red Team Block. So I'm going to start with a few questions dedicated to our two speakers, and then I'm going to go more to general Red Team questions if we have time. So I will start with you, Olivier. We had some questions about RDP. Of course, RDP is very well used in the industry. It's built in on Windows. You can use it on Linux. You can use it on Mac. The question was, are there better alternatives to RDP?
I would say wrap RDP in an SSH tunnel, but that might not be convenient. That might be a bit of a troll. No, I think this is the standard. It's really efficient. So there are some proprietary alternatives, and the problem is you need to control the server and the client. You need the flexibility. You need the deployment. So it kind of makes sense that it is in Microsoft's control. So it's a difficult question, and I think it relies on a lot of things. But like, let's say I would be, I don't know. I control all my computing. I don't care about anyone, and I don't need to, because let's say I'm CSC, something like that, right? Our secret service. Then okay, just use something else and enforce it, and make sure you audit it properly, because RDP has been audited a lot, right? But if you are anyone else than Secret Service, I mean, you must pretty much use RDP, and using something else, it might not have been scrutinized as well as RDP. So no, I think my advice today still holds, is wrap it in something else. Wrap it in VPN. Keep monitoring it, and maybe speak with Devolution. And I don't know I'm plugging a vendor here, but they really understand it, and look at what they're trying to do to make sure that it's secure. And if you can't do VPN, or if it's too clunky, too complicated, but there are also other vendors doing that. But if you want to avoid additional costs, I think just VPN and making sure that nothing is exposed is a good step. And keep patching. Keep patching.
All right, thank you. For Rolland, do you have insights on which type of domains, like big tech, large orgs, brands, that you got the most amount of emails from?
I don't want to single out any single provider, but I will say that in general, it's a numbers game. So the more keystrokes and the more attempts, I guess, to communicate with the domain name system, the more likely you're going to land on a typo squat. So the longer the domain, the more likely it is that there's a typo in it. And the more, in this case, emails are being sent, the more likely it is one of those is going to be a typo. So I would say think about the big providers that have millions and millions of emails going through every second, every minute. And typically, the longer the domain, the more likely it is there's going to be a typo in it.
Okay, yeah, cool. Next one for Olivier. In your research, I don't know if you read about MS Remote Desktop Services, which encapsulate RDP into HTTPS. Do you know if it resolved many of the problems you presented today?
I honestly thought that this was RD Gateway. So I think it is RD Gateway. Does the person who asked the question still here? Because if it is RD Gateway, then it was in my future work slide. So if it's not RD Gateway, then I want to hear about it. But no, honestly, I think this is so the remote desktop services. You can enable a gateway which encapsulated in HTTPS. And so for the NTLM attack, it means yes. But now, how have they implemented it? If they have implemented it by just layering HTTP on top of it, then as soon as I get to implement that in PyRDP, I'll have access. And if they haven't changed anything, and they have no reason to have changed the underlying protocol, it's just another encapsulation, I believe that our attack will still work. But right now it doesn't, because we need to do that HTTPS decapsulation. And to be honest, that code is so complex. The guy, are they still here? That code is so complex and hard to maintain that if I ever keep up with it, I might attack it, but I'll need other interns to do it for me because I'm not that bright.
Okay.
It's sad, but I'm aging.
So next question would be for Rolland. So you mentioned how to do typo squatting, but let's say you are being typo squatted. So what would you recommend to blue teamers in the room?
Sure, yeah, that's a really good question. I think the first thing is to be aware that it's happening. It's really easy to look around DNS. There's lots of good tools out there. DNS Twist comes to mind. It's a free Python script on GitHub. You can find it for free. There's a lot of web implementations of it as well if you're not into running Python. So just being aware that it's happening to your domain is interesting enough. And then you can start filtering for it and looking for instances of it. You can use tools like dig, NSLookup, and just see what kind of records are on that domain name. If there's an MX record, that's a red flag. Just being aware that it's there, and you can do a lot to protect yourself and your users from reaching out to that domain, but it's really hard to police everybody on the internet from looking for that domain. So I guess the next best thing is, depending on who you are and how much leverage you have and where the domain is registered, you could try to do a takedown request if it's a brand infringement. I think the key is first understanding if somebody's doing it. Simply, I would recommend looking at a tool like DNS Twist. Is probably a good place to start.
Okay. May I add an additional question? Do you know if they are provisioned to, like, so we know that you can't purchase like Nestle because it's a brand that is a trademark, right? But do you know if typo squatting kind of falls under the trademark infringement stuff?
I'll say that from what I've seen, there are definitely efforts out there to police it, but I think it's on a registrar-by-registrar basis. I think it's going to depend on the TLD. There's a lot of factors at play, but generally, if it is being policed, it's not being policed very well. I think it's incumbent on the trademark owner to actually fight to go and have that domain revoked. And they do have a lot of power. There's a lot of levers in place for brands to protect their trademark that way. I think it's a mixed bag about whether or not you'll be allowed to register it in the first place.
But so you, sorry, Martin, you typo squat pretty big names, right?
Yes.
And you got nothing. You
No
like
problems.
no one kicked your door, or you know.
Not yet. After the talk, maybe we'll see what happens. But no, not yet.
For 45 days, so.
I'll say that those domains have been registered and active for a lot longer than what I started working with them.
Okay.
But there's a lot of conversations now about what do we do, what's the responsible thing to do with the domains. So I'm open to discussions. If anybody has ideas, I have ideas about it as well. But yeah, so far, got away with it.
Okay. I'm gonna jump. I had a pocket question about legal concern of your both research. So I'm just gonna jump on this question. So are there legal concerns about doing typo squatting on a specific company? Is it considered as attacking this company?
That's a really good question, and I've lost a lot of sleep over it recently, especially knowing that I'm going to present it in a very public forum. I think yes. I think depending on what you're doing with it, I don't think owning the domain is necessarily enough to call it a criminal act or an illegal act. I think depending on what you do with it and how you use it, maybe. Is it illegal to steal mail from somebody's mailbox? Is this the same thing? I think there's a lot of questions about it. I think intent is important. If I'm in front of a judge and saying, I really wanted those e-transfers, that's one thing, but if it's for security research, I would like to think anyway that we have a society that wants us and encourages us to point these things out and try to correct them. In my case, it's a risk I'm willing to take. I'm not going to share data with anybody. I'm not going to talk about personal information. And I would discourage anybody from trying this. It's already been proven. You can do it. You don't need to do it at home. In the case of a red team engagement, a great tool. I think awareness is probably key. So I think, yeah, it should be illegal, but how do you enforce it? How do you police it? Those are the bigger questions.
I agree. And Olivier would like to add on this? No?
No, thanks for asking, though. But it was a very good question, and it's a very difficult situation. I agree.
I agree too. Okay. I work a lot with the cyber threat intel team, and most of the companies base their security prioritization based on threat actors with documented activities. So I was wondering if you have, for your both research, used such intel. Have you seen attacks like that been made by, for example, ransomware or publicly known groups in their campaign, in their TTP?
Want to go first?
Go ahead.
Yeah. So recently, the Okta breach, which we heard about, was RDP. So yeah, I removed that from the slide, unfortunately. But I mean, it was just a screenshot saying, "Hey, RDP is important, Okta." But yeah, no. So RDP is attacked, and there's a lot of IPs out there, and some of them are my honeypots. So you know, I'm increasing the number of exposed RDP systems. But it's used, and it's a low-hanging fruit, and it's brute forceable. So of course, and you know, the ransomware groups, they're going after a low-hanging fruit. But in the Okta case, they purchased credentials on a forum, and then you leverage them. And there are RDP credentials for sale on forums. So yeah, yes, it's real, it's used, and it's not gonna go away. But I mean, stop exposing RDP.
In my case, what I can say for sure is that there are a lot of, I mean, I spoke about it a little bit in my slides. Just from the 3 sample domains I looked at, I think it was over 400 different domains with active MX records that were nonsense domains that don't have real services that I'm aware of behind them. The bigger question is who's behind them and what are they using them for? I think the part of my talk that was most interesting and I think impactful for me is that it's a passive technique. I can stand up a mail server completely anonymously on a VPS anywhere in the world, and I can receive these emails. What I do with them, I think, you know, as an attacker, I think that's something that needs to be researched. Maybe canary tokens and sending things out to these addresses and just seeing what happens. I'm really curious about that question as well. And I don't know who's behind them. It would be interesting to see. I don't know of any known cases other than other research I've seen on the subject, but I don't doubt that it's happening. Would be my take on it.
Okay, thank you. Quick question for Olivier about RDP. Do you know if two-factor authentication or multiple-factor authentication would mitigate will mitigate what you just presented this afternoon?
So I think it depends on how it's implemented, and I haven't looked at implementations. I would be interested in knowing popular free ones because I don't want to pay for a service to just attack it. But let's assume that it's a pin added at the end of your password. Then the net and TLM capture would work, but the hash would potentially be harder to crack unless you know that is the NIP appended, and then you add that to your cracking rules. So this would still work, but is this how they implement two-factor for RDP? I don't know.
Okay.
I'm sorry.
No, but I mean, I needed to ask, but it's fair. I think it's a fair answer. Now we're going to talk about honeypots because it's a field that is growing in the cybersecurity industry. There are some companies that dedicate, they really make products that make it easy to deploy honeypots. So I think PyRDP is a great project to build honeypots. Probably there will be probably something to do with your work, Rolland. But do you think it would be a great idea to use PyRDP for honeypots and literally have, let's say, sophisticated actors with breadcrumbs, with you put some hints, you put some password on the network and have them reach your server and monitor it? What do you think about that?
I think this is what I'm doing right now. No, but the problem is that like lately we had actor interact with our honeypots, and some of the attacks, they kind of stopped doing them. And then I was like, why is so? And looking at the replay, I was like, okay, they're transferring a large amount of files. So I reproduced it, and it turns out we have a bug. So the transfer really slows down. I'm not sure quite what this is, but I think that we're so eagerly fetching client-side files that even on a stat system call, so the equivalent of a stat system call, but like I want to know the size of the file and I want to know the permissions, for example, we are grabbing the file. So if the person mounts a drive with a lot of stuff on it and then drops with thousands of files, drops a folder, well, Explorer.exe will do a stat on all these files in order to just show how long the transfer will be. But PyRDP in the middle is doing just like whoop, 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 whoop. I want all of them. And so we have issues to work on regarding that. So unfortunately, I haven't caught, but we know, so we've seen the miner, crypto miner stuff being transferred and stuff like that. But we do have scalability things to look at. Also, for example, like on a typical week, we'll have like 17,000 replay files to look at. So I really have a triage problem. The problem with those replay files is that they are all unique and binary, but because they are all unique, and even if you hash them, they're all unique, because they are timestamped in that protocol. So I need to find a way, and Lisandro was working on that actually not so long ago, but we need a way to factor out all of the timestamping and the bits of the protocol we don't care about, and then focus on the interesting things. Because the other thing I want to do with those honeypots, more so than finding threat actors, is finding also attacks like potential 0 days or blue keep and stuff like that. We do have blue keep detections, and we do have detection for a couple of them built in. But like, why did the protocol fail, or who is this? What tool is this guy using that is creating this kind of interaction at the protocol level? So we're all looking at that, but it's a shit ton of work, and I have a small team, and we're not making money with any of this, so this is why it's slow.
Makes sense. All right, I'm gonna jump into more high-level questions about red teaming, the field in general. Just do your best, guys. I think it's gonna be fun. So my first question would be, based on your work, what do you think is the cybersecurity industry's best next move?
That's a really kind of big question, I think. The next best move for the cybersecurity industry, I think, is train more people. I think there's a lot of need in cybersecurity, and not necessarily experts of a super high caliber, but there's a lot of work and just grunt work that goes into research, whether it's going through honeypot files or looking at stats and email collection. And there's a lot of work that can be done, and I think there's a lot of interest in the field. And I think hire more people is probably the first thing I would say is the next best thing we can do. Train more people.
I'm glad you finished with train, because hiring more people, it's tough right now. Okay, I'll try. This is super accurate and good. I'll try to go in a different direction. Okay, so during the pandemic, something that I was not doing a lot that I started doing again is play D&D, Dungeons and Dragons, and I'll link it with cybersecurity. So one of the first things, not the first, one of the latest offerings of my company is tabletop exercises for threat simulation. And so what I liked when I heard that is that we are now in a state where we are assuming breach. We no longer think we're going to protect them. We are assuming breach, but now we are testing you. How are you going to react? And what's the drill? Do you have plans? And this can be done in a simulated way without much cost. And what's interesting is that you can go deeper and then validate it one day. We'll have red teamers validate the plans. But for most organizations, and we deal with medium-sized companies and smaller companies, but for most of them, sitting down with smart people who play some corporate D&D, okay, let's simulate like, oh, this user received an email and clicked on that link. What's your visibility? It was downloaded. What do you have on your endpoint? You know, and then you just go through this mental exercise, and then eventually you say like, oh, the computer is getting encrypted. What are the map drives that are, you know, accessible to that computer? And you just, you know, played. You know, you even could roll some dice if you want. You know, like, oh, the N drive was encrypted. I thought I had 8. You know, I mean, I'm making this shit up. I know. I don't, and I'm not doing the service. It probably doesn't look like that at all. But to me, it sounds like interesting. And then you can, you know, this is very effective and low cost because it's just a long half-day meeting of simulation. And then imagine the client has a long list of stuff to look at. He was like, I couldn't answer half of the questions. And so then you come back and then you iterate. So I think we are at a maturity level where we can get a lot done and effectively done to get better by knowing how long to spend and then buying the things that will protect us, you know, but not buy first because you have CapEx, you know. Use humans to buy intelligently products instead, and I think this is where we should go.
Awesome answer. I was going to talk about purple teaming. I think the industry really needs purple team exercise. They shouldn't pay for big red teams just for, you know, having a surprise and a big report that show them that they have some mistakes. But I really like your answer. I would love to be invited to such a Dungeon and Dragon game. So another question, not an easy one, but anyway, what's the best way to use a red team for companies? Again, based on your work, if you can, like, should it be to shake, to rattle the company's cage to show that security is important? Should it be to ramp up the technology, the process, the humans? How do you see red teaming in the industry?
It's a really good question, and I think a lot of times red teaming, penetration testing is misplaced. It's the sexy thing to do, right? We're going to hire some hackers and they're going to show us how they broke in. I think it's often mistimed or maybe not conducted in the right frame of mind, in the right context. You know, we used an analogy earlier. If I take my 5-year-old and bring her to the Taekwondo arena and I say, tester, you know, what's the result going to be? I don't know if it's a very productive exercise to just do red team engagements without first taking the baby steps before you're ready for it. I think purple teaming is a great use of red team assets to work alongside and train blue teams, train against each other. And I think that red teams are a great validation tool, and I think when you reach a certain maturity in your security organization, that's when a red team is really valuable. But I think you can start with basics and not necessarily need a red team to introduce you to the basic best security practices all the time. Would be, I guess, my opinion on that.
Thank you.
And it's also a kind of a bloated term right now. Like, everyone's a red teamer. I don't know, man. I'm sure you're not. And if you have a scope, are you really a red teamer, you know, type stuff? But I think this is the definitions, and we don't have. Do we have a standard bodies that defines like what are these, or we're just
the
like?
The problem is that there are many definitions. If you follow SpectreOps, they have their own definition of red team. If you read someone else, it's something else. I think it's a language abuse. So red team is usually used for offensive security or just pen testing, ethical hacking. In my opinion, red teaming is really about you know, training technology process humans. I follow more the SpectreOps definition, so it's about simulating threat actor based by using several TTPs to create training opportunities for a blue team. But in the industry, it's used for anything. You're right. Yeah.
Good answer, Martin. No, but I just want this to be clear, right? He is the one who should answer those questions. So this guy manages a red team at a large institution, and I am a director of research. And what about you? I didn't read your.
I like red teaming stuff, but I'm not a red teamer either. I'm interested in it, but I'm definitely not at the caliber of either of these guys. But I don't need to be to pull off an effective attack either, which is sort of what I was getting at. Is we don't need the best hacker in the world to prove that you're fundamentally insecure. So I think there's a time and a place to conduct these exercises. And again, my white belt 5-year-old is not going to stand a chance in a sparring session against
Mike Tyson.
Yeah, exactly. There you go. So I think context matters and time and place, and asking yourself, why are we hiring a red team? For what? To embarrass us? Or are we doing it to actually improve our security culture? I think that's what it comes down to.
All right. That's going to
So
be
the next red team questions goes to Martin directly. You want me to read it?
Okay, I'm going to try.
Or we'll have like us and then you. That's nice, I think.
Well, I was going to say it's my last question. We have just a few minutes left, but I will try to answer. And it's like it's the worst question because I know it will raise a debate. But
nice.
It's about red team, the RTOST debate. So red team open source tools. So a lot of people care about sharing. They say that sharing is caring. You should publish your open source tools. You both have very awesome research. It can be good. It can be used for the good, but also for the bad. And so, what do you think about publishing all your work? You said, Rolland, before that you wouldn't publish your data, but maybe you will publish tools to accelerate this work. So, what do you think about this debate, and would you publish your job?
I'm a little bit biased because I'm a net beneficiary of open source tools. I'm not a net contributor. I think there's a lot of value in open source, but I do respect the fact that people will spend a lot of time developing techniques and developing tools for themselves. Personally, I'm on the side of open source. I think if you discover a vulnerability, you should disclose it in due course. I think putting tools out there that people can take advantage of, they're great learning tools, as you say. I tend to be on the open source side of things. But again, I'm biased because I haven't spent hundreds of hours developing a tool that may be obsolete 3 days after I release it. Yeah, that's my opinion.
You want me to answer first?
Oh man, I'm a kind of a philosopher in my times, and I think we lack perspective. Like, piracy existed and was authorized or happened without no one doing anything against it, because it was, all countries were separated. But then eventually the pirates did so much damage that the countries had to get together and create this international zone and then fucking kill them, get rid of them, because they were losing so much money. So I think we're at the era, like basically we're creating firearms, okay? I wouldn't, this is not Gosegur's opinion of anything. This is my own here, okay? I think we're creating firearms, and I don't think you're allowed to create firearms right now, right? I don't know, to be honest, I don't know. I know people try to 3D print them, maybe we're allowed, and in Canada and the US it's probably different. But I think that we lack this perspective, so for now we're doing it, we're having fun, but eventually, 100 years from now, if climate change didn't kill all of us, we will look at this and be like, these guys were crazy. Like, they were allowed to create destructive tools and put them online, whereas the defenders were not sharing, right? That's the asymmetry of it right now. And now the blue team folks now are sharing, Twitter accounts with IOCs automated and stuff like that. And there's a lot of blue team talks, good blue team talks now. When I started, that didn't exist. Blue team, we were kind of like, this must suck. You look at IDS all day. I'm fucking the pentest badass, Now, blue team is sexy, which is good, which is very important, which is part of education that is going on. But they still have sharing problems because the organizations that they are in don't understand that they should share. It's not the fault of the blue teamers themselves. It's the fault of their organizations. And so this asymmetry is not helping them. And so the red team, they collaborate, they create Patreons, they have tools. You can now have like paid for offensive tooling that eventually becomes free, like the Porchetta Industries guys, which are very good. They're actually like really, really good with RDP right now. I'm following all that stuff. And at one point, maybe we'll be like, you know what? And it will be an incident. Like something will get hacked that it's so fucking bad that we'll be like, okay, you know what? It was a bad idea. The whole thing of like, because they'll use fucking Cobalt Strike and stuff like that. And so, and sorry if I'm talking against you. You'll have time. You'll be retired by then. But I don't think it makes sense if you think of it from far enough. And last thing, I told you I was a philosopher, okay? So think about this. At one point, fire protection, you had to pay for it, okay? You had a badge on your house. It was like opt in with money. And if you didn't have that, the fireman would come and water the house that had the little badge, but the other house would burn, right? So eventually it became so much of an issue that it was nationalized or municipalized. I'm not sure which, but like it's part of the things that we need as a society. And so I think eventually government will be so pissed off that it costs so much money to so much companies that there will be like, AV and, ISP protection and security in general will be mandatory, like built in the things, and which means that, and if it's regularized, it will mean like anything trying to be against that will be outlawed. Maybe. I don't know. I'm just a philosopher. I should write a book.
We just need to finish on that. That was an amazing question. So thank you, everyone. I hope you enjoyed. I wish you a lot of flags this weekend. Pray with me for a Windows track, maybe. It would be fun. And that's it. Thank you, everyone.
Test. Okay, so just before you quit, we do have a feedback survey. So if you want to give comments to the conference, go to me or just go to the survey. We have billing there. Thank you very much. We'll send it through our social.